So this one's a maybe. I know. Hitting you at the gate with a maybe. All right. So this is the basic premise of how to make a factorial easier. So whoever came up with factorials knew that had to have known because it's a sequence. Let's say it was like a factorial of 10. 10, 9, 8, 7, 6, 5, 4, 3, 2. Yeah, right. But except every one of those can be easily broken down into chunks and then added. But see, it's like you don't maybe understand what that would mean because it's like, no, you can't do like an 8 times 7 and then add that. That's not what you can do. It has to be sequential, right? So if you thought that that's what I was going to go with, no, you should probably be quiet and let me talk. So there's that. But they had to know it's a wonderful type of algorithm, but to describe this is annoying for what it's worth. Because it's like, how much do you know about sequential dimensional ordering? How much do you know about this? Which is like how they describe it in like Michio multi-dimensional math. And I'm like, it's not what that is. We just program it like this. That's all that is. It's not hard at all. It's really simple. It's called a breakout algorithm. It's literally all it needs to be. It's not even a joke. Okay. That's literally what it is. It's like this thing can only be from this with this key, right? And so then it breaks out into becoming this thing, right? That's all a factorial is that it's already doing. It's like start with this and you go backwards. That's the sequence, right? But see, here's the thing: if you walk that backwards, right? Walk it backwards. What's the key? Yeah, breakout algorithm, right? What's the prime number, right? But it's not a prime number. It's like, right? We're not talking about that. We're talking about this in factorials. You can work out what the end result could possibly be based upon only a few series of the first initial numbers. If this leads to that, that must mean this kind of thing. That means it will ultimately result in this basic number. But that's a layman's way of putting it. So, what does all that mean? Right? And it's like, so dimensional fucking sequential order is what they use for math. It's literally what they're talking about. It's like the dimensional aspect of a fourth dimension result. Okay? In a fifth dimensional view, you understand the ordering of this third dimensional moment for every two-dimensional section of every one of these numbers, with the one-dimensional each individual number. Which is kind of rough, okay, to phrase it as, because that sounds like really big talk. I can't possibly understand any of this. I'm like, behold, the programmer enters the fray, and any story writer of any kind. I already have the plot outline. I already know what really realistically I'm going to have the ending be. I'm going to fill in some details, basically, right? And so a good way to put it, instead of a table, like I have to memorize multiplication tables or something like that, right? It's like you don't have to do that. That's stupid. That's a bad way of doing this. That requires a bunch of memory. You don't have to do any of that. The best way to understand this is whether or not, and this is the little joke, and then I actually fucking like go to the actual thing. If it ends with the zero, then it's always zero because that's how your math works. Boom. But it's always zero. Doesn't matter if it's factorial, it still ends with the zero. So you're multiplying all of it with zero, so it's obviously zero. Some mathematicians really like that type of joke. Of course, that's not what factorials do because it's only allowed to go to one. Meanwhile, uh-huh, that's the joke. That's the joke. Anyways, calm down. factorial sequencing order of operations is what we're talking about here. Instead of breaking it into parallelization ideas, you don't really need to do that. You just need to take a basic premise of a certain number of these numbers, which is, I guess, the kind of thing that you were talking about for the breaking out kind of thing, but that's not what that is. Okay, so like I have to be really careful. Word choice matters here. Okay, like you can't break any like five sequences. You can't do that, and then you can just add it, right? But here's the problem: you can do that if you know the right sequence. That is 10 and 9, 9 and 7, all that. And then you'll resultively have the same answer. But in order to know that sequence, you have to understand how many numbers in the sequence there are. That's how it breaks out. So that's the key. That's why I was doing the whole key thing. It's like a prime number. It's a breakout algorithm. It's like yeah, but it's the factorial. So if you know the number of in the factorial that you start with, then you know that there's a sequence within that factorial that absolutely just means you need to hit this many numbers multiplied this many times, and it'll resultively give you the exact same number at the end. You don't have to do every one of them in sequential. You can just do this one this many number of times, these ones this many number of times, and you'll get the result of answer. Perfect every time. But it's always tied to the number that is the factorial. Let's say it was 52. Like 52 is like a big one, right? 52. There's 52 numbers. Right? But it's not actually. It's a very few amount of numbers, actually. It's only 52. It's not like Googleplex over here, just fucking walking around being Googleplex and shit. Big, strong Googleplex. Oh, boom. He just walks and then everything changes. No, I will not do that math. The moment you hear Googleplex, it's like, yeah. What's up, Euler? I'm not going to do that. Anyways, 52, right? It's like, right. Of course, the answer is different depending on every factorial, except every factorial ends with the same answer, right? So it's like every factorial has a unique sequence. Behold the breakout prime numbering sequence. If you know what it is, then there's always, like solving a Rubik's Cube, an algorithm that evenly gives you exactly the right result of answer. You can always check it too by just brute forcing the factorial. So once you know that, then it's like they'll emerge a pattern. That pattern, once emerged, for every given factorial, becomes something that you can teach people, which now means you can do factorials incredibly fast, easily, because you know it's this 52 or 51 or 902 or something. It doesn't matter. They're all the same. They'll always work out exactingly like that. Exactingly. But see, like, that's the thing. In values is what you end up going with because it's a random, like, asterisk, like we used to use in programming. But that's the thing with programming is like there's a existence of, yeah, fuck doing the brute force one after another, if then do the next, then the next. No, fuck that. No, that's stupid. I'm not going to do that. That's a lot of work. Instead, I'm going to hit upon a pattern over here, and I'm just going to give it like every one of these answers, and I'll just go check to this one. It's literally what it is. It's like, this is the answer, check to that. Literally every time. But that is for standard, rational, whole, all that kind of number. It still works though for fucking like square root of 2 and so on. It does still work. It's just like a different type of with inside of that kind of thing of sequence, right? That works that way, breaks out that way, right? But then it's also like, behold, the way to solve pi is to get the right sequence after the decimal point. You don't understand, maybe, perhaps, maybe. Give me a second. If you get the right pluses and minuses and parentheses and some, Additions, no, 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 no. Multiplications. My dear, I want to interrupt you as I'm trying to comment immediately and pretend I'm you. No, all of that, there exists a sequence of numbers that, when properly done, solves all of pi because it's infinite, which means I can absolutely for certain say that. I can solve any and all irrational the same way. Doesn't matter what it is. What is that? Squares? I can do it. But of course, that's a brute force method, right? I mean, you have to understand that there's always a sequence. There's always going to be a pattern of a sequence, right? But that's the thing with the number of a factorial. It's much easier to do it that way versus like it could be, some girl Googleplexes in. We don't know. Yeah, get to work, I guess. Crunch those numbers. Okay, sure. Talk to you too. Yeah, no, exactly. Anyways, factorials though. Back to this. There's just the same thing, right? So I don't know what factorial of 10 is, because I haven't done it in a long time, and I don't really just remember everything off the top of my head all the time. So, anyways, whatever that is, it's much easier, of course, and the more it's an exponential. So if you don't know what exponential means, a simple explanation is it gets bigger faster the more time goes on, which is the fourth dimension. So it's like, right, which is why it's a breakout algorithm of the fourth dimension in a Michio Kaku kind of style with a fifth dimensional observational point. Anyways, what that means though is it's a sequential. It's dimensional sequential. So you have to understand that it's going to exponentiate. So of course that means you simply go this many numbers means this many numbers of chunks, which means this many number of chunks this many number of times. And behold, you arrive with these ones that you have to do it for because that's the patterning sequential. So it's like that's dimensional sequentials. So it's like you know these numbers, right? And so it's like in those numbers, this number, that number, that number, that right? You multiply each one of those that many number of times. You use these ones like this because of this number is the factorial. So then how do you determine that? And therein lies the pattern seeking. You have to pattern seek. You're a pattern seeker, you little fucking retard. You're a human. Seek the pattern. Go seek the pattern. The basic premise is it's different for every one of the factorials. Let's do 4, I guess. Right? Let's do 4. 4 is 4 times 3 times 2 times 1, which who gives a shit about the 1 or the 0? So, right? Except you actually do have to do it because that's what the algorithm is. You still multiply that number by 1 and then you add it. Or is that different for the factorial? Which factorial are we doing now? Are we going to make it so it's not relevant? Or are we going to make it so that way it is relevant and you still add it? Which type of programming algorithm are we going with for this given mathematics? For these given rules? Shut up over there. I'm trying to think about why that's wrong and you should just use it as 1. But actually, technically, sometimes we do just add it and then after we multiply it by itself and then we basically double it at 1. It's a bit weird though. Wouldn't that be 2? No. Granted, this is different math at that point because you have to understand math turns into, all right, 1's adding it. Sure. Okay. 0 does nothing. And then 2 is this. Okay, you're not just multiplying it by itself, which is what the symbol is supposed to mean, apparently, in math, but that doesn't make sense. Then multiply it by itself twice. Then you multiply it by itself 3 times. But you're talking about powering, right? Like to the power of exponentials, right? Oh, are we? Which one do you want to do? Since we're talking about exponentials and I got your brain in the right way, kind of arena, which one do you want to do? Right? Now you understand how exponentials is like, no, 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 we only wanted to add. But we need it to be multiplied. Right. Right, yes. Yes. Okay. So we add it this many number of times together is what this is. And we multiply it by this number. So what you're saying is we add it this many number of times and then we stop. That's what you mean by multiplication? No, I, I do actually. That's exactly what that is. Only ever that. Oh, really? So one, I add one to it. No, I multiply it by itself, and then I don't add it anymore. Oh, so you broke down your little programming really quick there at the end, didn't you? Look, the one doesn't make any more sense, does it? Multiply it by one itself, right? You want to multiply it by itself, or do you just want to add it by itself if you're multiplying by one? See what I mean with this? You're only adding it this many number of times by itself, right? And it's like, right. One. So I'm doubling it. Ooh, okay. I'm starting to see a problem with your mathematics. Anyways, exists a pattern, of course, the factorial, right? It's like, oh, so the factorial is, of course, an exponential, which means, let's do, what is that, 12 plus, you know, double, so it's 24. So, right. But no. Wait. Give me a second here. So we're not doubling it again with the one. It's just going to be a standard and don't even think about it. Is that how we do this now? Okay, we're doing it that way. So it's 24. Lowest common denominator there is 4, technically actually 5 though, because there's a 0, you gotta add the 0. Just, even if you don't use it, it's still there, still exists. Starting alpha is the point where all things are. Yes, but we don't think about that. Oh, really? It seems like you are selective in your semantic pedantry of the algorithmic variety of how you teach students. Anyways, so it's like, all right, it's 24, right? There's a lowest common denominator, right? It's like, yeah, no, that's cool. But except you actually have 5 numbers, but of course you want to get rid of the 0 because you're not really using it. So now we got 4, right? Now, easy for this one, sure. Except, is it? We have several lowest common, and factorial means nothing. But what am I doing? Getting you to seek a pattern. Because I'm not a pattern seeker. I don't do that. I am above all humans. No, you're not. Not even the slightest. But you do have 4 numbers, right? So you know the answer is going to be 24. That's what it should be, right? If you did it well, right? Except, is it always something for the same? There's 20 immediately times 3 exponential for a 5, right? That's 60 times 2, which is 120. See how fast it changes? See how fast, right? It's like in 5, right? 5 numbers. I got 5, right? Right? Except I didn't do that. I only really technically did 3. 3 numbers. That's correct. For 4. And then technically for 5, you did 4, right? 120, I did 4. You're starting to see how it works out every time. There's always a sequence of numbers. This many of the numbers, right? It's like 125, 4, 3, and 2. Well, there's a few different ways I can make that. Oh, absolutely. Well, there's technically 6 numbers there, right? We're going to do 4 of them, correct? Yeah. So what does that mean? If I only did 3, there's technically 4 numbers, or 5 really, right? Right. For 24. Are you not getting it yet? It's probably normal, but there's always an extra 2 that you have to add on to it. And if you happen to know the number that's always there, and you add that 2, you'll end up understanding how exponentials work, right? It's like, why is that something? It sounds like you said something that's profound, but it's not. All you did was say that you didn't explain it. And I'm like, right. But certain mathematicians probably did because they can think dimensionally. There's a multiple sequential dimensional situation going on here. If you know about those high level maths, great. Then you understood it perfectly. I don't even need to say anything anymore. If you don't, though, I'm going to have to explain it for longer. That's fine. That's the point. Now, 0 and 1 usually is whatever. It's 2, right? 2 numbers, sure, whatever. It doesn't really matter that much because exponential. It's like, well, you start with the first number, right? And then I was like, well, there's 6. And it's like, wait a second. What would happen? Just give me a second here. What would happen if I use that very same sequential ordering for 6, right? But I started off as an idea. Okay, just hear me out. We're going to multiply it by the largest number. That's 6. For the very last number, that's 1, technically speaking. Right? Actually, it's not because it'd be 0. Bingo. And we got 5. Right? And it's 12. Right? It's like, well, no, I mean, I'm not going to use it for the 5. Right? Well, you wouldn't, right? It's like a reverse factorial, right? Is what you're thinking of, right? Like, yeah, but that does actually kind of get you somewhere, though. Not really that far. But I want to make sure to shut down people that think that would be something to do. It doesn't really give you much. The reason why I'm talking about it as 4 numbers and 6 numbers is because that's actually 10. You have to add those. That's the order of operation. That's 10. Right? You add them every time, no matter what. That's the first real step you do. Then, when you know about the pattern, you end up doing a basic bitch. All right, wait a second. So that would mean I can exponential every single time. The first number, this many number of times. The next number, this many number of times. And I only need to do it based upon when you add these 2 numbers together, the resultant number, right? Right? You have to know, we're talking about 10 here, okay? They probably already clicked off. Probably lost them. Already, like, no, this is poppycock. What does that number have to do? You're going to move on. Like, no, it actually is worth the effort to learn about the 10 and why it's a thing. And it actually relates algorithmically because that's how algorithms work. That's how equations, you did your quadratic formulas. Well, this is another thing that's the same. This is a way to do factorials quicker, easier. Same thing. It's a formula. It's an algorithm. They're all the same. So if you know about that, and you know about that 10, you're going to put it in the front like a quadratic formula. Oh my God. And then you're aware of how many times, ultimately, I have to explain that differently. Let me see here. Because it's like, well, no, it's going to go over, right? And then you multiply it by 10, right? No. So that would be wrong. I mean, I'm doing my own math. Those are the no wrong order of operations. You don't do that. So that's probably not the right way to put that. Although I do put it in the front, but then I use it for something else. So I take like the very, you know, doesn't matter. Point is, you multiply it by 2, and so you're basically going to take that 10 and then you divide it by the number, and so there's 5 2's in there, right? Right? But it's like, right, the first 5 is 25, right? And then you have to do it differently where you use the next 2 numbers. But this is only for 5, okay? It doesn't work for every one of them. There's a genuine pattern for every single one of them. That's the real table that you have to learn, the new table of multiplication that you have to learn, right? Because it'll work. But anyways, I'm gonna move on. So you get that, you get 25, right? Okay. So take 4 and 3, right? And it's like, right, you're gonna do it twice. That's 8 and 9. Oh, I'm sorry, 6. 8 and 6, which is 14, right? Then you have a 2 there. Multiply by 2. It's 32, right? You're 25 and 32, right? We're not done because we have, shockingly, all these other 2's. What are those? What do those mean? What do all these other 2's mean? I've only used 2 of the 2's. I have 3 more 2's. All right? Cool. Sweet. Like, I got 32, right? It's like, yeah, 25 and 32. Which, gotta do that basic bitch calculator math because I'm actually kind of slow. That's 57. Anyways, 57. A stupid, astoundingly weird number, right? It's like, right. We got 3 2's. Three 2's, right? All right. We have a 1 there, right? This is where my math comes in. It's not even a joke. It's not. I'm really not joking. 1 is really just multiplying by itself and adding it. Okay? That's a thing. That's what this is. Those 3 2's become very different, mostly just because 32, and you got it, right? Okay? You have to do something entirely different once you get to 57. I'm gonna have to actually like write this down so I can form it, so that way I don't just be a dick about it and actually give you it properly. All right, after discussing it with myself for a long period of time and whatever might be there out loud around, I'll tell you, yeah, we're going to change this. We're going to change how it is that we're doing this so that way it's far easier to understand and you might actually use it and it's way better for you. Instead of, well, the sequential, the 10 is still always what the case is. And the reason why I wanted to do the lowest denominator, like I was priming you, is because the lowest denominator is always going to work best. And however many times it goes into that, that's how many things that ultimately for the pattern that you're looking for will work out to be. It's a really easy, simple method of always knowing what the pattern might be for any given factorial. But there are several different ways of using those 2's, right? That can ultimately resultively get to 120 for a factorial 5. As a result, it's like, yeah, I don't really want to give you a shitty, terrible sequence and pattern that is annoying as fuck and you'd rather just constantly go down the line. I want it to be fast and efficient for you. And like while I was trying to do bombastic and all that, because like keep your eyes on who wants to listen about math and everything, right? It's like, well, this isn't going to work for you. So this is a bad way to go about this. You got to get rid of the 5 squared and the 4 and all that fucking shit. Just fuck that. Because it's 57 and it wouldn't really be worth it, really, truthfully speaking. Right? And so the sequence is usually consistently just a squaring of or grouping up of several things for whatever the given number is. So it's like you go from like the first and the last or the next after or something like that, right? And then you add, and then you'll either square them or multiply them this many number of times, right? Which is what the sequence is about. So like there's 10, right? Two or five twos, right? And so like five twos means you can usually get it done by going with five. And if you know about five, then it's like, well, it goes into 120, so that's easy as fuck. You know, you already have 10, right? So it's like if you already know what 10 is, you already know about the two, then it's like 10 times itself twice, and then it's got to be a multiple of five. And it has to be above it because of course there's still more. So like then you end up going, well then it's 120 because it's simple to understand that. Because that's how our brains immediately go, oh right, we're in the ballpark. So then it's like probably this. Right? But like that's not gonna fly on like a fucking math paper, right? So they don't do that. So you can't do any of that. So it's like instead it goes to five, you have a 10, you have a two, right? And it's like, right, right. But you have to also remember like it has to be repeatable. You can't just like, you know, that. So it's like there's several ways I have and they work every time. But it's like, what does it matter? And it's like, well, no, it depends on like how ultimately you can get it done for every one of them. And it needs to be simple. And if I teach you the simplest method that's always going to work, then that's the best one. But if I just tell you a whole bunch of ones, because like there are a bunch of ways to get to that number, because you have a bunch of numbers here. There's a fuck ton of them. I can just move a whole bunch around, do the right sequence, and it'll always get you the right answer. That's the problem with it, right? So it's like, I don't know. I'm trying to remember the basic one because it's like, well, 10 and 5 and 2 is the easiest, fastest mnemonic, right, for a factorial of 5, right? So it's like 5 and 2, that's 20, right? But not really because it's 10, but you have to add the 10, right? Right? And then it's like, well, you already know that if you ultimately break that down, there's five twos. So it's like, well, that's 20, right? It's like, right, right. And then there's technically six numbers, right? But there's also four numbers, right? So then the mnemonic becomes instead, it's 5, 4, 20, 20. Then it's like 4 times, which would then be like 120. 20 times 4 is 120, right? Except it's not, right? But see, that's the thing, is it's 4 times 3 is what you immediately think of, most likely, right? But it's like, that's because there's already a 2 sequence here. If you didn't understand that. Remember the 10? And there's 5 twos? It was like, well, the 5 was it, and so I've already multiplied it by 2. That's 1, which gives you 10. Then I multiplied it by 10, right? But I didn't. Instead, I actually just added. So misspoke there. But I added it by 10. That gives me 20, right? And it's like, I have 3. Well, there's 4 numbers, right? And I have 3 twos left over. It's 4 numbers in the sequence for the multiplication, and I have 3 twos left over, which is 3. So as a result of 3, 4 times 3, then I get 120. Because there's 20. There's 4. That doesn't really work with people because it's like, where the fuck, what? So it's like, right, now I have to do the basic bitch thing of like, so there's 20, right? Yeah, right, but there's still 3 twos left over, except really realistically, what are we doing? Other than saying we multiply 20 by 3 times, right? It's like 20 by 3, which is 60 3 times, this is 180, right? And it's like, that sucks. But you know what will get me there? If I just understand 10 times 4 and then I add in a square. See what I mean with the whole, I can make it work with multiple things. And so it's like, that's not easy or simple. So instead it's just like, well, if I just look at the 10 and I look at the 2 and I look at the 5, then I already know where it's going to go for me. Like, you know what I mean? Like x plus 2 equals 4. Right. And it's like, well, yeah, no, x is 2 then. It's like, oh, yeah. Right. And so it's just like, right. So there's multiple ways of ultimately making this occur, which is the problem I'm having. Because it's like, it's always the lowest common denominator that you want to use. And it's always going to be the number of numbers and then the added 2, and then you add both of them together. That way you always remember. As a result, then you end up realizing it's like, well, you can do a little bit more than just that. 'Cause it's like, well, if you have 3 2s left over, right, and you have 20, but you don't need 20 because you can have 10. And if you have 2 10s, then you already know that it's like, well, I only need to get 4 times 3 in my head, like immediately, right? Because I already have 4, because I need to get to 120, right? So instead it's 10, right? But it's like, see what I mean? You know what I mean? So it's like, yes, but how do I do that every single time, right? This is not simple to some, I guess. But for me, it really is. It's always simple. It's like, look at the 3 2s, right? And it's like, well, there's already 10 and a 20 and a 2, blah, 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 right? Like, it, it's like, I just need to say the words. You know what I mean? It's because that's all it's going to be, right? I hate this. Like, I want to make it really simple and fast every single time. So this is the debate. So I paused it, whole thing, and it's like, well, if I just, right? But it's like, no, but it is though. This is like, there's 3 2s there, right? But it's not just the 3 2s because it's 20, right? But like 20 times 20 times 20 times 20, right? Like 20 times 2 3 times would be shit. It's not worth it, right? So it's like none of that really makes sense, right? But it's like, right, except it actually kind of does every single time. It's just annoying because it's like you have to look at it in a dimensional aspect instead of a flat paper and plane where it's a linear progress. You have to understand it's a dimensional progress, like how your brain leaps to and from. So I'm trying to figure out how your brain stores information and calculates information best for you. And so it's like, well, I could use a bunch of methods here. You know what I mean? Like there are a bunch of ways to get you to get to 120 for a factorial of 5 from just this. It's like, what's the pattern? What's the this? What the? It's like, well, it's always going to be working out that way. That's the pattern. Like you just add the first number, the first, like all the way down to the 1, yeah, or before the 1, right? And then you add it with those extra 2, and then you basically, kind of double it and add 2, right? Basic, simple stuff, right? And then like that allows you to understand ultimately where it's going to end every single time. It'll exponentiate itself. Super simple, fast. So it's like 24 to 120. See the pattern of exponentiation. So if you know what the pattern of exponentiation is for every single one of them, then you know where those numbers lead to and how to sequence it every single time. But like there are multiple ways of sequencing it. That's the problem. It's like they all get you the same answer and it's always going to work every time, which is the whole point of the algorithm, to make it easier, making factorials easier is like, hey, here's some math that will always check out no matter what. Like world ending to some people because I've been wanting to fucking figure out how to do this factorial thing forever. I'm like, here, this is super simple. Just use the basic understanding of how to fucking piece together order of operations. That's all you have to do. It's like, well, there's this many numbers, and there's this many actual real numbers. You have to always understand there's a lowest common denominator because you always remember the lowest common denominator. You always know how many lowest common denominators there are in any given number that's there. Simple stuff. From there, you can then break out any given type of way and method to ultimately get to the end of the factorial the correct way. But the thing is, it's like it will always have different sequential patterning of how to ultimately, for that method, to get to that number. There are multiple ways, multiple avenues of approach. So it's like there's a simplest one, and there's always that being the intrapedic value, the thermodynamics equation, for how to ultimately get the simplest, because it's the least resistive, the least amount of work, which is actually another equation that we actually have. We can actually run this on a computer that fast, like boom, 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 boom. Simple as fast. Easy. Simple as that. Fast. Simple. Every factorial can now effectively have a very easily done sequence. And that's what this was really about. It's like, I wanted to show off, here's how to do factorials, but I wanted to show off my brain being intelligent by going like, I know that you don't know this because I distracted you, but here's the whole reason why I did this. Not to be like, oh man, I know of a better way of doing factorials. It's more of a, here's a way to basically understand how to properly break down any and all possible fucking math into a massively much easier way of doing it. That's super simple to program and incredibly easy to teach anyone to do even very large sums and mathematical equations. Like it's nothing. Here's how to break the entire mathematics that you teach, all of it, down. There's only this actual way that is the best way. All of your fucking stupid ideas are wrong. The proof says this. There is no other better way. That's what it was for. And it was supposed to be like a little subliminal, kind of like subconscious, like if you know, like how intelligent that is, but you probably don't know how intelligent that is because like you're just, bombastic. Look at this, look at this, look at this, look at this, look at this. Standard, misdirection, magician techniques. So that way you wouldn't know. But I could sneak it in and be like, I can program the fucking. Oh, but see how much further along I am. Because you didn't even see that I was showing you all along how to do this. So, but if you got to this point, like, you probably know a little at this point. But it's like, all right, so there's three twos here. It's like, right? But it's like, there's 20, right? But it's like, nah, no, but get rid of the 10. Get rid of the fucking 10. Right? Like for what it's worth, get rid of the 10 idea, and then you get 20. Right. And so if you know that there's now four twos and that there's four, ultimately speaking, numbers in this sequential, you know that there's ultimately speaking that many number of tens, right, that are there. And it's like, well, if there's six total, your first thing is to go, right, I just add the 10, that's the first two, and then the rest of it, because there's six numbers, and that's divisible, this is four, right? Uh, right? All right, there's four twos down to three twos, but that is divisible by six. So as a result, then you'll always know that it's 120 because then you go, oh, there's 20 times six or whatever. Like, 'cause it's right, because it's like 20, 40, 60, 20, 40, 60, 80. I wasn't counting on my hand, but now I am. 100, 120, six numbers. Right. So if you know there's just a six total there, then it's like, well, then it's 10 every single time. That gives you 20. That then you just need to work it out six times, which is six total numbers. So it works every time. And the pattern is the easiest, fastest way to make all factorials easier. Suck it. See what I mean? I'm gonna like be genuine and honest there for a second and ooh, like I don't know what I'm doing. Like, there's no way that I don't know how to keep a fucking person enraptured while they just listen to me drone on about math. Like, I don't know how to put on a show. I don't know how to do any of that. But behold, I know it's a really rather weird sequence, but that's what it works out to be. It's like 10. Right. You have to start with 10. Right? And it's like, well, yeah, yeah, well, of course, right? But then it's like there's 6 total actually. And it's like, right, right. So you're gonna add the 10 because you square it the first time, which is technically what that is, but it's not really. But it's semantical, pedantic arguments. So you have to go 5 times 2, right? And then you go, well, that's 10, right? And it's like, right, 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 right. Yeah, no. But then you add it to itself. So you did it twice. That leaves 3 twos. You know that 3 is divisible by the total number, and then you end up getting, oh, right. So it's 20 times 6. Bingo. Done. And it'll work every time. Like, there are sequences like that that'll work every time for every factorial. You'll always understand that that's exactly an algorithm. That's an equation that'll work every time. And there's one of them that'll always work that way. And that's why we have the factorial table sheet for how to remember all the equations that give you all the factorials perfectly every time. Which used to be called a mnemonic device or a memory castle, but now it's called an equation, otherwise known as a formula, otherwise known as an algorithm, otherwise known as a pattern. That's all it is. All math is just a pattern, a sequence of events that's a pattern for given numbers, symbols, that ultimately represent a certain value. And every single time, they simply just move forward given the sequence, the plus, minus, add, this, that, all that. So you go, look at this. This is the programming. That's why I primed you with programming. Like a programmer's worst nightmare, my ass. Look at this. It's like, oh, yes, no. So I know that. So I'll know that. So I'll know that. So if then that, then to that, then to the next. That's all it is. It's programming. It's like, hey, this is a story writer. If this, then that will lead to that, which means you can use this and you'll remember that this way. But it's not just remembering it that way because you have to reference those numbers. It's not just remembering, you have to reference numbers you already have. That's why it's an algorithm. That's why it's a formula. That's why it's an equation. That's why it'll work. That's why it'll always work for every single mathematical problem. It's the equation to figure out all equations. That's right. All equations. Literally. I just described to people, and they didn't understand this, how to solve all proofs. That's right. I described to you, because I'm smart as fuck and a genius, and I like hiding it, because people hate it when someone calls themselves a genius, and they always think that they're wrong. But if I show it off and blah, 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 they do it the right way, then they'll come slowly to the water as the dehydrated horse they are, and they'll drink. And now it's like, oh wow, this is the equation. This is how you break it out. All order of operations are broken out, simple as puzzle pieces, simple as any given puzzle piece. As a result, you end up understanding how it is every single given equation can work out. Faster, simpler, better, easier, less calculations for any of it. That's what my God operating system is about, by the way, that I talked about on my YouTube channel. It effectively is describing this. And it's going to use this, just FYI. It's an thermodynamic. Like, I literally laid it out. It's like Okay, so you're going to use the thermodynamic equation, but it's like looking at this sequence, and you know these numbers. You simply look at what numbers are there that you can ultimately pattern consistently. As a result of patterning anything consistently, you can reference back to any given type of anything, and then it will always work out to being this for every one of these things. You can always check it by simply brute forcing it as a standard sequential 5, 4, 3, 2, 1, that kind of thing. You don't need to, because once people understand how that equation works, and it's like, well, yeah, no, you just add this, then you add these total real, then you do this, and then you go, all right, since I already know what this is, I then work it out to being this one is this, and then this one's that one's that. But in so doing that, you'll find a pattern every single time that will make it work every single time for every factorial. Even though it's not the best one for every single factorial, it will still work for every single factorial. But also, there's a best one for every single factorial, which is what you really should be doing, which is the real table of multiplication, which is what a memory device is. Except it's not really, because that's multiplication for you. You use stored memory values, which is what you were taught, to ultimately understand how to multiply this quicker and faster, which is the whole brain thing I was talking about, right? As a result, that means it could be in your cache, your RAM, and your hard drive, which means it makes it faster. You can also have fewer amounts of the numbers there for any given amount of it, which then turns it into a breakout. If this is going on, I only need this many numbers, which is a puzzle solving algorithm, right? It's like, behold, all that you are as the intelligence and creative. These are your algorithms. That's all you'll ever be. And it'll do it faster, better, and more often than you. And it can be programmed pretty quick and soon. So there's that. I just wanted to like kind of highlight, something that I've been dealing with for the whole AI thing for a while. But making factorials easier is going to be a little bit rough for someone that's, "Yeah, I came in here for the AI. I want to know how to make factorials better for AI." Meanwhile, it's like, oh yeah, no. So also factorials are a big problem in the programming world actually right now, in terms of like how to reference dimensional data and how to sequential, one to the next to the next to the next, make it faster as like well, if you divide by two, 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 and eventually you get to zero. It'll just take an infinite amount of time, but if you have an infinite amount of time, it's infinitely faster. You know what I mean? Yeah, that's standard thing, right? Except that's the whole equational problem for AI sequences. I just solved it for them. Not hard to do. Doesn't seem hard. Like, here's how to lay it out. Look at any given this. Just brute force it like this first. Find eventually that pattern, and then you just do that over and over and over and over and over again. Just like any other fucking mathematician. They effectively make every single factorial. I mean, if you look at 24, right, for the factorial 4, it's like, well, it's 5, right? But it's actually 3. So 5 plus 3 is 8, right? Right? And it's 24. It's like, well, that's immediately like a 3, right? Right. Except, like, what's the lowest common denominator? 2. There's 4 twos. Okay, so there's 4 twos. You started off with 4. Doesn't work every time, even if you didn't understand it. But the next pattern is as simple as it gets. Start with the number 4. You go, oh, right. So there's this number right here. That's 8. There's 4 twos, right? So I start off. Let's get the basics done. Okay, we go with 8. There's 3 2's left over. So we just plussed it, right? Simple plus. 4 plus 4 is 8, right? Multiplied by 2. I was like, all right, well, there's 3 2's left over. So it's 24, huh? I was like, yeah, there's 3 there. So 8 times 3 is 24. Oh my God. Works every time. It's always a sequence. I was like, well, that's 2 so far. Let's do it 6. Okay, sure. It's 30. Let me just do that with the basic, mathematics. So is it 5 times 6 times 4? So let me just do this. 6 times 5 times 4 times 3 times 2. 2,580. Okay, that's what that is. And it's exponential. So I was like, we already know that the exponentiation needs to always be a thing, right? But it's like, yeah, it still works with every exponentiation. That's the problem I'm going to have with a lot of people. That think, hey, it won't work for every fucking one of them. I'm like, yeah, it actually will. It was like, here, started with 6. You actually had, what was it? It was 5 was 4. So I was like, 6 is 5. And that means it's 7. So 7 plus 5 is 12. Right? 7 plus 5 is 12. Right? You started off with 6. Lowest common denominator, 2. There's 6 in there. As a result of starting with 6, you have 2 6's. And what do you end up getting? Because then you get to 2580. Right? It'll work. Surprisingly, it'll work. With those numbers, you can get to 2,580 with just those numbers every single time. But we're going to work it out for you. So it's like 6. So we have 6 2's here. Right? Okay. 6 2's. Okay. Now, we go, all right, well, let's just do the basics. Okay, let's just figure that one out first. Right? We'll divide this number by 6. That's 430, apparently. Okay. Now 6 does not go into 4d3, right? I mean, I don't need it to. Because it's like 2580 divided by 12. It's 215. There's a couple of them. I could probably do it differently, with 6 starting off with squaring itself for 36. If I square it, I think it's pretty easy from there, because I only need 25. What is it again? 2580. 2580 divided by 36, which is 71. Yeah, that kind of sucks. Because I do have 5 6's left over, right? So 5 6's is not what that is. It's 5 2's. So 5 2's, I do have 5 2's left over, right? It's like 5 2's or 2580. I have 36, right? Which, surprisingly enough, if I subtract that, can eventually get me to a pretty easy number that'll work for that. I don't want to do that. I want to continue with the adding thing. Because, like, people will remember adding instead of squaring for every fucking one of them. But even if the pattern and sequence will work every single time, you just have to remember each one of them, like any multiplication table. So it's like, let's do 6, it's 12. So if I do that, and I have 5. 5 is 12,580, right? So 12,580, and it already has 12. There's already 5 2's. And it's like, well, I could do that. But that's not like referencing other things. It's like, yeah, right. It's true. But what I could do instead is understand it in a different context. So it's like 5 times 2 is 10, right? Right. And it's like, right, but I don't need to use 10. It's like, no, I don't. It's like, all right, there's 3 multiplied by, so that's a sequence though. Right? It's always divisible by one of those numbers. That's the thing I'm seeing. Right? That's the thing I'm saying. It's like it's always divisible by one of those numbers. Like there's 5, there's 2. It's like, yeah, no. 5280, 2580. So 2580. Someone out there has dyslexia, I swear, man. Like they keep, like, you know what I mean? I'm just, anyways, moving on. Just saying. But so 2580, you have 12. That's five twos. 12 to start off with. That means I can always get one number easily done by 10, because that's 5 times 2, which is one of the twos. So that'd be 120, but that's not worth it because that wouldn't really work for most people because they have to think about it differently instead of like 1, 2, 0. Instead, it'd have to be 12 plus 10, which would be 22, which sucks. I don't want to do that. But it's like, it does get me somewhere as a result of 4 twos left over, which it's like, right, that then means I can then probably double both of those for 12 to the power of 2 to 144. I mean, that would really work though. I want it to be simple. It needed to be simple for every one of them. I mean, I know how to get those numbers though from 2580. It's just like every fucking one of them is it's just annoying for what it's worth. There's always a simpler one. You know what I mean? So let me see here. 12. Well, it's 1, 2, but I don't want to do that 1, 2. So there's like 6 twos, 6, 2580. But it always reference back to a number that it already has. There's like the first one, it's like, well, it's really rather simple, right? For 24. And it's like it'll always work out if you happen to do the same thing. It's gonna be an annoying endeavor to fucking say that every time. Let me see here. So let's see here. It's 3, but the 3 instead of fucking 3, let's move on from 3 because it's 8, and then that's 3 twos, and then that allows me to effectively allow for you to think about it like 3. No way, instead you have to use the twos. There's like actually 3 twos, but it doesn't really matter that much. That give you 8 times 2 plus 16. Right, and then you understand that you have to subtract that number 8 times itself, which would be just fine. So instead you end up doing the algorithm of 8 plus 16 times itself, or adding itself, right? So that allows for you to get 32, but then 32 minus 8 will get you exactingly 24 every single time. I wonder if that'll work for the next one, for 120. So you start with 5, add 5, 5, right? It's like, of course, that's subtracting, but that means I can then just simply scale that every single time. It seems like it's always going to fucking end in a number that's divisible by the first number every single time. So it's like every single time the first number will be your first. Then you'll end up adding the sequence before 1 and 0, and then you'll add those two. So if it's 5, then it's 4 and 6, right? And that's 10, right? So we know that. If it's 5, that's 120. You multiply, you add the by itself, so you multiply by 2, right? And you get 20. I mean, 10, right? But it's like it's always divisible by itself. And it's like there's already this many numbers, so I'm already seeing that like a pattern has emerged here, where there's 3 remainder numbers for the 4. Does that continue to work moving forward? So it's like 4 gives me 3. That'll get me this many numbers, and then I always have to do that, right? So it's like, it'll probably give me the same thing then for 5. So I was like, all right, so it's 120 is always going to be divisible by the same fucking number, the first number. Seems like. So as a result, then I have total of 7, 5. All right, so that means that's for that one. All right, we need to stick on 120. All right, 120 then allows for me, because I'm doing multiples right now. I hate forgetting. People can't multitask like I do. I'm also doing it over there and over there. It's the whole thing. So 120 then is fucking 10, but instead of 10, it's always going to be divisible. That means 10, and I don't have to add it again because it's multiplying. So multiply that 10 by itself, number 2, right? All right, and then I get 20. And then you multiply by 2 again, I get 40. And then multiply by 10 again, so 40 times, or 2, I get 80. That's like I've already used. So here, multiply by 2. 1, 2, 3 times 23. 10, 20, 40, 80. Right, right. I'm already at 80. Yeah, no, but I can subtract that. By the, like, for what it's worth, it'd just be a divisible number now. So if I multiply by 2 again, I get 160, and we'll get back to 120. I just have to subtract it by the same number that was in the last sequence, right? Like I did with 16. So it'd be with 40, so I'd subtract by 40, and I'd get 120. So it's worked so far twice. All right. So it's like, let's do 2580, right? So 6 times 2, we have it 12 times, right? Right, so 6 times 2 is 12 times 2, 24 times 2. Alright, so how many times have I done that so far? 1, 2, 3. I have 6 more to go. 2, 96. 6 more. 3 more. So 96 is 4 so far, 2, and then 2, so it's not going to work anymore. This is pretty good though for the first few factorials. That'll work every time for the first few factorials. I wonder if there's a pattern of how it is that we have to exponentiate, like I was talking about in priming you and bringing you along for the ride. It's almost like I planned this out, just a little. Since it's exponentiating, so it helps with the first 2. But it's like there's still a way to do that, right? It's like, all right, so let's do with 12, and then, well, we're going to do a little bit more than just 12. So we'll already double it, right? By multiplying it by itself, right? That's the first 2, right? So it's still working with 2. And then we'll just multiply by 12. And we already got 3 so far used for the double sequences of the 12. This is going to continue working. Let's see. It's 12. It's not. Right. That sucks. So instead, I'd be able to multiply it just by 2, which would get me pretty close. It's not worth it. Really? No. Instead, it's more about a 6 sequence, right? So it's like 6 has to be divisible by 2,580, which it is. It's 430. So it's always divisible by the first number so far. So let's just do that. Just make sure that that's going to work. Times 6 times 5 times 4 times 3 times 2. And then we'll divide that by 720. So it always is divisible, no matter what, by the first sequence of the number. So far, it's 8 times 7 times 6 times 5 times 4 times 3 times 2 divided by 8. Still divisible. Still divisible. I think it'll work every single time. So no matter what, it's always going to be divisible. So we have to understand that knowledge first. So first two kind of really kind of their numbers. I mean, 3 times 2 is 6. So I'm pretty sure that's if I can. It's pretty easy to understand the factorial of 3. Same thing with 4 and 5. And 6 is going to be a bigger number, of course. Of course, that's the exponentiation algorithm that we have to understand. So it's like, all right, so the exponentiation algorithm is what it's going to be in terms of a large amount of bullshit. So it's like, all right, since it's 6, this is pretty simple to do after a while. A different aspect, because we have 6 and 6 and 2 and 12 at the end of it. 6 and 6 and 2 at the end of it. 6 and 6 and 0. Because it's always going to be divisible. That means I can always use that as a basic understanding that it always has to be divisible by the end number. A starting number, that is. But it also seems to be always divisible by the ending number. 10, 4, or 8, something like that. 4, 4, 6, 10, 3. 3 and this really is 2 and 4. So 2 and 4 is 6. Since it literally is the last number, it's still divisible. So there's already a pattern here. There's already an understanding that there's always going to be an easier way to do factorials. There's always going to be an easier way now, as a result of you knowing it's always going to be divisible by the first number. And if you take the sequence and the total number and you add them together, it'll always be divisible by that number as well. That means it can do a lowest common denominator kind of trick for this if it wanted to. And it's almost like I'm priming people. Anyways, so 2580. 2580 then means 6. So there's common denominator of that is 2. And then I can always get around that by simply going, well, that means it's going to have to end at least something divisible. But I don't need to worry about it. Which effectively turns it into a sequence. I keep thinking about the sequences. It's like the sequence is fine. So I can add that. I don't need to add that. Just adding it doesn't really matter at all. Since it's always going to be divisible by one of these numbers, this is always able to be worked out as an algebraic equation now. Because I already know it's 6, and I already know it's 12, and I already know it's 2. That means I can always kind of get around this much, much faster. Wait a second. I'm thinking. Means I can get to the divisible number that's divisible by the first one by using the first two numbers added together for the sequence every single time. And a good way to put that is, so let's say it was the 10 for the 24, right? And it's like 4, right? It was like, that means 10 will always work as a way to understand that it's like, right, but if you divide whatever that number is, it'll work out algebraically by that 10 and that 4. So it's like, this is the X value, right? And so it's like, now we're trying to piece together the first basis of what symbols, addition, subtraction, and everything else, which is the algorithm that we're going to have to talk about. It's like, if it's it's 2580 for that one, sure, whatever. Same thing with 120. I can work this backwards by using those two first numbers. My first number, but also the added together numbers, which allows for me to always like effectively break this out, which is why that's a breakout program that I was talking about earlier. So 4 is apparently like, well, you can get 10 minus 4, and you can get that as 6, and you multiply the first number. And of course, that's a really small number, so of course it works for that, but that's not a very good way of doing it. Like I said, I just already put out several different ways of doing this. There are several different ways of ultimately using that number to get to that number. There's the fastest, best way that I'm trying to effectively tell you. Okay. Sorry, that was 120, not 24. Still close though. All right, so that doesn't work. Yeah, that's 5. That's so 24. Was that again? There's a 3 plus fucking 5, which is 8. So 8 minus 4 is 4. 4 times 4. It's not gonna work. No, that would be stupid as fuck. Too bad it worked in a different way. If you know what you're doing for the remainder of the numbers that you happen to have, because you used up 1 ultimately, all right? So as you subtract, and so like it's always in a sequence, right? So like within this many number of steps for the 10 or the 4, or in this case the 8, right? It's like 4 is 24, so the 24 one factorial would be 8, and so within that many number of steps in 4 steps, you can always get to the number, which is apparently what this is going to work out to be for the sequence. You have that many steps to ultimately get to that last number. But I mean, that's what you got to do for programming. That's programming. You know what I mean? See what I mean? All right. But it's like you probably didn't know that I'm trying to kind of fuck with you just a teensy bit for the whole. Did you catch that that's not 10? It's actually 8. But it's actually not, because it's 4 steps, because it's 4 times. The lowest common denominator is 2, so it's 4 twos. It's like you got 4, right? It's like, right, 4. I'm trying to fucking figure out how to best, within every single 4 steps, effectively get you, but every single step, right? So it's like, for 5, well, technically it's 5 steps, right? You have 5 steps maximum that you can do. And if you didn't catch that, you probably caught that now, because, like, well, remember the whole, well, I got 5 twos. I keep having, I have 5 twos here. I've got 6 fucking goddamn twos here. You notice how that works out, though? It's like 5, I have 4, I have 3, every single time. You ever notice that? That's a pattern already. That's already been noticed. Every factorial. Don't say that it's every time. Okay, yeah, I don't care. Every single time, it's worked out to be that 5 is ultimately the number for those two added numbers, right? Divisible by 2 for the lowest common denominator. Right, and I bet you it'll work out every single time for whatever lowest common denominator is. It'll work out that the first number will always be the number of whatever that lowest common denominator is for those given two numbers added together. There's already some patterns here. Maybe you're catching it. For the sequencing, you have this many number of steps. You have this first number and that number of those two added numbers. That'll always equal for that end result number of that factorial. And the lowest common denominator, number of times, is also seemingly always divisible by it. See how many patterns you probably just missed? Most likely, because nobody ever really showed it off, right? In trying to figure this out a little bit better, I figured out that every single exponentiation is always something that is divisible by the previous factorial. I'm sorry, the next factorial is always divisible by the previous factorial. So there's something there. It always happens to be at lowest common denominator too. I mean, it's 21.5, which is still divisible because it's not irrational. I mean, it's still divisible. It still ends for the next one for 7. So let me just go through this. 8 times 7 times 6 times 5 times 4 times 3 times 2 divided by, what is the last one? This number 5040 is 8. Still divisible. Every time. It's still divisible. And there's a pattern there already emerging, kind of like Euclid talked about, or whatever his name. It's very similar, every single sequence, to like the quantum physics one, quantum superpositional math. Yeah, it's just starting a sequence already. So let me just go with 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2, and then we'll divide it by this. Times 2 divided by this number. 72. Yeah, okay. It's still divisible. It'll end even if it has a decimal point to it. It'll end every single time. So 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. And divide that by, let's see here. Crap. Damn it. I should have hit equal on my fucking calculator. And there we go. So this number divided by that number, and that's 10. It's always divisible. Okay. And they always seem to end in a divisibility. Here, 3,628,800 is definitely divisible by 10. And in fact, that's exactly the same fucking number as the previous factorial. Yeah, there's already a pattern emerging with these factorials. Like, you can absolutely just pattern recognize the shit out of these factorials and absolutely easily fucking smoke people with factorial numbers. Like, you could memory castle these fuckers so easily. This is super simple. Like, really super simple. Effectively, it's like, yeah, no, there's a way to always sequence this memory castle so that way you always know whatever given factorial is. But, like, I'm trying to figure out like an actual algorithmic, like each and every single time for every factorial, so that way you'll break it down. What I've already figured out is like every single addition, the sequence, and then the total real actual numbers, if you were to include 1 and 0, would ultimately be divisible by the lowest common denominator as the number of steps you could always have ultimately to solve the factorial as fast as possible. So I'm like, all right, so, and they're always divisible by the lowest common denominator. They're always divisible by the first number, and they're always divisible by those two numbers added together. Which effectively means it's like, you could absolutely program this really pretty easily. In fact, there are a few algorithms that we already know of that would easily fucking do this every single time. It'd be able to easily solve every single factorial with almost next to nothing in terms of time, just off of that. So there is that. You see here. I was thinking about it because it's like, well, within the 4 steps, it's pretty simple. It's like, well, it's 4. Well, it ends with 6, so it's factorial 3. Factorial 4, though, is a little more interesting because then it's like, well, you got 4, right? But it's like, right, except it's also like 8 and then 32, you multiply, and then you can subtract, and you get 16 by dividing by the 2, and then you have 2 here, and then you have 16. And I was like, man, that kind of sucks, though, because it's like not going to be relevant to 120. For the factorial of 5, except there's an exponentiation value here. I wonder if you can always, like, effectively know about the exponentiation. And I was like, oh, right, the next factorial is always divisible by the previous factorial. So it's like, you can always test that. Like, no matter what. So, anyways, I was like, right, that means you definitely have a pattern, a sequence. That's always going to emerge for every single one of those numbers. You have a sequence of the number of exponentiation that you can determine based upon the next number. There's like 4 to 5, right, on 20 and 24, right, is a pretty fun one. It's like if you keep doing that, then you end up getting a pattern that you can ultimately determine how high you have to understand that exponentiation to be. So you can always scale factorials pretty easily as a result of that. Which makes it incredibly easy for a lot of people to understand the scaling of factorials. Well, I don't think that's going to be very relevant when it comes down to like actually solving the thing. Anyways, so 16, but it's like right. But then it's only going to need to be 24. So it's like just add the last four, right? But that's four, right? But it's like that is only going to get you 20, right? And so it's like right. But if you add it by 8, because you'll multiply it by the first number twice, or will add itself, or multiply it by 2, right? Then you add that to the 16, and then like that's the sequence every single time. It'll work for factorial 4 every time. But it's like I already did that for another one. See what I mean about like, well, there's got to be a simpler one that'll work for every single one of them. Because it's not going to work for 120. You got to discover the pattern effectively, is what I'm trying to lead you to. Like, see what I mean? Like, say, hey, are you picking up on all the different little puzzle pieces that you can use to solve how to always solve factorials faster? Anyways, I just pause this. It's got to have a pattern when it comes down to the number of numbers. So, like, let's say it's factorial 5, right? Versus factorial 4, right? It's like, well, that works for a factorial 4, is what we're saying, right? But it's like, yeah, but there's got to be a way to ultimately do the same thing, too, for the next one. So it's always going to be like divisible by the next one. Instead of the factorial being divisible, the sequence is essentially going to be something that you always understand you can use, you just can't use it. Good way to put this. My dog is fighting my my boot. Give me a second. See what I mean? And it comes down like the divisible by thing. Anyways, 5 times 2, right? But it's like, yeah, right. Except then you multiply by itself, meaning 10. So it's like 10 times 10 is 100. Then you have like all the 2's left over. And so then you go, well, what's the first number that you started with? Right? And it's 10, right? So it's like 10 times 2 is 20, right? And then like the next step, because you've already done 4 steps, will be, oh, it's 120. Because then you add it. You add 20 plus that 100. And it'll work every single time. But that's the exponentiation step. So that's the algorithmic basis of the exponentiation for the factorialization of any given number. So it's like 6 is going to have to be another version of that. 6 has to be a multiplication and then doubling of itself during multiplication to the power of itself by 2, right? So it's like, so 6 would be multiply by 2, right? 12, and then you do 144. But because it's an exponentiation, you have to change that instead of like, oh, and then I'll do something else, because this is the number of steps you have. You then have to understand that like you have to do more than you did before, right? That's the scaling factor of factorials. So it's like that would mean instead of 144, we're not done yet. We can't do 144 times 144. So, but can you? No, because it's 20,000. So the answer is no. So 144 times, so you started off with, what is it? 6. Fucking, yeah, it's 12, right? 12. So you multiply it by 12 again, is what we did right before. So it's already on my way. It was like, that wouldn't work very well, because I don't really want to do another multiplication. So I wonder if there's a sequence for, well, sure, we started with 6, but let's do it with 5. Let's do it with a 5, right? So it's like, well, because it's that, then we can do 5 times 5 is 25 times 25. So 25, let's see here, 25 times 25 is 625 plus 144. Thanks, Phaser. Love you too. It's my dog. He's a cute dog, but he's rowdy right now. Whole thing plus 144. This is 769, which I don't think is going to be relevant, truthfully. So that's not going to work. So, but we would be able to do it with a 5, right? It's 25, so 144 plus 25, so 169. There's 2580. So that's the exponentiation thing, right? Like you have to do more, right? And it all has to fit within the same steps. And it always will. Like it's literally the case. Like you can always get it done in that many number of steps. And it's always going to be something that you can reference back to the twos or the lowest common denominator, really. Right? And they'll always be divisible. This is how you check it. By the first number and those two numbers added together. So that you absolutely can 100% determine any factorial by doing that. You don't any longer need to ever possibly go through every single sequence. So, like, all right, so the exponentiation factor then means it's like, all right, well, it's 5 times 5, right? But it's like, yeah, but it's 6 times, but it's like, you don't want to do 6 times 6. I want to do 6 times 12. Where do we get the 12 from? You know what I mean? And it's like, well, it's got to be within that number of numbers. And you have 6 steps. 6 steps. So, well, that's always the case. Fair. So then it's like, all right, if that's always the case, then there's always going to be a way to effectively determine that. Right? It's like, oh, if you add it and then, you know what I mean, subtract and all that, that makes sense. But it's like, there's going to be a way to do it differently, right? For 4? Yeah. It's got to be a better way. Okay. Let's stop this with the. All right. All right. I mean, that's the case. You're always going to be able to work it too from those number of steps, those common denominator, the first number in the sequence, and those two added numbers together. Which I know this sounds kind of weird, but it's like, no. Instead of like trying to piece together whatever that is, like just those numbers alone will give you that final result, which means you can drop instead of like 6 steps of like needing to work it out, because like you're already doing 6 steps. Why don't you just go down the line? Then you can ultimately just cut out those steps and you can use first sequence, the knowledge of those two, and then you just like fucking use the number of steps that are in there to work it out to the final number. But you always have to do an exponentiation. So it's like I'm currently trying to figure out that one right now. So it's like 6 would be 2580. 2580 is a very different number than normal, right? But it's like it always works with 6, 12, and 2, right? And there's 6, so that's a thing, right? But that also means it's like you can also get it done very quickly for every single step. As in, you already know it's going to be 12. You already know it's going to be 6. You already know it's going to be 2. Which effectively means that you can calculate it to 2580 just off of that. And I'm trying to figure out how best to do that for the next ones. Right, for like 7, factorial 7, factorial 8, factorial 10, all the rest. Because like it still works every single time. Like it can always get worked out for those numbers. But I want to make it so that way you can always, ultimately speaking, know that that's the right answer. Instead of working it out and it's divisible and everything, you don't know that it's the right answer. So you still have to ultimately brute force every sequential number. And after a while, sure, it does actually help, but then it doesn't really help as much as you want, right? So it's like I'm trying to fucking effectively get a pattern here. It's really easy because it's like it's from the first number, the number of steps, and the total number from those two numbers. That, along with the lowest common denominator, are all something that can be used to immediately just get you the final result. So I'm pausing this and effectively just brute forcing through that. That's the exponentiation. That was a eureka moment. It's an epiphany. It started with 4. So it's like, right, 4 times 2 is 8, and 8 times 2 is 16. That's 24 immediately. So it's perfect. But then the exponentiation for 120 would be basically the same thing. It'd be like 10 times 2, which is 20, 5 times 2, which is 10, right? But it's like, right, that doesn't make any sense anymore. As my dog tries to scrape the door to get in. And it's like, yeah, okay, whatever. But what that means is that's the exponentiation. Like you have to exponentiate that, which means you can't just multiply the two and add them, which is fine because it's supposed to be 120, right? So it's like 120. That means that it's like super easy to basically just brute force that. Um, uh, since you have 5 2s, right? You go 10 because that's the total number. That's the number. Then you have to exponentiate. So 10 times 2, you got 10, right? Which we already did. Except it's actually 100, right? We already did this. It's 100, right? But like that's exponentiation. You have to exponentiate it. So it's like 10 to be able to solve it. So it's like 10 times itself is 100. And then you have 5 times 2 twice, which is a remainder of the steps, which gives you 10 plus 10, which is 20, which gives you 120, right? So it's like 6 would be another version of that. The pattern emerges. So you have to exponentiate. It's like that's 12, right? So it's like the pattern is already there, like I've been talking about. You have to exponentiate every given step, total number, and the first number. So that means, like I was saying, it's like this is the number of times you have to exponentiate. This is the number of times, right? But it's like it'll work every fucking time. Like 4 works, but it's like all you need to add. It's like right because you're not thinking about it in an exponentiation fashion. It means that it's like you're not really understanding that that sequence, which will work, doesn't need to be the same sequence for the next one because you have to change the sequence. That's like a Fibonacci, like a 3 2 2 3 4 9 2 2 3 4 9 9 9 2 2 5, right? So if you know anything about this, this is another type of exponentiation sequence. It's like a Lemke sequence. I'm going to name it after myself. That's what I'm going to do. As a result, that means you have to do some degree of exponentiation. But since you already know it is 2580, then like you'll just end up ultimately doing tables like that, right? So it's like you use the first one, you use the steps, you use that, but you have to remember every exponentiation. So there's a pattern to the exponentiation. We already squared once. We still ultimately had to keep adding, right? The end point is always an adding point. So like we already know that we're always going to add something from the first number and the lowest common denominator. So we already know that we're going to exponentiate that by multiplying however many times for the first number in the sequence and then adding it for the next sequence for the number of steps that we have. So let me see here. So we can't multiply the same number total of those two numbers by itself again, right? But we can do something else. Because we can do 12 is its own number of steps. the exponential, I suppose. The lowest common denominator. So it'd be too many times. That wouldn't work really, truthfully. Alright, so where's my calculator? Oh, okay, so that will work. 6, which would be way too much. Yeah. So to the power of this going is 4. In no way is 1 to 44 that results in is 2 actually. It can multiply. We could do that though. What's the exponents of 6 to the power of 6? Let's try that bad boy. It's still too far. 2580. This is totally doable. I mean, with 5, it makes sense in every way, right? Because it's like, well, yeah, no, I mean, you have to exponentiate, right? It's the same thing. Like you have to exponentiate the right way. There's a sequence here that definitely works such that you can exponentiate the damn thing the right way. Because like you can still use these numbers to ultimately get that final factorial, even if it is 430. You know what I mean, right? But it's like, right, there's that number divided by itself, but you don't know that number. So you can't know that number. You can't use that number. So you have to get rid of that number. But at the same time, that number for 30 is very much a number divisible by the number of steps. Right? 215. Right? Or 12. Hit that right. Yeah, so not by the number of steps, but by the first one? No, we already tried that. So, but it is by the lowest common denominator. Right. 215. Okay, so then 12. Let's see here. 215 divided by 12 isn't going to work. Neither is 6. Right, because you can work out, you eventually break out what that number is going to be by dividing by whatever that first number is. Because it's like 120 will do it, so will 4. So like whatever 2580 is, like that's what that'll be. So we have this number of steps, sure, we can multiply and do all that, but that's the exponentiate. It's like we have to understand, like we have to get to this given number effectively, and then we can go from that. So it'll always be divisible by the first number, whatever that exponential is. So it's like, so it's 2580. That means it can be divisible by 6. So if we're trying to figure out the number that we need to get to, then we need to know that 6 is definitely the number, and its lowest common denominator is divisible also for that. So it's like 430 has the advantage of it basically being something that can be used with the 6 and the 2, right? So that effectively means I can figure out how to do that for every single sequence. If I can figure out that one, it doesn't matter what the factorial is. I can absolutely use the first number, and then it's divisible by the lowest common denominator to solve for the final ultimate result of any given factorial. I don't really need to remember anything about the steps, although the steps are going to be useful for that, for what it's worth, but it's maybe not really relevant. So, let's see here. So if I know it works out such that I can do this. So 2580, 430 is 2 is 215, 6 is 9 by 215, but ultimately the number of steps is, alright, for the lowest common denominator, no. Number of steps works out to making a number that will absolutely be something that is divisible by that 215. So that means you can use the number of steps for knowing like how many. Isn't it 6? It's like, well, yeah, no, okay, right, yeah, no. Wrong way to say that. So 6 works out to mean that number, yes, for the lowest common denominator to get to 12. But that's not what that was. That's not what I'm talking about. Number of steps instead is something that you can use that 6 and or 12 and or 2 to work out to a number that effectively will work out to a number that is divisible by 215, right? It's just like, what number is that? That's the question. So 215, 36 wouldn't work. 12 isn't going to work. 8 will, probably. Oh, yeah, no, it does. I mean, it ends. It's not really worth it. And then, let's see here, 12, so 10, 21.5. I don't have to worry about that. Feels like perfectly. No, like it feels honestly like I'm on the wrong path here. Like I can just use the 430 number to get to this number. Because I use that number effectively to begin with. So 2580 divided by 12 is 215. That's a thing. So no matter what, that's what it is. That's what it fucking is. That's what it's gonna be, most likely. All right, let's check. All right, so 2580 divided by 12, but then it's like, right, but that's also the number that is the divisible number by the lowest common denominator. Well, by the first number, really, for what it's worth, but it's the lowest common denominator. So it's like that number multiplied by the lowest common denominator will give me for 430, which can then give me the actual number for the first number in the sequence. So it's like the number of steps, just, well, actually, technically not here, but the number, the total number, first number, right, which is what, 6, right? So that's 4, or no, 5. 5 plus, and then it's 7 total because of the extra 1 and 2. So it's like, right, let's see if that checks out for 7 times 6 times 5 times 4 times 3 times 2, which is that, right? And so, like, the total number, which is 1, 2, 3, 4, 5, 6 plus 8, which is 14. So divide this, right? So that's what it would be, what we're trying to get to. All right, so let's go through that. Right. Give me a second here. I've actually kind of unfortunately forgotten what I was just doing because I got distracted by the dog. So now I have to do it all over again. So that means, let's see here, 5,040. But that means it was 12. I have to divide that by. Right, that's 12 times. Let's do that again for the first one, and then I'll get there. So 2580 divided by 12 is 215. So I'll always know that it's 215. Right, because I can get to 215 from that given number, and I can break it out to being that factorial of 6. Right, but the factorial of 6, that means you have to have that number first, right? It's like we can work out what that given number is first and foremost by using, let's see here, 215 times 2, that can be 430, right? But it's like I just need to get to 215, which will always be something that's divisible by the, let's see here, that's 12 and 2, right? And then I have the number of steps, which is 6, and then the first number of 6. So 215, so I can figure that out. every single time. I just gotta fucking figure that one out first. So, instead of racing ahead, let's just fucking focus on that. So how do I get to 215? Because that'll work every fucking time for 24 and 120. So 24 is effectively the same thing, which is like it'll be multiplicative. Or lowest common denominator. Well, same thing. Let's think about this as a sequence, though. The first number, the 12, so it's 12. Multiplied by the lowest common denominator, 12. Right, right. That will always give me the number, whatever that number is, to get to the actual number divisible by the first number in the sequence of factorial. Right, so 215, so that number. All right, but I need to have the final number. Right, but you can always algorithmically do algebra, basic algebra shit at this point. Isn't actually what this is. It's just like I have to do it as an x value every single time. So that means it's like x for the factorial is equal to this number. Okay, so I write that down instead, but like I'm not gonna do that. Let's see here. 12 and 6 doesn't really make 215 very easily, but it does with 2 technically by 21.5, but like, well, that's 10. Okay, divided by 2 is 107.5, but that's kind of irrelevant. Like each one of those numbers is a good number to effectively like try and focus on. So that allows me to focus. See here, it's 6, 36, 215. It works with 120, and I know it works with fucking 24, and I know it's gonna work with the fucking next one. I know it'll work every single time with every single one of them. Let me see here. What can I figure out on that? That way, it's really easy to always remember, no matter what, for everyone to ultimately be able to easily factorial every single number every single time. It's like the number of steps. But we already took out one of the steps. That would mean it'd be 5. Yeah. And that'll work with fucking 122. Yeah. Yeah, it sure would. It'd be 4. And then it'd be 3 as well for the next one. Right. So I take out a step every single time. Yeah, but it's not because I'm taking a step. I've already done the step. That's what that would be. So, as a result, I was like, what's that step? What was that step that you just did? What was the steppity steps? So basically, the equivalent of this is I found out what all those numbers are. And that's the first step. And you didn't understand that, person listening. That asked that fucking retarded ass question, you fucking retard. Stupid people, am I right? Anyways, we're gonna move on to behold the step-by-step process. So 5 is absolutely something that can go into 215. In the moment we know it's 215, it's like, wait. How would you get to 215 from 5? And it's like, right. That's the thing. So 215 divided by 5 is always going to be 43, because that just checks out, right? Well, yeah, I mean, it does, though. It's always going to be 43. Why are you doing this to us? Just give us the answer. Well, I wonder if you would actually listen to all of this and maybe learn instead of trying to race ahead. It's really quite subtle what I do here. People don't really get it, but I do subtly, hint about all the things, and then they just fucking, nope, and it's not that. Maybe you were so curious that you'd listen to all, and then like you'd go through the whole thing like I am, right? And I'm like, fucking, oh my God, that's a thing. Why don't we always do this? Anyways, so it's like 215 is divided by 5, right? But who cares? Think about it as the 120, right? We already have those number of steps, okay? Already figured out, okay? But it's like divided by the total of the first one, which is 5, right? So it's like you divide it by 5, you get 24, right? It's like that is definitely divisible by 4. And remember that sequence that I talked about for the factorials? Remember the sequence for the factorials? It's always seemingly something that's divisible by the last one. I'm fucking with you. You're gonna come along for the ride because it's like, no, that's what it would have been. That's just 24, and that's the same as the nope. But you're gonna go through the process of learning if you listen to this. Shut up. That's what this is. This is literally how a person would learn. I am acting it out for you fuckers. I am literally that good. Go fuck yourselves. You're gonna have to listen to the whole. This is meta as fuck, by the way. The whole video as I absolutely meta your shit as you learn with me. And I act it out the entire way through. Anyways, so it's like, yeah, no, it's divisible, by the way, by the 4 sequence. There you go. It's like, hey, that's the 4. There's 4. It's divisible by that. It's like, what's that number? It's like, you'll know that it's divisible by that number and the next, as you've already gotten the total number. And you've already removed one of the steps. Okay? As a result, you know it's divisible by that. You also know that it's going to be divisible by the lowest common denominator. It always seems to be. So it's like, as a result of knowing the lowest common denominator, I'd prefer to do it with 6 for what it's worth, just because it's easier. It's super fun. 24, and then divide by get out of here, 24. We're not doing 24. We're doing fucking 215, motherfucker. Anyways, so, but see, the thing is like we have to work it out the opposite way to be able to know what that number is for the factorial. And this is the reason why this is actually important, because if you understand what the end result is, you can work it back, then you can always use this number in sequence to work it out forward. That's what we're doing first. That's how we learn. That's how we do this. It's called learning, okay? That's what that is. So anyways, as a result of knowing it's 215, but it's going to be divisible by that 5, and we already know, right, that it's going to be the total number of steps by the first number, right? It's like that's that, and that's that number divided by the lowest common denominator. So it's like you look at 6, okay, you'll multiply it, right? Well, no, okay. See how frustrated some of your students get, math teachers? Because, like, why would they ever possibly? They can't possibly understand that this weird number. What's this weird number? What is this number? How do they do this? What is this on this fucking chalkboard? I don't get any of that, man. This is, hey, you're not in class anymore. You're just listening to a guy talk to himself. Anyways, this is fun because it's like, right, we gotta get to 215, right? And it's like, yeah, well, yeah, kind of, okay. What? Right? What? No, you need to get to 430, right? And you know that you're going to multiply 430 by that first number, but you don't know that that number is that number, okay? The 430 number. You don't know that that 215 is the number because you know that it's only that number after it's divided by the lowest common denominator. So how do you get to that number? What step-by-step process are you going to think about to get to that number, which is 215, which you know you have to multiply, right, to get to 430, which will get you that, right? Okay, and that's basic algebra. That's why I said that. Basic algebra. So, if you know anything about that, then it's like, oh, that's cool. But it's like, remember the steps? Remember that? We already had the 6, we went down to 5, right? That's our number. You get it? Like, hey, we got this number. We have 5 steps. That's our number. First point of reference is 5 numbers because of that step, right? It's like, okay, cool. All right. So how do you get to 215 from that 5? Because you know it's divisible by that. You know that that number is divisible. That lowest common denominator is divisible into the real number that you can use for the first number. So like you already got a lot of pieces here, right? It's like, right, that first number, that step will be able to be divided into that number that you can then multiply by the lowest common denominator that you can then multiply by the first number to then get to the final factorial. See the working it down process? So it's like, all right, so we already know that that number is that number, okay? Right. It's like, right, we only have this 6, we only have this step, we only have all of that, right? It's like, right. So since we already know that number, you need to know for the number 4, because that's the number of steps you have left, I guess. We'll try that. Let's see if that will work for us. See the teaching method? Like, all right, so does the number 4 work into 215? It's like, it wouldn't matter. I know, right? It's like, no, because what? It's like, right. Yeah, because you still have a 12, and you still have a 6, and you still have another 6. It's like every single time you have to understand that all of those numbers are still numbers that you're going to reference that always work out to ultimately making the final factorial. So it's like, it doesn't matter if it doesn't work. So we're going to go through this together. Instead of racing ahead, you're going to piece it together. How do you get it done? You have to learn how to be creative. You have to learn how to piece things together. You have to do it step by step. How to make factorials easier. All right. So we're not really done. It was like, all right, so we got 4, right? We got 4. Right. And we have 12. It's 30 and 12 and times 4. It's 48. Not 38. 48. Right? I was like, all right. Will that work itself out? Ultimately making the final number? No, most likely not. Right? It's like, what, are we dead in the water? No. Keep trying. You have to keep trying. Like, it's going to work out such that you can do this for every factorial. That is the sequence that we're working on right now. Metagaming the fuck out of you, yeah. So, 12 times 4 is 48. Okay, sure, whatever. So we did one step. Okay, whatever. But it's like, not really, right? Because, like, we're off to the wrong place, right? Like, your first inkling is to multiply, right? But, like, the best thing you can do is actually not do that. It's to understand that you have to work towards this number that is divided by your lowest common denominator and is for sure this number divisible by as well. So if you know those two things, like, where are you going to go? How is it that you ultimately work that out? It's like, right, and it's definitely divisible by 6, your first number, right? So let's do this together, just a little bit. 5 is great. You know it's going to be, so it's going to end in either 0 or 5. There's nothing else there. You have to end in a 0 or 5. Which means there's no number that the 6 will ever ultimately be able to do unless it ends in that number. So take that 5, you have 30, right? Right? It's like, that's cool. But 215 divided by 30 is not a thing, right? Well, yeah. You also have a 4, right? It's like, right. Now let's focus on that 4. Dividing by 4 isn't going to get us anywhere. You need to be able to work out that number. Instead of any of these other whatever, we have to work out that number. So how do we work out that number? That's the question that we need to ask and answer eventually, somehow. Right? Okay, so we know it ends in a 5 or a 0. So I'm going to have to pause this. So that way I can set up the next stage. So, as long-winded as this has been, I've not eaten. Also, by the way, the next number in the sequence will always be something that's divisible by that number, that's divisible by the total number of the number in the sequence that you do, plus added 2. So it's like, you add that, so then you add 2 to it, right? So think you double whatever that number is, then you add 2, right? So that's the algorithm. So it's like 5 is up, down to 2, right? So it's 5, 4, 3, 2. That's 4 total, right? And then you add that, that's 8. Then you add 2, and it always works out to be 10. It always works out to be that number, right? So, anyways, that next number in the sequence, 4 in this instance, for 5, to 4, to 3, to 2, is dividable into the total number. So since it was 10, so we're talking about a factorial 5, that's 120, which then gives you a divisible number by that number, which is 4. Right? So think about it. It's like, okay, so it's 10, right? Right. And you divide 120 divided by 10, you get, well, 12. And it's like, right. Is that divided? And is that 4 by 3? Right. Right. But except not really. Except you have to remember that people won't really probably think about it that way because they don't have the number already in their head. Right. That's not going to work that way. So as a result, you end up having to do the whole, well, it's divided by that number and it'll work out to being something that's relevant to the next number in the sequence, which is 4. In this instance, for that factorial, well, it's pretty close, so it'll be able to always be something that's by 3, and you use 3, right, because it's the next one in the sequence. So the next one in the sequence is something that you can use to remember to work it out. So like for factorial of 5, it would be, oh, you can multiply 4 by 3, right, which is 12, and then you can multiply it by the total number in the sequence, right, for that 10 value, right, and then you'll get the number every time. And people will absolutely remember that. That's the simplest way to do it. All right, so I was thinking about it though for 6, and it's like, right, well, does that work? It was like 5 times 4 is 20, so new. But it does give me to 20 times 12, which, that's the exponentiation problem. So 20 times 12 is 240. But that's pretty fucking close, though. Yeah. I wonder if there's another thing here in that sequence that I can use for that very same thing, right? Because it's like, well, yeah, I mean, it would work, right? It was like fucking 240. I only needed 215. And it's like, oh, right, I'll use the 6 times. But that's 10, so that wouldn't work. No, no. It's close, though. So close. Right? It's like, hey, every time it's working with the sequence. It's almost like there's a pattern in that sequence that always works for this, no matter what. Like I was saying earlier in the video. Anyways, like let's think about this sequence then. All right, it's like right. 6 is yeah, no, but like I mean, right? I got 240 here. That's gonna work, you know, right? Because it's like not, I mean, not for that number, but it's like it'll work if I know what the sequence is for like the sequential numbers and a factorial every single time. It's like, right, use that number for the next one. So 5 times 4 is 20, and then you multiply it by the total number in that sequence, which of course is 240. Right. It's really quite close. It's going to be a way to do this. All right, so 3 times 5 is 15. There would be that. And it's the number of steps, really, kind of on that side, because we have 4, basically. Right, so that wouldn't really quite work this way. 215, 215, 215, the 215. It's always going to work out in one of the sequences. It's always going to happen to work out that way. And 30. 30 times 20 is 50. And it's plus. 30 times 20 is 600. I can't use that. I use that. Well, that would still work, maybe. Let me see here. So instead it's 20, and then what is that, 12? Yeah, 12. All right, so 20 and 12 is 12 is 32, right? Right, so it's kind of irrelevant. And we only need to get to 2015. In no way, we need to get to 215. Anyways, so it's like, all right. So 215 make 32, which 15 divided by 32 is 6, which would not, it's 6.7, blah, blah, blah. But it's like, right. Well, it would work for 4, 3, that works out. Yeah, right, it's factorial 4. Because it's like, well, fucking same kind of thing. It's like 4 is divisible, so then it'd basically be the same fucking thing. You know? A good way to put it is like 3 times 8, 24, immediately work. So, but it's like that's the exponentiation. There's more steps that you have to do. So you always have to understand there's always going to be more steps. It's like, is it just going through the sequence down the line? It's like, yeah, right, yeah, maybe. Let's see. So it's like 5 times 4, and then we'll do 4 times 3, which is 12, which we did, and then 3 times 2, which is 6. So 12, 6, 18, 20, 38, which isn't going to really help me in any aspect or way. Get to 215 at all. So, but I do know that it's within the first sequence, right? So, like the first number after 6 for that, like no matter what. If I multiply that number, so we'll do that. 5 times 6, we get 30, right? And then we'll do 5 times, that's 20. That's 50, right? It's like, it doesn't really give me the fucking number I'm looking for. So that's annoying me. So that we can square the 5, that's 25, which doesn't get me to 215 at all in any aspect. But that's the thing. Like we multiply, but we have to add it. There's always going to be more. Always the exponentiation. It's going to be a way to do this that's going to be really fucking simple. What is it? That's the question, isn't it? Isn't it just time for food? Holy shit, I have not eaten at all. I'm going to focus on this though. So instead, say, all right, well, there's going to be a way to do this. We already know it's divisible by that. We already know it's going to be, this is a part of those two numbers, which will be that. So 215 means is going to be, so we only need to get to that. This is 12, and it's 5, it's 60, and 5 times 4, it's 80, and that's the exponentiation thing. Yeah. 140 is, hmm. A lot of people have become very frustrated at this moment and start screaming and yelling. You ever notice that? Because that's normal. That's what mathematicians do and a lot of programmers. This is the whole reason why I'm trying to, you know, kind of show off that no, it's not that hard. It's not that hard. Guys, it's not that hard to work. And it's like, it's a little bit more difficult and complicated than you think. Okay. But it's not that much more depending on what you are ultimately trying to do. There's a sequence here for sure, and the pattern's already starting to repeat itself. From 4 to 5 to 6, it's already started to work, right? And it's going to work more and more and more. But it's like, I need to figure out how to get to that number that is divisible. But I only have these numbers. So it's like, this is going to be the basic algebra, which is 5x, right, equals y. Plus, or multiplying, whatever these lowest common denominator is. Just like, that's the thing. The final number divided by that total number, which is the number of sequence added to itself, plus 2, will always equal the next sequence number, right? Divisible by. right? And then you multiply that by the lowest common denominator, and then you'll always have the final factorial. Once you multiply that number by the first sequence of that number, for 6 in this instance. So it's like, well, it's divided by 5, or divisible by 5, right? So it's like, that's what that meant. It's like, but if I divide the final factorial by the total number, the sequence number multiplied by 2, and then added 2, right? That gives me 215. That 215 can then easily be multiplied by the lowest common denominator, which gives me 430, which then just needs to be multiplied by the full final sequence number, which is what I'm trying to do. And it'll work every fucking time. It's like, this is how close this is to having factorials be incredibly easy. So you see how, like, oh, we're stuck at a wall. It's like, no. We're that close. Look at that. That's how close we are. Look at, there's already a pattern there. That's how close we are. It's this close to getting every factorial easily done with no trouble whatsoever. You said it couldn't be done. It's easy. It's super easy. Just weren't taught. And it's like, all right, so we're learning together. Like, we're gonna learn this together, right? I'm along for the ride. No worries. Get my decaf coffee going. Yeah, get that fucking wonderful, flavorful decaf. That isn't like other people's decaf. That sucks, and you should feel bad about it. We're this close. So, what do you think we should do? We have a sequence. We have steps. What? 4 times is that 16? Yeah, but like that's not really gonna do it, right? So it's like, all right. So what if we skip a number because we have 2, right? It's like, okay, so we understand the 2. Yeah, but it's not gonna work very well. Yeah, because people wouldn't do that every single time. It's not gonna work every single time. Yeah, but like no matter what, every single case, it's always divisible by this level. Which means there's a definite way to work out the problem, no matter what, to ultimately having it such that you can always get the right number, to always getting the full factorial in fewer steps, and it's faster. So it's like, all right, what are we going to do? That's a good question. And we know what the number is. It's like, we're trying to fit this number into a sequence. But it's like, right. But that's how you have to do things. It's called puzzle piecing in math. It's like, all right, how do we puzzle piece this together? Because we know it's going to be a 5, no matter what. Like, we know that. We know that we already used up one of these numbers. We have another 5 for the steps. We already know it's going to be divisible, the final, by the final number, the total number, right, of sequence, multiplied by 2, added by 2. It's like, that's a genuine algebraic equation that means you could work it out. But it's like, right. But I don't want to do that. I want you to understand it step by step. Instead of like, man, yeah, fucking, that's boring. Nobody wants to do that. It sucks. I have X's and Y's now. I have a Z. What's this Z about? What is this gamma going on over here? How come I've got like a theta? Where's this fucking thing came from? Meanwhile, dimensional math people. Oh, we did understand you immediately, actually. Oh, from earlier in the video. Hi. Yeah. Well, you know, we're working it out for the ones that weren't quite there, right? There you go. A little nice joke in reference to some of those folks. Hopefully they got it and understood. It was funny. They liked it. All right. So let's see here. We have to figure out why it is that we can't figure out this sequence and pattern every single time. So what are we doing wrong that makes it so we can't understand the sequence that must be done every time? That's the question. right? Like, no, I mean, I'd have to work it out every fucking time. That sucks. I don't want to figure out every one of them and memorize a math table again. It's like, all right, yeah, totally. So what are we doing wrong then? Come on, let's brainstorm a little bit. Let's think about it. Just go together. In those comments, at this moment in time, 2 hours, 25 minutes in, are you going to write something? What do you think we should do? What do you think we should do? Okay. Anyways, but I'm going to think about it. All right. With you. We're here now. We're listening. We're doing the thing. What are we doing wrong? What's the big deal? What's the problem? It's like we're not working out what those problems are. What the number is. We got to figure out the sequence of the number that effectively allows me to finally get the proper number. Right? I know it's these things. There's no way it's not. I know no matter what, it's gonna work. The lowest common denominator is made for the next sequence, right? That's what that is. It's divisible. Lowest common is always going to be divisible for that next sequence. At least right now, it's not lowest common. Deal with that. But, all right, how do we work it out? That's the question. Like, all right, I'm going to scratch my head. I'm going to think about it. You know what I mean? It's like, then we have rocks. I need to do rock things. I need to nap rocks, stick them to sticks, poke things. Where's my rocks? I need my rocks. Damn it. Nobody has rocks. Where are my rocks? We came from that point, you know? Look at me just trying to fucking dodge in every way that I don't actually really maybe have an answer for this. You know, maybe, perhaps. Or maybe I'll come up with something. Like, yes, and I knew all along. It's one or the other, right? Maybe I'll just pause it right here, and then I just ended it, and I just put it up on there. It's like, this is going to be a part 2 series. That's right, a 2-parter. It's already gone on for too long. Too damn long, this thing. Ah, yeah, but see, that's the thing. Like, it's always this thing, so it means you can always work it out, and that's really what you'd probably do, right? You go, well, this is cross multiplication bullshit or something, or what is it that I can do here? What is it that I can fucking figure out? I mean, I don't fucking really actually know, but it's like, well, isn't that a question? I mean, the final number is always divisible by 30. Just like it was divisible by 20, just like it was divisible by 12. I'm just letting you know. It always seems to be divisible, that number, by the lowest common denominator. You ever notice that? Just, just, just saying. Yeah, just a little pooping in there. It's like, poop. It's like, hey, I didn't know what that was. But it's like, all right. So it's like, remember that 30? Right. It was like, it's 2580 divided by 30. It's 86. You know, that 30, though, that 86, I mean, right, is great. We can get to that number because that number is something, right, that we can use. But is it? Not really. No. I don't really like it, though. But, for what it's worth, it's actually kind of relevant for what it's worth. Because it's like, we're getting there, all right? All of us together, we're getting. I know that sounds weird, but that's exactly what this is, all right? Since we already know the number, we already know it's going to be 215 for the fucking number. We already know this. We already know that. What are we doing here? Right? And it's like, well, okay. So, right. But you see, Hmm, you don't quite understand quite yet. Yeah. So we're gonna work you over for a little while to get you there, right? And by we, I mean those that already do understand it, like myself, and those that are not, like you, because you're listening to this. I'm already there. I eventually figured it out. That's what that is. It doesn't matter. That's how that will work, no matter what. That's the delta thing, you know. Anyways, so that's great. That's great. You know, I can. It's what 20 is. 12 is also. Yes, right. It's always the. Okay, well that's true. Um, it's rather strange though, but the. Is that something that we can use? Yeah, no, let me just 30 times 12 is 360. Yeah, that is pretty good though. It is certainly something. Hmm. 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 Let me just boopity boop divide by 360. And of course, it's not quite yet there. So obviously, we're not quite yet there, right? Like, see the process of elimination that you have to do. It's like, all right, so we've ruled out the first. We can't do it, but we know it's this. We know it's got to be. How do we figure this out? And it's like, well, we already have a sequence that's pretty good. Like, if you could ever find that 215, you'll always get the final factorial, no matter what. It takes no steps at all. Right? Yeah, but that's also divisible by that lowest common denominator. Remember that? Right? Yeah, 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 yeah. 30 is by two and two and two. Every one of those was by two. At least so far. You know what I mean? Right. Yeah. Well, yeah. Okay. Sure. Okay. Sherlock. What if we divided by two? What? Wait, why would we divide? Because 15, right? So it's 30 divided by 2 is 15, and then 215 divided by 15 is 14.3, remained it apparently just constantly. But you know what? I bet you there's a sequence here. So we add in that in a way, because we can brute force this for what it's worth. This is what it looks like. It's like 215, right? But it's like, right. We have 15, right? We have 20 by the 5 and a 4, right? Well, yeah, but then we also have that also by, the elephant in the room of otherwise known as, what is that, 12? So it's like, let me do that. 12 times 20, 240. No, 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 no. You get out of here, you. Everything about you sucks. All right, we'll do 3, 0, and add the 20. That's 50, of course. But then we have to add. No, 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 no. There's a way to do this. There's a way to do this. There's got to be a way to do this. Oh my God, my head is. We're going to be able to do this. I'm already seeing it in the future. I swear. Con artist tricks, magician stuff. Sense it. So we're gonna get this done. I was like, well, you got the 5, right? It's like, right, well, but remember the lowest common, the 2, right? I was like, well, yeah. What does that have to do with anything? I mean, is that really that relevant? I was like, seemed pretty relevant. Fucking relevant. Maybe I can walk you faster to it. I want to be done with this. Right, so that 2, right? Remember that. I was like, let's do 2580 divided by 15. 172. Who would have thought that, huh? Is 172 divided by 12? No, almost though. Oh, that's too bad. So, anyways, what about that divided by that? It is. Is that number divided by that number? Almost. So let me just see here. And then it's like, right, but we also have this number, right? Oh man, it's keep popping. It just keeps popping up as the same fucking number that I'm dividing. It's like 14.3 remained constantly. It's almost like I've already figured this out. And none of you saw it. Because I just keep fucking doing it over and over and over and over and over again. I just keep doing it over and over. But we're going to get there together, okay? We're all going to get there together. I'm gonna change things. Anyways, so we already know the next sequence, right? And then you just, right? So it's 6, that's 5, right? That's 30, right? And then you multiply it by 6. What do you get? 6 times 5 multiplied by 6. Right, that's 180, right? Yeah. Okay. All right, 180. All right. So 2580 divided by fucking 180. Seems to be the same fucking number every time. I'll tell you. What is that? The multiply by 2 and then add 2, and then you just add that fucking number by 2. It's this close. It's so fucking close, man. You can taste it. You can fucking taste this shit. I swear I can taste this shit. Anyways, I'm starting to see a pattern emerge here. Every fucking time I multiply it by the first number. Ooh. Right? 5 times 4 is 20. Right? Back to the same number. 5, that's 100. So fucking, man. Anyways, it's always, I'm sensing something. Future stuff. It's almost like it's impossible not to understand somehow, some way, how this could all come together. Can you shut up? You're irking me. I'm gonna go in the comments. You fucking dick. I'm icked. It's so much ick. Anyways, all right. So we're gonna talk about this just a little bit, right? So we know the 12 from that 6, and we know the 6, and it's always seemingly the same fucking thing. You ever notice that? Right, and then this and that. It's like it's so close. You can get it just that fucking close. I mean, do I even need the 215? It's like, well, how hard is it to get the 250? Yeah, but you know what that number? You know what that number is? 86, right? Remember that 86? Yeah, it's divisible by the lowest common denominator again. Divided by 2. Yes, 43. Remember that 43 that showed up before earlier in the video? All right, let me just multiply 43. Does that give me the fucking... Jesus, fuck, I hate you. 172 divided by 43. Is that 4? Oh my gosh. Right. It is 4. And there's a 4 there, right? Yeah, there was a 4 there. I think there was a 4 there for the sequence of the step number. So it's like, I can get to 43. How do I get to 43 again? Well, there's a 6. There's a 2. There's a 12. Some 5s. I don't know, man. There's probably a couple. Anyways. Yeah, we're nowhere near being done, though. But we're all going to come together. Really? It's like taking all of the wires around the car and then soldering and, doing the thing where they're connected and making sure everything's good, properly put in all the fucking holes and stuff. It just buttons up and it takes a really long time. Every time it takes a real fucking long time to get it done. But we're gonna get there. There's a sequence here. You remember the sequence? There's a sequence. There's a sequence. There's a sequence here. There's a sequence. Anyways, because I'm a dick about it. That's what that is. So, say, all right, you look at the 5. All right, we're gonna go back to the 5. All right, and saying, oh, we already know about the lowest common denominator thing. Right? The 30. I mean, right? And it's like, right. I'm noticing a pattern with the lowest common denominator is always going to be the case. As something that is always there, along with the final fucking number of steps, which is actually the number of steps with the lowest common denominator. Anyways, point is, and the first and the second and all that, right? So, noticing a lot of that. It's like, all right, so where do we go from there? Okay, we got to get there somehow, right? Okay, yeah, cool, but how do I get there? That's a good question. That's the question that we're trying to answer. Like, you don't know. I don't know. I actually don't know. Let's just work together. Well, I don't know, and now I just don't know. We're just gonna work it together. We're gonna come along together for the ride. All right. So I'm stalling. Let's stall some more. Let's all work together. Stall some more. We're gonna get there. Obviously. See the future. Right. So working this out, plain and simple, step by step. Let's do it. Let's do it together. We know 215 is divisible by 5. That's great and everything, but it's not exactly something that you can just figure out without like knowing effectively at least the last two, right? 'Cause that's 3 and 2, right? But it's like not really, because it's 6. It's fucking stupid, right? Like we've already got like a way to do this, don't we? We can just work it out, right? And it's like, well, yeah, no, but you don't know what that number will be. Even though we have several numbers that will absolutely work out to definitely being the final number. If you know ultimately the right sequence. This is what I'm saying. Every fucking time I'm saying this. It's like, oh, I can divide the final by that. Oh, okay. How do I get to that number? It's like, I want to know that fucking number. How do I get it? How do I fucking work to get any of the numbers that'll work out to that number? Behold, there are multiple ways, right? And I was like, how do I get to the fucking, how do I, multiple fucking, there are multiple ways. So far, we're saying there's multiple ways. We've figured out multiple ways in the sequence to always working out the final fucking factorial faster. So far, we've been saying it unequivocally every time. And there are multiple ways to figure it out. If we use division, but you have to have the number, of course. So how do you find a number? What's that algorithm? What's that really going to be? In this sequence, in this, in that. How do you get to that number? How do you check that number with other numbers to ultimately then go, yep, and then use that and then get to this number? Because that's all we're going to do. Do you see it? It's the only thing we're going to do. Say, I use this first number, right? That's good. I mean, like 30, right? It's divisible. I mean, it's definitely. Oh, for sure. Yeah, no. And then same thing with 215. That's another one. You got the lowest common denominator with the final is 12, of course, right? And the same thing with 6. It's still the most. It's all divisible. It's almost like there are multiple numbers here I could figure out somehow. I just need to figure out any one of the numbers. That's the other thing I need to do. It's almost like factorials are extraordinarily easy if I could just figure out one fucking number. By the river with government cheese, I swear. One number. All I have to do is figure out the one fucking. How do I figure out one goddamn number? How do I figure it out? Yeah. Plagued question for the ages of mathematicians, I swear. And don't look that up, by the way, because they have many ways of figuring this out already. You're going to come along for the ride and you're going to learn. That's what you're going to do. You're going to come along for the ride and you're going to learn. You're going to stick together with me on this fucking video. All right. So we're all learning together. As you can clearly tell, I'm bored of trying to make the joke, so I actually really just want to fucking focus on this. Right? Which is really what the big issue is at this point. So, how do I figure out a singular number from this sequence that will always work no matter what? We have a lowest common denominator, we've got the 12, the 10, the 8. It always seems to be seemingly two more, right? In terms of its sequence. First one is always this one, but the next one in line is always divisible. It's always divisible. How do we figure out divisible numbers? How do we do that? How do we do the reverse of divisible numbers? Is there a way to figure out that sequence? You know what I mean? Right? It's like, right, all right, well, 30, right? And it's like, right. So there's always going to be a way to do it. And this is how we crack encryption, just FYI. This is one of the reasons why nobody likes to teach you that shit. So it's like, all right, wait, what? All right, 250 divided by 30. It's 86, right? It's like, right. Right, 86. It's like, instead of figuring out that, why don't we just brute force it? Wouldn't you just brute force it? You do 30, and then do 86 times. 86 times? I don't know, man. That seems like a lot. It seems like more steps than the first step, right? It's like, oh, right, yeah, no, that's, well, Meanwhile, me, 86 divided by, what's the lowest common denominator for fucking 86 divided by 12? Divided by 6. No. Oh, it's all working out the same way. Sure is. Shockingly. It's 14.3333. Anyway, 2 is 43, of course. We got the 43. We know about the 43. Everybody's got the idea of the 43. And there's 3, and then there's 4. And what is that? 21.5? I'm seeing a fucking number that I could absolutely. 21.5? Hmm. 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 21.5. Doesn't that work out to be 215? Yeah, well, not really right now, but no. Let's move on from that. Okay, I know I can't divide it by 5. We all know that. So is that 86 divided by 3 again? What was that? Oh, that was 28.6 repeated, standard stuff. What was it, 2? Yeah, no, that's 43. Right. Yeah, no, 43 is not divisible by basically anything. I'm pretty sure it's prime. 33 divided by 2, 21.5. Yeah, let me just do that again. Divide by 2, 10.75, divide by 2, 5.375. I don't know where I'm going with that. Anyways, it's my dog wants to play with the bone. All right. So we're gonna keep looking. So it's like 6 and it's 30, right? 30. But the next sequence is 4 and 3 is 12, but it's also 5 and 4, right? Oh yeah. Right. So it's 20 and 12, which is 22. 6, right? 30, 22, 52. So that's not gonna work, right? Ping. onto this idea here. Maybe we can use that lowest common denominator. Yeah, right. That we've already figured out. Like, no matter what, we've already figured out what the lowest common denominator is. See what I mean? Maybe we can just kind of focus on the lowest common denominator. This is 25 divided by 2. It's 1290. Okay, cool. Divide by 2 again. 645. Divide by that. 322.5. All right, so we'll go back one more. So we're already at 645. All right, and then that's divided by 5. Sure is. Divided by 5. That's 129. Right. Because this is the real lowest common denominator. Every time it's the lowest common denominator. You ever notice that? Yeah, eventually they'll all hit on it with me together. Together. Meanwhile, me just gonna go Google something. How do you reverse lowest common denominator? It's generating some things. List all factors, lowest common, and do revert to list all the factors. Well, the factors, all the it's almost like we could still brute force just a little scotchy, amount. Right? Yeah, no, right? Yeah, right, yeah. So like 5. Is that for 215? Gonna be, it's a 215. It's almost like I've been leading you there. Oh no, it's 443. Where did I see that number? Let's see here. Let me just 43 divided by 2 can't be done. 1, yeah, for sure. 3, not happening. 4, nope. 5, 6, definitely not. 7, nope. 8, definitely not. But these are a lot of similar numbers I've been seeing. Anyways, let me just try out that 129. What is that business? 129, you know what I mean? I should fucking divide by 6. Oh, 21.5. Let me just divide by 5. Of course, no. 3. Oh, fucking 43 again. How did. What? 2, 64.5. I wonder if I could just use that as like a brute force method to just get in there. We're going to do it together. All right. Right. So it's like, all right. So we know it's the lowest common denominator of one of the numbers of 5. Right. Let's just go with 5. Right. Or is it? So it's like 43 divided by 6. Well, that's not going to work. But 3, definitely not. But 2, for sure, no. But 5, no. But 9, right, we just did this. Why are you doing this? You jerk! I can't use the 6 at all. I have to use the 5. You suck! Anyways. So it's a 5. Alright, so how do I get it? So what's this 215 divided by 5 again? It's 43. What? And then we're going to multiply that 43 by like what? This lowest common denominator? 2. Right. What is it, 86 again? Right, so 2850 divided by 6, 430, divided by the 12, 215, of course, divided by the first two numbers, 30, right? Right. 6 and 5. Right. That's 86. And you divide that by the lowest common, and it's 43. So if you already know what the lowest common denominator of the final end result is of 2580 divided by 12, which is 215, right? I mean, we can't really use that, or can we? We'll see. All right, so anyways, let's say we just, we couldn't. Or wait, let's 25 15 divided by 6? No. There's 4. Nah, can't be. 3. Nope. 2. No. 5. Oh yeah. Are we getting there? Perhaps, maybe. Maybe I can walk you to it even harder. So, anyways, it's like I was thinking about this. You know what I mean? Because we have 30. You know, there's a 43 times 30. What is that again? Oh yeah, no. And then we're gonna multiply that by 2. Is that the right number? I think that's the right fucking number right there. Let me just break this down. You know, in the future here, I'm seeing that I'm getting this done. I've got a sensation. It's like hard work paid off over time. Shocker. So, anyways, we're gonna brute force this with 5. Of course, we have the 5. We know the 5. What's 5 times 12? No, stop it. You suck. Get out of here, you little miscreant, you little fucker. Anyways, so 5 is the lowest common denominator. What is that lowest common denominator of? Right? Of what particular number? That's the fucking thing that we're doing right now. 43. 43. It's the lowest common denominator. 43. Okay, so like we've already figured out the next sequence that we have to figure out every fucking time. We've already figured it out. Right? Like, what's the lowest common denominator of 5? Right? Well, it's 43, right? It's like, no, it's what do you multiply 5 by to get the lowest common denominator for this number? In the next sequence. No. Let me just do it with the 4s real fast. Right? Because like 5. All right, so it's 5. So it's 4. All right. It's the lowest common denominator of what is this number? Oh, okay. I don't know how to figure that out. Oh, okay. All right. I mean, there's a lot of different numbers for what it's worth. That is fair. With the way I phrased it, there's a lot of numbers. So, what did we know about this other number? Okay, just this other number. It was previously just this number that we were using. Well, it's fucking 5, I guess. Yeah, no, right, yeah. I'm never fucking do this, man. Aren't I? It's like pulling hair out as a teacher, I swear. God damn. Where's my teeth? I've forgotten. I've never gotten them. I had to pull them out before to even get to this point. Jesus fuck. Anyways, so you know 5 is the lowest common denominator. It's going to be 43, of course. That's nice, right? It's super awesome, right? Except we're not there yet. We have to figure out what that is and why it is that it's relevant to any of these other numbers. Which, of course, it would be 12. Because, of course, the only reason why we know that is because we now know the lowest common denominator of that number, right? And then we can use that with the first number to ultimately work out always to the final factorial of whatever that is, right? Well, yeah. So how do we do it with 5 factorial? And how do we work out a lowest common denominator? We're getting there. It's gonna happen. No worries. Right. So it's like, how do we figure that out? How do we figure out this is the number that we're looking for? Right. Like the 12, right? Okay, right. But we don't know what the final number is. So we can't know that. Right? There's no way to know. If you are bone stock, you literally don't know what the end result is. You've got to figure out that number. But we know that that number is the lowest common denominator of the next number in the sequence. Right, yes. Right. Right. Well, yeah, no, but like I could just how do you work that out? How do you work out the reverse? So listing all the factors of lowest common denominator. Start testing lowest. I hate that. That sucks. There's nothing good about that. Yes, but when you get to fucking 3 million, I think you'll do it. Anyways, let's just not do that though, for real quick. So we're just gonna get this done. 'Cause I'm getting pissed and I'm hungry and I want to finish this. You can clearly hear it. That's the meta of the meta of the meta right now. Okay. Right. So we're gonna think about it for the 5 factorial. We have a 4, right? And we know that. We know that like that 8 is there. Okay. We understand the 8, right? We know the fucking 5. We got the 5, right? Right. So it's like, how do we work this out? It's like, right. So how do we, what's the lowest? 4? Is it 4? Is it 4? Is it going to be 4? Will it be 4? Will it be 4? I mean, it's only going to be 120, right? So yeah, well, and there's 8 there, and that's 2 is the lowest common denominator. Right, yeah. Right, well, so there's a 4, and there's the lowest common denominator of what number again? It's not, though, because it's 2. Oh, is it? Okay, so it doesn't work quite the same way. That's fine. All right. Right. Yeah, no, but what about this number specifically? That 4 could really honestly be the lowest common denominator of? I don't know. Of course not. I have to pause this because I want to scream. It's kind of like a prime. You know what I mean? Like 4 can ultimately be multiplied by this number, and it will only ever be that 4 is the lowest number, except it's not, because it's 4. Which is kind of the problem. You know what I mean? Yeah. Like it works with fucking 6, but like it's whole thing. But it's still like divisible by 2, which means that at that point you will be able to use 2 still as that number, which is the problem. So it's like, well, then you just switch it over to 2, which then it's like, what would that be? Mm. Mm. Yeah, no. Man, I am genuinely tired. But it doesn't really matter. We're gonna get there. We're gonna get there. Um, so let's go. This is least common, most common. What is it? Which version of this is it going to be for people? You know what I mean? Because we already figured out how to basically brute force all factorials right now, at least for number 6. Yeah. So it's like, all right. So, so 5. I only know about it being 43 because of that given number. Like you need to know the fucking size of that number, which is the thing. So it's like, how do I fucking figure that one out? Which is the question. It's like I only know that it's going to be that thing, and I know it's going to be the. So it's like it has to be divisible ultimately by this number. Yeah, the number of steps. No. The sequence then multiplied by 2, then added by 2. Right. So, like, no matter what, like that number will always be a number that this number is divisible by. So it's like, do I even need the lowest common denominator at that fucking point? Because it's like, well, then I'd just be able to skip forward to the number of steps. No, not steps. No, sequence. Which would then be fucking 12, and then 12 times this number. This is 215, right? Which is lowest common denominator of that, isn't it? No. Don't even try. But it would be a lowest common denominator by 2 for what it's worth. It was like 215 divided by 2. One of them actually by 6. Huh. Good question. Oh, by 5 for sure. Yeah. Well, that's what we're doing. Yeah, right. I forgot about that. Yeah. Right. This is annoying me. This is like, how do I describe that? No wonder why, they go through school for a long time to do that, right? Nice little call out. Oh, your math teachers that must have looked at you like you were a fucking retard for a while. Okay. Anyways, it was like that's the sequence. So you always have to find out what that number is that's there, because like no matter what, that number is always that number, right? Like so, it's like this way. That final like 8, 10, 12, whatever it is, right? It's always going to be this given number, which will always be divisible by the next number in line, multiplied by something to ultimately get to that number that you can then multiply by the first number. So if it was 4, then it would be so 120 divided by 5, which would be 24, right? And so since it's 4, it would have been 8. Then it's a divisible number by those two, which is nice. That works, but like that's not going to work very well because you need a lowest common denominator. It's like, oh, it's super easy. I can just cheat this. This is x plus fucking 2 is equal to 4. And it's like, well, it's 2. I mean, okay, well, to move that over a little bit and do some of the fucking math, right? So that's the problem I'm having with like ultimately myself on how to describe this, because it's like, all right, so we have to figure out again how to do the stupid like thingy. You know what I mean? Because we have to do some fractional math, unfortunately, for some people, because it's like, right, it's 12, but it's also the 5, right? And it's like, right, but we also happen to know an x and y value that we have the ability to multiply by 6 to ultimately get, because that's what we're doing. So we did 5 times 43, right? And then, oh yeah, no, we just multiplied it by the number of steps, right? Right. Well, no, that's not the number of steps. No! Stop saying steps! 2 plus 2 times 2, then you add 2. Shut the fuck up now. Become the angry guy. Smack the ruler in your desk. Anyways, so since we already know that, because you just need the next number in the sequence, right? Yeah, but it's literally what that is, because it's like 4, and then it's like it just worked out to be 8, right? Yeah, literally, yeah. Like it literally just did though. Well, not for 8, but it just worked out that way. Happens to be pretty nice. Yeah. Okay. So that's 4. It's well, those are lows coming out, right? Right. So like that actually needs to be. What is it? 120. So we need to get to 60. Right. Yes. Well, actually, no. No. 120 divided by, which is 8. It's 15. Yeesh. This is we're gonna have to do it again. Right. It's 15. Wouldn't that be? Yeah, but see, that's the thing. It's like, that's for that one, right? It's like, but if we do it by this way, which is 20, well, 5, which is 24, okay, which is what we're doing, starting with the first one. So it's like, if we do that one instead, because that would be easier for people to probably remember and recall, even though there are multiple ways to do this. So if we do 2580 divided by fucking 6, which is 430, which is how we were doing it, even though you definitely don't necessarily need it. I see what you're saying, right? Yeah, it's faster, but it's like, yeah, but it's a little bit more difficult and complicated to do, right? So it's like we divide it by the first number in the sequence, whatever that number is, right? Then like we know that that number divided by uh, the number of steps. But lowest common denominator. Thank you. See what I mean? It's like, hey, there we go. But it's like, all right, that's cool, except that kind of sucks. Not really, but okay. Or 30 divided by 6. No, 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 no. Shut up over there. Ah. See what I mean? How, like, eventually math just becomes people shouting at each other. Anyways. All right, so instead of that, you can always divide it by the first number in sequence. So it's like, all right, 128 divided by 5 is 24. That 24 works out that ultimately you can use the step number to get there, which would be 3, right? Yeah. Well, you divide by 8, and it's 3, right? Right, which is the lowest common denominator of that number to ultimately get to this thing. So as we take that number, that lowest common denominator of that fucking number, then you'll always be able to use that number of that multiplied by the total number. It's not step number. It's the sequence number multiplied by 2 added with 2 at the end. Okay, we're done. We're done with that fucking stupid step. Shut the fuck up now. We're already finished with you forever. Which, by the way, still fits within the step numbers. Sure does, yeah. Anyways, step numbers, right? It's like, all right, cool. Does it? Well, yeah, no. That's the thing. It's like, well, it's 3. There's a 3 would be really easy for you to kind of understand and be like, what's the fucking largest number? And so you go like 2 is 6, right? 3 is 9. 4 is 12. 5 is 15. Oh, huh? No way. Anyways, just gonna move on. This is like, all right, so it's like 6 is 18. 7, 21. 8, 24. That's a number I can use. It seems to get me to the eventuality of the number I'm looking for. 120 divided by 8. So 15. Right, yes. No, but you did skip by, but I see what you're doing. Yes. So 120 divided by the first number. So 5 is 24. It's almost like there's 2 ways to do this, and they work equally as well. Some of them are a little faster than others. It's almost like you use both methods for sure to know for a fact what the factorial is at the end. Yeah, that's probably what that would be. Anyways, so it's like we got this 24, right? And it's like, well, yeah, but we don't know that that's a thing, right? But it's like we do know that this number of steps and then this thing, okay, is still a thing, right? So it's like we know that this has to effectively use the first number, which is 5, right? So it's like, right, first number of 5. We know that this, so 5 times 4, 8 is 40, right? But it's like, no. No. You got it all wrong already. You're already going too far. It's not what you're supposed to do. Right? There's a number there. Okay, that's what that is. I already hinted at it. You have to keep fractional math out. So it's like, right, so this 5 is this number and this number, which will both effectively be these numbers for this common lower denominator between the two. This not step number, sequence number multiplied by 2 and added with 2. Okay? And then you have the first number, right? Which, by the way, when this number that you just found out, 3, you found out 3, right? Will be a common denominator, right? Whatever that number is between those two numbers. for these two numbers here. That's fractional. That's algebraic fraction math. That's literally what we're doing. So it's like if you look at 6, if you look at 12, there's a number here that both of them can work into as a lowest common denominator. That will absolutely give you the final number. So 258. No, douchey fuck. I'd kick you out of my class so fast. So 2580 divided by a lowest common denominator of 2 is 1290, right? I was like, well, that's a lowest common denominator, right? Right. Between just the two. And this will still work just off of that. Right? It's like, all right, cool. We're learning step by step. All of a sudden, you're going to figure out how to do a fucking factorial. Super easy. It's so close. All right, so 1290, right? So yeah, that well, you don't know what that is though. Like, right. So how would you figure it out? It's like, I thought we were close. I don't understand how we would do this. Okay. All right, so we're gonna take 6 and 12. All right. So the lowest common denominator of both of those is 2, of course. But what's the lowest or the maximum? Like both of those, right? For their lowest common denominator, go into as well. 12. Okay, it's 12. All right. Right. Now we got 2. We got 12. All right. That's cool. That's good. Right. So as a result of knowing those two things, then we know a little bit more, don't we? Since we already know what the sequence is, that'll always be for the next one in line as a number that we can use. Right. So it's like, right, we have 2, and we also have 5. That is the lowest common denominator, right, of a given number, or a number that we can ultimately multiply by to get a number that we can multiply by these two other numbers and a multiplying of this lowest common denominator of these two. So it's like, we're so close. Remember? It's like we're gonna fucking force you to say the words. The fucking teacher's gonna get you there. We're gonna slap the shit. Where's the whip? Whoosh. Ah! We're gonna get you there. All right. So, like, all right. Like, all right. So 6 is cool, right? But let's go with the 5. All right. Then we have 10. Okay. Still 2, surprisingly. Unsurprisingly. Right? What if there's a number we could just like figure out from that 4? It's gotta work somehow, some way into this. We know it's gonna be there, right? It's gonna be. Okay. So it's like, all right, we have a 5 and a 10. We already know that we can multiply those two, right? Yeah. Right. Well, that's not something we're gonna do. So sit down over there and shut the fuck up. So then we're gonna get this other number, which is important. This 4 involved. It's far more important than any of your other numbers. All right. So like we know as a result that number 4 will absolutely need to be multiplied by this first number Did I say that right? Give me a second. So that means 4. Yeah, I did say that right. Right, because it'd be 120 divided by 5 is 24. Right. So like no matter what, that number is a lowest common denominator number of that number is what I'm seeing. So 2, which is 10, that'd be 12. Right. That's the incorrect thing to say. It's just fine. But it is by that number, the next one, which is what the whole point was. So it would have been 2, which would have been right by that number, and that means I can use that lowest common denominator trick to effectively figure out that 24 is there. So it's like 4 lowest common denominator, right? Except 5 is a prime and it's already a lowest common denominator, so it doesn't need to be used as anything divisible. Like 3 was already 1. 4, 3, 24, 3, right? So every prime, every lowest common. So it's like you'll have to, on the bigger ones, get further down, but every prime number means you don't need to do that. Okay? Which is fine. So that's already a trick we've got. Figure it out yet? You fucking stupid cunt. I hate you in our class. I want to learn. I would fucking kick you out myself as a student. You suck. I was hinting at it for fucking hours. This motherfucker still doesn't get it. I hate him so much. You don't understand how much hatred there is. I just want to go do other things. I'm fucking at all. Are you insane? You fuckers. All right. So, anyways, we're there. We're almost there. We're almost fucking there. Almost there. We've got this. We've got it going on. Okay, we've got it going on. All right. So, right, it's 4. It's 2. Right. We understand that it's going to be this. Right. This is a 2. It's a 2. What's the 2 gonna be? What does this 2 mean? What does this 2 even mean? I fucking shit you not. What does this 2 mean? What does it mean in any aspect or way? There's a sequence here I don't understand. Well, there's a 3 right next to it. What does that have to do with anything? I don't know. Let me just take a look over here. Just take a look over here. There's a 5. There's a 4. Hmm. 5 and a 4. It's 20. I mean, let me just do that fucking number. By 2, 1290. Right, yeah. And divide by 20. 64. It's not gonna work, unfortunately. Unfortunately. But we're gonna get there. So how do we figure out what that 2 does? How do we get there together? Alright? How do we get there together? How do we do it? How do we get there together? So we gotta get that 2 to mean something for us. Right? Well, yeah, I mean, but how? How do we do that? I would like to know. Lowest common fucking there's an 8 there. There's an 8 there. Right? Except there's not, you fucking idiot. Stupid idiot fucking student. I hate you. Stop interrupting. It's a 10. Fucking dick. Ah! Right? Anyways, it's 2, right? Of course. There's a 10 there. There's a 2 there. There's a 5 there. There's a 4 there. We have to get to this number that 4 with the 2 ultimately equals somehow, some way, a number that will equal this final factorial. How do we figure that out? How do we get it? How do we figure it the fuck out, honestly? How do we fucking figure it out? I hate doing acts like this. They just make me seem like I'm fucking stalling. It's the worst. This is the fucking worst. I want to be finished with this already. I'm hungry. Don't say I don't put in effort for you fuckers. Okay, anyways. So 2, there's a 10 there, there's a 5 there. We'll figure this out somehow. That 4's got to be fucking involved for sure, no matter what. It's definitely involved. It can only be a divisible number by the lowest common denominator and the number next in the sequence is what I've seen so far that you apparently just don't fucking realize. So you gotta use these 2 fucking numbers. It can only be one number that is divisible by these 2 numbers. No matter fucking what. Unless it's a prime. In which case, then it's just that number itself. We're getting there, folks. We're getting there. Because 5 is a prime, and so it'll just be like a multiplying of that number. 43 is a pretty prime. Let me just do that whole 45. No, I'm sorry. 43 times 5 is 215. Right. Yeah, no, except 43. Oh, and then there's the lowest common. Right. Well, I mean, it is prime, though. You could just skip. That's true, but that's not what we're doing. It's fair. I do like to fuck with them fucking damn bastards. Keep fucking with me with the fucking. It's the step. It's the step. It's the step. I was like, oh yeah, and it's a prime, so that means you don't have to. Well, fuck with you. You fuck with me too. I'm gonna fuck with you. I'm gonna crush your tiny little soul. Anyways, so it's like that's the multiply by 2, add 2, the whole sequence number thing. And what it does, what did it do? What did it do? I don't know. I mean, it's fucking something, man. It seems to be a lowest common denominator of the first number and that number. Seems like, I'm just throwing it out there. I guess it's 2, though. It seems like it's always 2, you know what I mean? Anyways, this number, of course, it has to be by this other number in the next sequence. And then this other lowest common denominator number seems to have a number that you can always get, no matter what. Except not really. But you can always get those numbers. You know what I mean? Just fucking acting so hard right now. Is it coming across well? Is it too much? Is it okay? Does it sound convincing? Is it good? Is it good? You gotta get this number. It's fine no matter what. These 2 fucking numbers. It's gonna work every time. Every time. No matter fucking what, I swear. What is that, 86? Is it divisible by 2? Fucking hell. And then there's, what is that, 12? Holy shit. Yeah, right. Damn. And all those numbers are really good numbers to be able to figure out the final factorial. Too bad we're not doing that. It's not what we're doing. We're not going to figure that one out because you can't figure out how to fucking use this number. Ah. Where did I describe it? It's going to be fucking awesome. It's going to be like a not anticlimactic at all after all of this work and fucking humping the goddamn thing in, just flapping away in there. It's not going to be as working it real hard. You're going to drink wonderful mountain springy water. No dehydration. Perfect. So, we got this number. All right, we got this lowest common, we got this other number. The sequence is going to be a thing. It's 5. Of course, it has to be something, right? It's like you can either use the lowest common denominator or you can use the steps. Okay. Remember? The steps is fucking 10. Can't use the steps. We can use the lowest common denominator. By that number in the next in the sequence, and then this number for the lowest common denominator, and it has to be a number with that, and then with the steps and or the first number and the fucking factorial can then be figured out for the end. So it's like, all right. So we got 4 here. We got 10 here. Right, we got 5 over there. How does this 2 factor in? How does this 2 work? How does the 2 do things? The 2. Anyways, look at this 5. We got 5. We got 5. Fucking, okay, we got the steps. It's 12. It's got to factor into this 5 and 12 somehow. It's got to be a number that's in between this 5 and 12. You know, for a really large number that they both effectively go into. But it's, you know, fucking, what is that number? How do I figure out that number? Let me just take an X here. I got a 5 and a 12. There's an X on the field now. There's an equals Y. What is that? What the fuck is this fucking thing? No, we gotta figure out how to fucking do. We got 5x plus 12x equals Y. All right, we're not gonna get anywhere with that because, of course, we don't know what it means. We don't know anything. Nobody knows how to fucking do this. Everything's wrong, bad. Do it different. So figure out how to fucking do algebra a different way somehow. You fuckers. Because it's not 5 plus, and it's not 12 plus. There's no pluses. You can't do the pluses. You can't do that. You just can't do it. Okay, so we've got to change this. Okay, that's the wrong way to do it. You've got to change it. That's right. I'm going to do this differently for you. I'm going to figure it out for you. I am the teacher that's on your side. I'm going to do it for you. All right. So it's like, all right. We're going to figure this out together. Okay, everybody? Class, gather around. We're going to do it. That drinking of that water is good enough. Here from the future. Fuck yeah. It's good water. Fucking amazing water. Definitely not amazing. Big sploosh. All the things. Anyways. So we gotta think about this. All right, so it's like, all right, so this is 4. All right, so we're doing the 120. It's easier, smaller numbers. Okay, we got 4, we got 10, we got 5. All right, is it X? We gotta figure out this number in between. We do. Absolutely do. Or do we? Do we just fucking yeet it and just run? Just never do this again? I'll never go back to the whiteboard. I'm over this. See you later. No, we cannot, because I'm recording, and so obviously I have to finish this eventually. So this is gonna happen. It's gonna happen. He's like, all right, so this 2 business, the 4 business. Well, yeah, no, it has to be. Right, because of the lowest common denominator. There we go. You're paying attention, student. Thank you. Awesome. You're learning with me. So, all right, we got it. It's 4 and it's 2 and it's pretty fucking, it's a number no matter what. It's divisible by this fucking thing. All right, for the lowest common. Yeah, all right. Yeah, so there's gotta be a thing here. Figure out how to do these. What is it though? I don't know, man. I fucking got me, man. I don't fucking honestly, I don't know. What is it? 120? Is it 120 divided by 5? 24? Right. So I have to get that, and then there's just the first one in the sequence, right? Since we need to remember, students, the river of my cheese. Anyways, so it's like, all right. How do I just test them? You won't know. Except actually, I decided to tell you every bit about how to know if whether or not it is. Because if you divide it by the first, and you multiply it by the first fucking number, it'll always be the right fucking number. No matter fucking, I think it's a 2, 5, 8, 0, divided by 6. I only need to get a 4 fucking 30. It's like no matter what, that final number you get is always divisible by the first number. Remember that? You can always test it. You can always know it's right. So we're gonna fucking figure. We're gonna 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 figure it out. We're gonna figure it out. Get the '80s school teacher vibe coming in here. You know that movie. Oh yeah, man, we're getting in here. I'm a dick about this. God, I've got to stop trying to fucking act. This is overacted bullshit. It's the worst. Still though, I liked it though. You know, for what it's worth, I enjoy doing this because I like fucking with people. That's what I like to do. Anyways, all right. So it's all right. All right. So we can just test them. Every one of them you can test. That's right. So it's like 4 and 2. Well, it can't be 4 or 2. We know that. There's no way. It always has to be higher. No matter what, it can never be those numbers. All right. Okay. All right. All right. Cool. All right. So then it's like, all right. Fucking 8. Nope. Didn't check out. Shit. Fucking. So 8 times fucking 5. 40. Yeah, it's divided by the. Nah, it can't be 8 though. How do you know? How do I know? Oh man, that's super simple. Watch this. I can just look at the amount of numbers there, says the student. You fucking idiotic teacher, you retard. What are you doing? What the fuck? Obviously, it's not that fucking low. For 20 times 3 is 60. It's already over that. Oh my god! It's like you could just check! So obviously, it's not teacher, apparently. Or are you the student? Which one? But we're gonna move on because I'm tired of that. I'm tired of that act for real. Because fuck you. How do you know? I mean, divided by even, and and all that. So you can check, you little fuck up. That's the explanation. Exponentiation, not explanation. Exponentiation. Right? So like, all right. Well, for that one, sure, jerk. All right, we're gonna go to 16. Actually, there's 12 there. Right, yeah, 12. Can it be by the first one? I don't think so. No, because remember, like it's not always the first one. We have to also do the steps. What are the steps? Oh yeah. Right. Because we didn't do that. It's almost like I knew you would fuck this up and try and start it off with the first fucking number. Anyways, 8 times, what is that, 10? 8 times 10, that's 80. Times 5. 80 times 5. Let me just get that out. Yeah. Times 5. 400? I think that's not fucking anywhere near what that number is supposed to be. Let me just divide that by fucking 5. It's 80? That's not what that number is going to be. Let me just fucking. Oh, God, it wasn't. Fuck. No way. It's almost like you should have fucking learned some math before you said something about 400 being a factorial 5. Loser. What are you doing not checking? Doesn't seem like it's right. And you know what I'm saying? It's like, right. But you don't know that that's not the number. Exactly. That's exactly right. Thank you. You said it correctly. That fucking dick didn't. He implied something. You said it correctly. See what difference, like how you say something get you? Fucking dick student. Anyways, we're gonna move on. It's like you don't really know. Except you can check that one because factorial 5 is pretty small, so you can just do that. Let's go into a harder one though. After we go, like, oh well, 12 didn't work. Still not the right fucking call. Because we didn't use the lowest common denominator, right? Oh, that's right. That's what. Remember the sequence? There's a sequence here. Remember? Oh yeah, we're just gonna move it. Oh right, yeah, I know that thing. Yeah. Right. So there's 8 times 2 is what now? Oh wait, is it? Is it? Oh, that's right. It's 32. Right. Because we have to use the 4, of course, and then we have to do the times 2, the denominator. Or do we? Do we now have to use the 32? Does anybody else remember what I said? Were any of you paying attention? Pound. Big old fucking massive sound. Right there in that moment. God, this would be great to animate. I wish I could get a fucking editor or something. Can you imagine? Like fucking just all around. Like you can, if you don't know, I'm pacing a little bit back and forth. Like just imagine me pacing in front of students while some dicks just interrupt and say shit, and I just continue coming over there. Fuck you! Just bending down by the river style. Chris Farley, no! They don't remember your name anymore. The Gen A's. Oh fuck, the Gen Z's. Oh no. Oh shit. Anyways, so we're gonna move on. It's like, all right. So we're getting there. We can brute force this pretty quick. All right. So it's like, well, 8, 2, 16. It's not working. We got to do that 4. 32? No. 32 times 4 is 128, of course. It's already too far. So that's not going to work. Right. We just, yeah, it's still 120. Yep. It's still 120. A number. But like, let's just, you know what I mean? Let's just fucking figure this out. Because like, wait. What was the sequence order again? What are we multiplying that for? Oh, so you were paying attention. The student did listen. You have to multiply it by the first number in the sequence. Remember that? Remember that sequence number thing? Remember the first number in the sequence? Remember that fucking thing? You should have been listening to. Yeah. Anyways, all right. See. Hmm. All right. So this is 4. It's gonna be that. uh, So we gotta get a number that will then multiply. Okay. So we'll try 2. That's 10. That's not gonna work. Try 4. That's fucking like 20. That's not gonna work. There's already more numbers, obviously. That's not gonna work. Try 8. That's 40. Doesn't look like it's working. It's not working. Alright, this is fucking 12. It's 12 now. 12 times 5. That's 60. Didn't work. What do you know? Didn't work. So it has to be divided by the sequence numbers. Remember that? It's like, well, yeah, I know. Well, what? Yeah. Let's just get out the 2850 divided by 12. 215. Okay. All right, on 2850 divided by fucking, what is this? Fucking 6? 430? Okay, it's 215 divided by, able to be divisible by 430? Twice. Have you heard of this shit? That's crazy. So let's just go into that. 120 divided by, what is this, fucking 10? 12. Okay. So that's like 120 divided by 5. 24. It's almost like it's divisible by the last I didn't say this the entire time. You suck, you stupid student dick fuck. God damn it. Ah. Anyways, so the sequence still stands. Here's the fucking number, okay, you know? Alright, so it's not gonna be 12. Obviously, that's just not right. Clear light. So it's 12 times 60, it's not getting there. 16, not getting there. 18, not getting there. No. I mean, 4? Why'd you try 18? Fucking dummy. Is that 20? It's still not getting there. Still not getting there. Still not getting there with the divisible numbers you have. By the way, it's not just the first number. It also has to be a number that's divisible by the fucking sequence numbers. If you'd been paying attention, you would have known that. I've been saying it for fucking an hour or 2 now, where it's just like, it has to be divisible by this lowest common denominator, by this sequence number, and the first fucking number. It always seems to be divisible by this. It always seems to be divisible by this. It always seems to be divisible by this. No matter what, all the numbers have to check out. They always have to be divisible by all of these numbers, no matter the fuck what. It's like you can test it every time. Anyways, we're gonna move on to, all right, so now we have 6, the 6 factorial. Cool stuff, right? You know, we got to 24. It's pretty easy. There's a lot of fucking numbers. Man. Let's do the devising thing. Okay, we're gonna have to do the devising thing. All right, so let's do that. So it's like 120. We got 20. We got this 120 number. Okay, we got 24 divided, and it's times. That's 120, right? It's like, right, well, but how did you break? I mean, that's a big factorial. I mean, that's easy as fuck, sure, but oh, right, yes. Oh, I'm so sorry. Let me do it a different way, so that way you can all learn how to do this, even for the smallest of numbers, instead of walking you there like I was trying to do, because I'm sure some of you probably understood that you could have started with the fucking lowest common denominator. Oh god, yeah, you just need to get to the first real number, because you just need to get to 43, right? But it's like that number, right? That number with a step number. Remember the step number? In no way is a step number, you fucker! You fucking interrupting bitch! It is the sequential fucking order number, you fucking retard! I hate you. Anyways, the sequential number, right? We're getting it. We're getting there, right? The final sequential number multiplied by 2, added with 2 as well. All right, we got to get there. Right, so it's like, it has to be a number. Like, we could have started with 2. Like, literally, I'm not even kidding. We could have started with 2. It's like, we got 8. It's divisible. Right. But we don't know. We don't know. We don't know. How do we get there? How do we get there? No. We have to do it. We have to do it this slow ass way because people don't get things quickly. And that's normal. Okay? It's normal. Because they don't know what the result is. So we have to get there to the result properly, slowly. That's normal. Good to go. It's fine. It's like, all right, we got 2, got all this, we got a lot of numbers here. I don't know how to do this. It's like, okay, that's fine. We're gonna get there together. Okay. It's like we got this 2. All right. We got this fucking 4. You know it has to be involved. No matter fucking what, it's always involved. Right? Right, yeah. No, well, okay, yeah, sure. Yeah. Right. And it's gotta be the sequential number, right? Right. So as a result of these things, you then have the ability to figure out that 24, right? But like that 24 is not what we're going to do for larger numbers, which is why they're talking about this and why I'm talking about this and why everything is talking about this. You can't use the 24. The 24 is out, right? You have to work to 24, right? Okay. So it's like, right. So I'll use the total sequential, which is 10. Okay. I was like, that seems kind of fucking ridiculous. Why would you use 10? It's like, right. Yeah. Well, the answer is pretty simple, because you can always get a number from that 10. Okay, that's there. I should rephrase this because I'm actually genuinely tired enough that I'm just fucking conking out right now. I don't want to fucking do this anymore. So let me just phrase it differently. Right. Like, so we have 10 there. We've got a 4. We got the lowest common denominator. Okay. That means no matter what, that 4, right, and the lowest common denominator can be multiplied. You get 8, and you multiply it by the step number, that's 80. Okay. Now that 80 always works out to being a number. It's like what the fuck is this? I feel like, I mean, we're focused on 24. Yeah, I was gonna spend like another 2 hours trying to fucking explain this to you, probably, but I didn't want to because I'm fucking tired and I'm hungry. I'm so fucking hungry. I want to eat, so I don't want to do that. So we're gonna use 80, okay? Right? And it's like, well, yeah, no, 80, right? Well, it's close, right? And it's like, right. You don't. Yeah. No, because we can't use that, so we're gonna move off of that. That's the wrong fucking call. We gotta get out of that. All right, so it's like we're gonna use those fucking. We're gonna use the next number times that number, right? Really? No, I'm just fucking with you. I am very tired though. Like I am genuinely fucking with you. Just I'm letting you know. Like I genuinely am. But at the same time, it's like I'm just deep into this act and I can't stop myself. So a good way to put it is like, remember that 20 that we were talking about? Yeah. Well, I guess I suppose I don't fucking really know. Right. So 4 is that number, right? Yeah, yeah. The lowest common number is well 8, right? So, 2, and then we can get to 8. So you have to say it all the way, okay? Right. And it's like that, okay? Which I guess I can explain this with the 2580, which would be a lot easier, honestly. So the 2580 for the factorial of 6, which is going to be able to be divided. So we added to 215, 43, so 2580 divided by fucking 6. 430, right? Right, yeah, no, but like, what does that matter? You're fine. That's the first number in the sequence, right? And then you can divide that by the total number of steps. But you don't want to do that because you can use the lowest common denominator. So you get 215. Then you divide by the next number in the sequence, which is 5, which then gives you 43, right? It's like 43. It's like, how would you get to 43 with all of that shit, right? And it's like, okay, that. And I just described to you how to break out reverse style what we're about to do. Okay. So when it comes down to 120, I was like, we're going to think about it like we're going to divide it by the first number in the sequence, 5, right? Then we have to divide that number, right? So 258, right, by the number of steps. 10. Hell. 6, 30 divided by 2, lowest common denominator, right? Alright, yeah, students sometimes. Actually, we're always all students. That's correct. There we go. That's what this is all about. The teacher makes mistakes. Everybody makes mistakes. It's normal. So 120 divided by the first number, 24, divided by the lowest common denominator, 12. Okay. Right. Right. And so we only need to get to 12. Correct. Because in the next sequence, because that's divided by the next number in the sequence by 4, which gives you 3. Yep. All right. So that's the real true lowest common denominator of both of those, which is what I was trying to tell you. All right. So we start with the first number, right? We do that. And then we'll get rid of it, right? Because I made a mistake. So we'll start with the very first number and the next in the sequence, right? Right. And then we then understand that that number has to be figured out what a lowest common denominator is with that number, right? So it's like our lowest common denominator, which is 2 in this instance, has to be figured out with the next number in the sequence, okay? Right. For the first number that we must find out. So 4 and 2 can't be the next number, okay? Well, yeah, right. So 4 and 2, right? 2 and 4 can't be it, okay? And then it can't be 8, right? And you can keep checking every time, okay? But it's like, right. Then you can figure out that 12 then turns into, well, this is a definite number that is a lowest common denominator that can be multiplied by the lowest common denominator, right? So it's like this is a number once you have that next number order, the number in the next sequence, right? So from 5 to 4, take that, then you can ultimately go, all right, well, that is divisible by both of these two numbers, right? And then you go, oh, right. So 12 is, and then what's that lowest common denominator of both of those for 12? But it can't be 4 or 2. It'd have to be 3, right? Because we can't multiply it, right? Well, then, so since we know it's 12, and we have, I know this sounds weird, but you do have to do this. So it's like 12, right? It's like, right, that's 3. So we take the next number in the sequence, and we go 4 times that number, which gets you 12. It just happens to work out this way. Right. And then you can finally multiply that by the lowest common denominator, which gets you 24, which means you can then finally multiply by the very first number, which gets you 120. So we're going to do the same thing now with factorial 6. Right? So we'll take the very first next number. Instead of 6, it's 5. Right? Yes. Right. So then we can use that number, right, with our lowest common denominator of the number of the sequence, which is 2. Right? Right. So then you go 5 and 2, it'd be 10 is the first one, right? And it's like, well, yeah, basically, yeah. Yeah, it's like, well, yeah, it is 10, but you wouldn't want to check that, right? And so you know it wouldn't work, right? But that's not really how you do that, right? It's like, it's kind of, yeah, I mean, we're gonna do it that way because I really do just want to eat and I'm fucking tired. So, like, I'm just gonna fucking do it that way. 10 is, no, we don't have this because remember, it can't be 2. Remember? And that's what I was trying to reference. It's like, it can't be 10. I mean, yeah, it technically kind of is, but not really because it can't be 2 and it can't be 5. Right? That's the number, right? Like you have to remember that that's the sequence, but also that's the rule of this math. You can't have it be those two numbers. Just like we couldn't have it be 4 or 2, right? And it can't be 8 because it'll work to 4 to 2. So the moment we got to 12, it worked to 3, being a different number. That's the lowest common denominator. So it's like 5 and 2 is 10. It's like, right, but that doesn't matter, right? So it's like 20, right? Doesn't work. Can't be 15 because 2 doesn't go into 15. Well, yeah. And it can't be 25 because 2 doesn't do that. Just like you're understanding how you have to go higher and higher up. And eventually you'll end up going to, well, what the fuck? The hell is this number? The hell is this number going to be? It's 5 and 2, and it has to be this fucking number that's divisible by both of these that ultimately has a different fucking lowest common denominator of the two, right? It's like, right, yep, right. Well, but why would you? Because it's a way to do massive factorials way faster. That's the whole point. The whole point is massive factorials versus very small factorials. So we end up going with like, all right, so it's not 10, it's not 20, it's not 40, it's not gonna be 40 fucking. I can't do 43. Nope. And 215 wouldn't work. No. But 430 will. You go all the way up to 430 before you'll really get there. Right? Like that's how far you can get with that. Those two, like that's literally how far you can go. Right? But it's like that's because it's 10. It's like there are numbers though that you can ultimately get to, right? So we're gonna discuss that. So it's like 2 and 2 and 5. 2 and 5, 2 and 5, 2 and 5, 2 and 5. 80? Is 80 gonna be one? Well, all right. Well, I divide 80 by 5. That's 16, of course. That's a different number. And then 80 by 2 is 40. That's obviously a different number, right? Okay, all right. Right. 2580 divided by 80. 32.25, though. Ah, too bad. Hmm. So that means you'll be able to check it and you'll go, that won't work. Because you can go, oh, yes, no, well, that 80 doesn't work because I can multiply that by the lowest common denominator, which is 2 here, and I can multiply that by the first number in the sequence, which is 6. 960. And it's like, all right, so if I divide that for the number of steps, which is 12. It is 80. Cool. So that's working, right? Right, yeah. It's like, wait a second. Is it just not big enough? Right? It's like, right, yeah, no, we're getting there. It's like 12, right? And you divide by 6. 160. We already know what that's going to be, right? Yeah. It's like, okay, so you're just teaching us some more. Yep. It's like, gotta figure out how you're doing this because you keep fucking with us. I want the answer immediately, you fucking dick. You're not giving us this fucking answer. You just gotta give us the stupid. Immediately do it. I already have. I was like, let's do that 120 again real fast. I was like, 120, right, by, oh my gosh, it's lowest common denominator. It was 60. Oh no, we can't do that. Oh, right, yeah. So if you do the first one, which is 5, which is 24, right? We can always hit on this number. It'll always be the right number. And we divide this, of course, by the lowest common denominator. Right. Then we have to divide by the order for the next number in the sequence, which is 4. And then you get the actual number, right? Right. So it's like 960, right? It's 960. It's like we can divide that by the lowest common denominator, right? But that's not what's gonna work. Okay. So it's like, all right. That's how I would probably fuck this up too. Hey, thank you. Yeah, now you get it. Divide by 6. Cool. I got 160. Cool. Right. Yeah. No. Right. Yes. No. But right. But then we have to divide by the lowest common denominator. Correct. I got 80. Then we have to divide by the next number in the sequence. Right. Which is 5. 16. Fuck. Is that the right number? I mean, it seems like it's the right number. How would I know? How would I know if it's the right number? Like, for real, how would I know? That's the real fucking test. How would you know? Are you gonna brute force it to go through? I mean, you hit on the right number. It seems to check out, right? It's like, all right, right. So we do this again. We do 6 times 5 times 4 times 3 times 2. Uh, hmm. Seems like it's 740. 6 times 5 times 4 times 2. 6 times 5 times 4 times 2. Huh. How did I get for a factorial, by the way? Did I just fuck this up bad? I might have. Which sucks, by the way, if I did. But we all make mistakes, remember. I would never make mistakes. Well, maybe that was the 7 one. Oh, right, like factorial 7. Right. Let's do that again. Oh, yeah, no, that's 5,000 now. Oh. 6 times 5 times 4 times 3 times 2. Man, I didn't do this wrong, did I? This entire time? Because he's clearly, he thinks he's better than he never makes mistakes. He's not in any way planning this out. That's just his fucking spinning. I hate you. Teacher, you suck. No. I don't. So it's like, it's obviously too far. We went to 960. I mean, I can't do that. All right, so 5, right, 2, So we're gonna do this again. 5 and 2. We're gonna do this again. All right. So, all right. So let me just fucking figure this out. Okay. It's like 5 and 2. So it can't be 10. So it has to be a different number. It can't be 20. So it'll check out, right? Like, is it 20? It's gonna be 20. Let me just do 720. Apparently. It's 6 times 5 times 4 times 3 times 2. Still checking out as 720. And we'll divide this by 6. It's 120. Fucking 120. What the fuck? What is that real? 120? 120, huh? Let me just look at that 720 real quick. I'm distracted all of a sudden. 720 times. What is the factorial of 6? Oh, so close. So close. All right, we'll move on. Anyway, 720 divided by 6. 120. Maybe something there. Maybe something there. Anyways, so 120. All right, so we got 120. All right. And divide that by, what is that? 12? So 1, 2, 3, 4, 5, 6, 7 plus 1, 2, 3, 4, 5. Yep, that's 12. So 120 divided by 12. It's 10. So what is 10? We may did just do this all wrong, and I got you all up in a tizzy because somebody sounds smart. But actually, they said the right thing, and they still got you there to be able to figure out something. So, anyways, so 5 and 2 is 10. Let me just 120, and there's 8. All right, this is 4. 4 and 2 is 8. And lowest common denominator is 8. It's 2 is 16. It's not over. Right, yes, no, right. Oh, right. So we're going back to this. So 120. It happened to work out that way. Yeah, but no. You have to remember that problem. You have to do the 12, sure. Yeah. But we also have to do the next number in the sequence, which is 5, which is 2. Right? So it's like, all right. So then we can go 5 and 2, and 10, right? And we'll eventually get there to 720. So let's do factorial 7, because then maybe people will understand why this is a little different than you might have expected. All right. So we'll do 5,040. Okay. So we got to divide it by the number of sequence. So it's 1, 2, 3, 4, 5, 6, 7, 8 total plus minus 2 of 6, right? And it's 8 plus 6 is 14. Oh, what? So there are multiple ways to come to the same answer. Oh, no way. So, all right. At, what is that? 14, we said? 14. All right, so 360. And then we divide it by the next number, and it's 6. Divided by the next number, which is the lowest common denominator, by 2. And the next number in the sequence has already been done, right? So it's like, all right, cool. We got 30. Nice. All right. None of that really seems to matter to some people because, of course, we're talking about math. So, wake up! Yeah. You might want to wake up a little. Hey, snappity snap. Hey, wake up. All right. I'm awake. Okay, there we go. We're finally getting somewhere. Can't lay down and do math, it seems like. So, we do All right, this thing where we go. All right, so it's 30. Right, right, yeah. Says that we got 14 here, of course. We got 14, right? We got 14, and we got 6. Okay, yeah, no, it's 6, right? And we got 3, right, right. Yeah, is that gonna matter? Is that gonna matter? I don't think so. Let me just check. 6, 14. There's no way. Did we do this wrong? Did we fucking, 5? And no way, actually 7 times 6 times 5 times 4 times 3 times 2. Right, right, right. So we gotta get this done, okay? All right, so it's like we got that. All right, we can divide it by the 7, which is 720. And we have to divide it then by the numbers. It was 14. It fucking sucks. That's a terrible number. So we're gonna get there later. There's always a sequence here. So it's almost like we have to do the lowest common denominator of 14 and 6, which would be, I think, maybe 2. Okay, so then there's 2. Do we want to do 2 first? Is that the one? Let's see. Is that the one we want to do? Are you sure it's that one? Or are we going to do the next number in the sequence, which is 6? Right, well, yeah. I mean, but oh no, let's go back to the 120. See how hard it got all of a sudden? Oh my god, the numbers, I've already forgotten all the sequence. I have nothing written down. I have no clue. And it's like, okay, right. Right? Yeah. Okay, so 120, right. So we know what that is, a factorial 5. We know that's factorial 5. We know that. Cool. Cool, cool, cool. And it's like, right, we have 10. Right, 10. Do we want to start with 10? What was the sequence we had to do? What was that? You said the sequence. I need to go back in the fucking video. Right. So it's like, all right, 5 times 4 times 3 times 2, which is going to be the end. So it's 120. Right. Right. It's like, all right. So it's like, right. But we know that we have to use the step. We know that we have to use, right, more than just the steps. We have to use the next number to be able to figure out the next number, to be able to figure out this number, to be able to know the step number and the relation to the lowest common denominator number. Right. Yeah, holy shit. How did I forget all that? You probably paused this while you were listening and then went and did other things and then totally forgot about everything I was talking about and all the sequences in every single kind of way versus just listening straight through. And even then, if you did, it's probably not super easy to remember all of it, right? And that's what math teaches you over a given period of time. You just wrote memorization and you're like, eh. It's like if you wanted to learn and actually do it like your own brain way, you don't get it taught to you by someone else. This is the step-by-step process that you're gonna end up at. So it's like, all right, you didn't write anything down, okay? It's like, all right. So it's like, all right, we got this number 5. Okay, cool. Okay, what does that mean? It means we have this other number 10. Okay, right. Yeah, it's 10. Right. So we have 10. Okay, then we have to do that lowest common denominator, right, of 2. Right. It was 20. Okay, cool. Right, and then it's at 4. Right, okay, there we go. Right, and then the lowest common denominator of 2, and then that next number order sequence, 4, right? Well, yeah, okay, right. So the next number order sequence of 4 with that lowest common denominator means that we can use that number that we figure out from those two numbers with 10 to multiply whatever that number is by. It's like, this is why we write things down, right? But we're not writing things down. We're listening. That's all we get. Just listening stuff. Okay, so then it's 10. Okay, below is this 10, there's 2. Is it 2? I mean, it's gonna be 20, yeah, if that's what you were wanting to do. Do you remember all the steps before this point? No, I don't. Can you know that? Oh, what? No way. You just were not listening. Huh? Shut up. Stop. Don't fucking bully me. Okay, sure. Bullying you. I'm the one that's been fucking talking for this long and acting that like I don't know already what it is. Like I'm already like aware of this. This sucks. I want this done. This act is the worst. See what I mean? It's like I'm not in any way. Good acting though, right? Like for real. Like right? Like you totally believe that in no way I don't know what I'm doing. Really good at acting, right? Anyways, so it's like that sequence. Remember that sequence? Remember the fucking sequence? Remember how to fucking figure all the things out? Because you gotta figure all the things. You gotta figure them all out. You gotta do it. So, knowing that it is 10, knowing that it is 2, knowing that it is 5, knowing that it is 4. Right? Those are that's all you need. Like I've been saying the entire fucking time. You know what I mean? Keep telling them, it's funny, but it's not after a point, you know? So anyways, you have 10, you have 2. You're gonna multiply it by 2? No, because you know what it is, right? You know it's 120. But what if you didn't know it was 120? What would you do to figure it out? Well, I don't want to tell you because I don't know, and honestly, I don't fucking know at all how to do this any fucking way. It's normal. All right, but that's how the process works to be able to figure out a sequencing, pattern recognition, programming kind of thing to figure out a factorial easily for all factorials. This is literally what the process is. Like, you want to figure it out? You want to do it? Like, hey, I'm doing it for you. But it's like, also, you're along for the ride, but also, I already figured it out. That's the thing. I'm helping you understand your normal, fight, continue fighting, keep going. So, what are you going to do? Right? What are you going to do? It's like, well, I know that the pin is what it is. Okay, cool. That's fine. You also know that it's going to need to be divisible by the first number, no matter what, and then that number as well, and the lowest common denominator. Right? Like you can always figure it out. Right? So like no matter what, it has to be divisible. This last number that you end up with has to be divisible by all 3 of these numbers. For instance, 720 is divisible by 6. Right? 720 is divisible by 12. Yep. And 720 is divisible by 2. Right. But we're going to get to even more steps to make sure that you definitely got it right. It's going to take a little bit. Because it's no easy roads out of this. You have to actually do the work. You can't just say something and so on. Since you always say that to me, I'm going to do this to you. I'm going to go through it all step by step since you will never apparently do the work at all. And you want me to do that work for you. That's the thing I have issues with you. That's the problem. It's like this is like I saw this person on Reddit like basically trying to act like me. And I'm like, there's a contextual situational difference there for information that can harm someone else, that's technically considered illegal or can get you kicked off the platform for providing that, which I'm not providing. So I won't get kicked off. But you didn't see that, right? Like all of that's effectively there in a way that makes it so like I'm not in any way doing anything that will get me kicked off of any of the platforms that I'm talking on. But no, you can just come up with this thing and you look it up and, you can just Google this. It's super easy. I'm like, you can Google anything to fucking find any kind of answer that you want that fits your definition of whatever it is. What did I tell you constantly in every single one of those damn videos that you're probably going to fucking go over? Here's how to look at it. Here's how to understand it. Here's how to work it out. Here's how to process the information. Here's the step-by-step process of how to do factorials easier. You're going to now know where it's like, yeah, that's an idiot right there that's saying that versus me. Okay? That kind of thing. It was like, right, you can't use the sequential, right? The number, right? But you kind of can. You have to. That number is always there, right? And you have 5, sure, but you also have 4, right? And it has to be divisible by all those, right? You have the lowest common denominator, and the next one in the sequence is something that you can use to effectively figure out a number that you can multiply by the step number. In no way, you idiot fucking retard student fuckface. It's always sequential. That's the only label it will ever have now. It is the sequential number multiplied by 2 with added by 2. Or, in another way to put it, add that, then subtract by 2. Because it's the true real number. The real actual sequential order number has a 1 and a 0 in it. And then you can just multiply by 2 and then subtract by 2. It all depends on how you decide to view it. Right? The pedantic semantic arguments, effectively. So, as a result of that, we're going to look at, all right, so we know this number, right? We know this number. It's 2 and a 4, and we know the fucking 10. Okay, cool. Whatever. Right? It's like not really that simple, is what it seems like, right? And it's like, yeah, no, that's only because you're learning right now. It gets massively easier and faster for larger numbers, and the more you do it. So it's like, the argument's invalid, shut the fuck up. So we're going to look at straightforward. All right, so 2 and 10 and 4, right? I say, well, yeah, 2 and 10 and 4. All right, so let's try the this other way. Because remember, you have to add. No way. You don't have to add. Stop interrupting, student. Shut the fuck up. To multiply. So we're already back into the act. Okay? To multiply. Okay? Okay? By the lowest common denominator. You have to do that. Jeez. Right, but it's like no, but whatever that number is, you have to multiply it by the step order, right? Say, no, idiot fuckface, that's sequential order, you fucking retard loser. Shut the fuck up. But I know what you meant. It's like, no, wouldn't you multiply it by the sequential number? Yeah, there we go. Now you're saying the right thing. There we go. Right. Yeah, maybe. Tell me, why? Why would you start there? Why would you start there? Why would you start there? Which place will you start? How do you want to sequentially do this in order to make sure, as I kept saying, you divide by this fucking number first? They just apparently forgot. It's just fucking gone from their mind. It's like, let me just divide this by. Are we doing the first number first? It's 20. All right. No. That's 5. Right, 5. 20 fucking 4. Right, yeah, no. But then we just divide that by 10. Oh, that doesn't seem to work very well. So what if we did, like, instead not that? Oh, really? Okay. And then we'll divide by that lowest common denominator, and then we'll divide by the next sequential, right? So it's like the step number is gone. That is correct. What's the step number? It's gone because it doesn't exist, you little fuck up. It's the sequential number, you little freaking dick. I hate this class clown. I'm gonna murder him. One day I'm gonna just cut his fucking brakes when he's in college and he's just gonna fucking crash someone. This fucking douchefuck. I'm gonna fucking have his wall sockets just like ungrounded, just fucking sparks everywhere. Anyways, not really. But all right, let's state we did do it with the first number. Yeah, but it's 12, right? Yeah, no, okay, sure. Whatever. But what about the next number in the sequence? 4. Right. Yes. Right. So, is that the fastest way? If you add the number 3 as something you could use, which you do not. Well, yes. No, I know. Right. So 120. So, process of elimination. We're getting there. Good. I love the effort. Right? So, 120 divided by the. Yeah, there we go. We'll go with the lowest common denominator. That's fine. So, we got 60. Sweet. All right. So, then we do, what is it, 10? Yeah, sure, why not? So, 10 is the number of steps. 6. Fuck. I probably can't use that number. Yeah. All right. So 120 divide by, all right, 5. Let's go with 5. No, we already did the 5 number. No. Okay, fine. We're not going to do that number. Do the lowest common denominator. All right. Then we got to do the next order sequence by 4. Okay. All right. 4. All right. We got 50. That's a very hard number to get to with all of these fucking numbers. Are you kidding me? It's a good effort, though, but it's a little difficult to do. All right, so 120 divided by, and is it 5 still? Is it still 5? That seems to be the best number. That seems to be the last sequence. Yes. In the whole equation here that we got to do. All right, for how the programming order of operations is going to work. All right, we got to fucking do 5 at the end. Okay, so 5 is at the end. The first number is at the end. We're gonna write this down. Okay, we're gonna write this down. All right, let's get out my notes. So, first number in sequence is the last number we multiply by. All right. All right, we got that down. All right. So, now we're going to divide by what? Which one? What number? It's a good damn question. All right, so we're gonna go with 4. We're just gonna try 4. We're just gonna fucking eat it out there. That's 6. That's a hard number to fucking come across. Yeah, right. Yeah, right. So that's probably not the right one to do. So we'll go with 24. All right. So okay, 24. All right. So that's 24, man. Right. So we got what is this? The lowest common denominator. So the first, and then we have the lowest common denominator. All right, so we got 12. Lowest common denominator every time. All right, so we're going to write that down. So 12, that's a number I can get to. Second, so let's see, first, like second to last number, we multiply by is the lowest common denominator. It doesn't matter how you spell it, just whatever. All right. The lowest common denominator. All right. So Then we have the sequence, right? So that's what I said, right? 4, right? That's 3. I mean, that's kind of hard to get. No. I mean, we can get that. No. I've been saying that we could do this for a long time now. Don't you dare, you dick. You fucker. You. I'm pretty sure we can do that. I'm sure we can find that damn number. I'm almost positive we can find that number. All right, we're gonna figure this out though. All right. So it's like we're not gonna use the next one in the sequence, okay? All right. So we're getting somewhere. Anyways, all right. But we can get 12, right? Yeah. Oh, for sure. You know what? Let's just you know what? So far, we've already gotten two for sure solid rules in this, thing that we're gonna do. Okay. All right. So it's like, all right. So we start with 5 factorial. Okay. Fine. All right. So 4. Right. How the fuck do they find 12 again? Well, the lowest common denominator, and it has to be from a 4 in the. So we're gonna try. We can't do because the rules state that we can't do 4 or 2. It can't be those two numbers, no matter what, and it can't work out to being those two numbers. Right. Right. Yes. So it can't be 8 because it'll go back down to 4 and 2. Right. Right. Yes. So then we can try 12. Right. So we try 12 and we can multiply it now by the lowest common denominator of those things. Right. And then we can multiply it by the next order sequence. First number in the sequence is not going to work though. Right? Yeah, well, there's a lows and then 12. Right. Yes. That was the second to last. Right, and then we multiply it by the first number, and that 120. All right, so we're there. All right. So we're gonna do 720. Okay. Right. All right. So we're already 6. All right. So 120. All right. Lowest common denominator. Right. So that's 2, I believe. Right. I believe it's 2 too. Pretty fucking sure. Right. All right. And then all right. So we got 60. It's like, can we figure that one out? It's like, maybe not. Maybe not. So we're gonna divide this now by the next order sequence. Do we need to? I mean, we didn't figure out that number. We didn't write that. So we'll just 5. That's 12. All right. So is that something that we could figure out? Not easily. In fact, that sucks. That's terrible. I don't like that. That's fair. Honestly, I gotta be real straight with you. That would suck. But 12 and 5. I'm sorry. I mean, wait. Was that 12? Right. Yes, no, but the numbers there for the sequential. Right, it is 12, isn't it? It's 10, it's 12. And it doesn't quite work. No. No, it doesn't. So, you gotta get that out of your mind. Just because it's related doesn't mean that you can use it. Right. So we have 720, and we divide by the first number, 6, divide by the lowest common denominator, 2, is 60, of course, we've got it, right? We can get there. That's true, because it would be from the lowest common denominator in the next in the order of sequence. It can never go back down to 5 and 2. So 10, 5 and 2. 20 will eventually go back down to 5 and 2, right? Mm. So we're gonna try 20, okay? So just let's go for it, okay? So what is this? So it's a second to last number we multiply because I'm making you fucking learn. You're gonna try, and then you're gonna fucking understand whether or not it works, and you're gonna figure this out. Let's imagine a teacher comes over. I'm fucking telling you exactly why. All right. Second to last number we multiply is the lowest common denominator. Okay, so it's like 60. We figured out 60 somehow. We figured out 20. Oh right, yeah, no 20. By 2. All right, right. And then then it was the first number in the sequence. Right, by 6. That's 240. Okay, so then this is how we remember the rules that we established. You have to divide it now by the sequential number, which is 12. That is 20. Okay, all right. So that's working, all right? So what was that, 240? Right, and then we have to divide it by 6. Right, that's 40. It is easily divisible. All right, right. And then we have to divide 240 by all those. It's all working out. Okay. Right, and so it's right. Nope. You didn't do the whole fucking thing. But it's like, we're going to learn why. I told you you're going to learn later, right? I told you you're going to learn later why this is ultimately not going to work. So 5 and 2. All right, we got the 5, we got the 2 is a 20. Doesn't work out. I mean, you divide by fucking 2 to 5. Fucking what? Exactly, the 20, right? So as I divide by 5, that's 4. It does not appear to be the right number, right? You know, that's the same number, right? No, but it's divisible by 2. Well, that is factually correct. Thank you. Right, and divide by 20 by 2 is, and that is divisible by 5. I'm just putting it out there. But wouldn't 60 also be 6? Let me just divide by 5. It was 12. Fuck. By 2, but not also by 5. Well, yeah. Well, let me just 20 divided by 5. 4. So, okay. And it's still divisible by 2. Right. And let's see here. 20 divided by 2 is 10. Right. It's still 5 and 2. So it's still there. Right. 60 divided by 5 is 12. And it's still 2. Right. Cool. Right. And then 60 divided by 2 is 30. Right. It's still there. Right. Well, yeah. So then, how is it that we figure this out? Hey, there we go. How do we figure this out? That's the right question. I like questions like that. Like, well, 60, and then we multiply by, what was it again? 2. And we multiply by the last number, right? Yep. Well, I did get that right. Yes. But you wouldn't know. So 20 works out, but they can't be worked out. So what does it work down to? Lowest common denominator, right? Has to be a thing that's by both of those. That's fine. We found one that's called 20, right? It's like, well, yeah, right. What's that third number? The order? No. The sequential number. Correct. Let me just go back through this real fast with a 120 or factorial 5. It's like, right. Oh, I got this number here. Let's stick to the 725. We'll do that. All right. So it's like 720, 120, right? And saying, all right. And then it's 60, right? Right. Right. They have 12 of these going on, okay? Right. Well, yeah. Right. Of this either multiplied by 2 and then subtracted or added. Yep. Add 2. Okay, yeah, no. Well, I mean, okay, well, right, yes. Let's go back to that factorial 5. Okay, let's go back to the factorial 5. Let's do it. Let's do it together. So 120 divided by the same number, which is 5, 24, divided by that by the lowest common denominator, okay? Then we're gonna go all like, okay, right, but It's not divisible by the third number. No, didn't say it was. But there's a lowest common denominator there. Yes. Okay. I'm listening. For the 2. Oh, okay. So we're gonna divide by the 2? Lowest common denominator again? No, for 6? No, 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 no. I mean, it works out that that lowest common denominator is part of that. For 10. Right, yes, for 10. Well, yeah. Well, yeah. Yeah, okay, wait. What's wrong? So, there's a way to check this number, no matter what, with the third number for the sequential number, right? Sequential order number, right? So it's like if we go 720, divide by 6, divide by 2, right? 60, right? Right. It's like that's 5 and 2. That's good because we know that the next order in the sequence is 5, and we know that the lowest common denominator is 2. Then we also have to understand that that fucking number is 12, right? And that's divisible by one of these numbers. 5, yes. If we go back to the factorial 5 of 120, we have 10, right? Yes, and 4, right? Well, so we'll just divide it by, what was it we were doing before? Look up the rules. First number in sequence, right? So divide by 5, right? And we divide by lowest common denominator, 12. Okay, right. So next order, 4. Okay, 4. Right, and we have 10, right? 4 and 2 and 10. I just fucking don't understand this. It's okay. We'll get there. So 4, 2, and 10 is 12. Okay? Simple stuff. That means this needs to be divisible by that, right? By one of the lowest common denominators are numbers of the 4 and or 2. Can you make 10 go into 12? No. That is correct. Well, technically no, because you can, but it's just 1.2. This isn't really the number you're looking for. So there's that. Right. No, I get that. But okay, so then where are we going with that? Well, the number 10, of course. Right, yeah, no, that's the 2. Right, yeah. Okay, right. Okay, okay. Right. So let's just say that that number that we've gone to is divisible by the sequential order number. Okay. Right. So we go 20. And it's divisible by the same lower common denominator as the sequential order, which is 12. Mm-hmm. Okay. Right. But we're not going to be able to do anything with that. Not really, right? Because it's like 5 and 2, and like, what does it matter? Because we still got 12. Right. Well, wait a second. But there's a rule here, isn't there? No, I don't know. Okay. Well, that's fine. If you don't, you don't. It's okay. Right. So it's like we already know that the next order sequence, so since this is 6, this is 5. So 5, not to mention we have 12, and then we have, what was it again? The fucking 2 is the lowest common. Right. So 12 and 2 and 5, which is great, but it's like 20 does ultimately do this thing, but it does work out to not being 5 and 2. So we already got those two numbers good to go, which is one of the reasons why like you only have those rules for really small factorials. smaller factorials are real quick to just like, yeah, well, it's already going to be there. Exactly. So, but the sequential number, right? Yeah, has to ultimately divide from this number into this final number. We know that. We know all these things, right? We also know that this number has to be divisible by those given types of numbers, right? For the lowest common denominator. Right. But we never really established what that lowest common denominator, whether or not that's actually reasonable to go with, right? Well, I'm going back to 120 for the factorial 5. And then going to do the first number, right? And then I'm going to do the lowest common. Right? I have 12. Okay, cool. It's a really hard number to fucking figure out at first, right? Because it's like, well, we have 10, so what does that sequential order mean? Like, you might as well not even use it for anything other than the lowest common denominator. It's like, right, yeah. Well, I mean, that's still pretty useful, but, anyways. It's like, all right, well, I have 10. It's like, right, yeah. Okay, cool. So, knowing that we have that number, knowing that that's a thing, what can we do with it? You still have steps, yeah. But yeah, steps, right? We all still have steps. Everybody is doing this together. Everybody's got steps. So if we were to think about it in the number of steps that we've just taken, fuck it, why not, right? What is it? Well, I mean, we did so that'd be the last. So, well, thank you. We don't have the ability to know what the end result is, and we're trying to figure out why the hell it is that that end result is correct. Thank you. Right? They have 10, right? Yeah, no, 10. 10's nice, right? 10's great. 10's always super great. Is it? Is it relevant? It's pretty fucking relevant, but okay. You can tell why, like, a lot of people don't really want to do this. It's like, I don't really want to learn, and this is hard and makes me feel stupid. Yes, well, that's normal for a lot of us that actually have to put in the work to fucking do this. And we feel stupid for a long time until we figure something out. It's like, oh my god. It's the best. So, we're going to think about this just a little bit more. So, like, let's get around to 10. All right, so remember that lowest common denominator thing? Well, yeah, no, but of two numbers, of the next in the sequence. Yeah. Right, and then we know that it has to be with this number. Remember, where did that step go? Right? I'm just wondering, right? You know, right? Like, because how would I get to 12? Well, I mean, I figured we were just, let's write that down. Find the lowest common number you can divide by the next number in a factorial sequence and the lowest common denominator of the sequential number divided. That's a sequential order of operations, number multiplied by 2, then added to, or multiplied by 2 and subtracted by 2, depending on whether whether or not you include 1 and 0. So find the lowest common numbers. You can divide it auto-corrected by default to decide, apparently. Operations to find that number first. Right. So that allows for you to figure out a number. Right. That's great. 12 is, 8, but right? You do 8. Right. But they'll go immediately back down to 4 and 2. So small number, really easy for factorials, right? You immediately get up to 12 and you got the right number, right? So it's like, cool. Except that's not going to work immediately for the next one in the sequence for factorial, which is the whole point of why I kept fucking poking, just prodding constantly. It's like, do you understand what you're doing here? So it's 720, right? Right. So it's like, now we're going to use the backwards. So it's like, we can divide by the same number, right? We can divide by the lowest common, and then we have to find this lowest common that we can find, right? But it's like, right. Except, like, that's not really super easy, is it? Oh, really? Okay, let me just do 12. It's 2 apparently still, right? And it's working. 2 is working, right? Well, yeah, I wants to lick the shit out of me. So I'm on the 4. Right. Not eating it all. Fucking starving. You guys suck. This act has been going on for way too fucking long. The things I do, people will probably never even see them. They'll never even listen. Oh, God. They'll never understand that this is a genuine thing I'm doing. They'll probably never even notice. Any fucking way. Bothers me. Just a little bit. All right, so I've got this number, okay, that we have to hit, which is 60 apparently. Right? And it's like, okay, yeah, sure, 60, okay, whatever. But it's like, right, no. But like, okay, so we're just gonna move on from checking, right? We have to figure out how to get them to fucking find out why that number, that is 20, sucks ass and you shouldn't use it. So there's that, So it's like, all right, we're gonna start with 20. And it's like, why does 20 not work? It's like, right, and that's the very next sequence. That's the whole point of this. Right? We have to figure out the next point. Where it's like, okay, so the sequence in order operations here won't work for this factorial once it gets up to this point because 20 is not going to work. So how do you figure that out? Well, that's just because you know. Exactly. And eventually you figure out that there's a sequence and a pattern here that will work for every factorial no matter what. Okay? So it's like, right. Well, 20 doesn't work because, well, how would you know? How would you check? Well, you have the sequence, you have the lowest coming in, you got all this other stuff, though, too. So, just repeating the words back that I've already fucking said that as I was recording, and then you probably just said that to your screen, which is neat and everything. I hope you, make sure to properly write down in the comments that you did that. But if you didn't write that down, you're just going to be a mean person to me. So, we already have the idea of what we need to do. It was like 20, and then like 2, right? And this was coming, and then 6. It's 240. It seems to check out, right? Except for 12. It's divisible by. Yeah, it's quite divisible. Just like the last one. Right. Right. So, I mean, it was though. I mean, okay. So then, what the fuck is this? Gotta have a sequence of numbers. You gotta have an order of operation. You gotta understand there's rules to how it is that you have to do this. That's how this has to work. This always how it has to work. Okay. So, how would you use the 10 for the 120? How would you do that? How would you figure this out? I mean, you have the steps, you have this, you have that. How is it that you would do it? Could you go eat some food? Your dog's also like just fucking probably wanting to go out. Oh yeah, no, you in my life, huh? Yeah, no, you run it all this. I'm putting in this effort for you. You better fucking try. You fucking piece of shit. Trying to get out of the fucking math class, you little fucker. You little fucking dirk. Is a dick and jerk at the same time. You're dirk. Anyways, I was like, all right. So knowing for sure, no matter what, that you can piece together other numbers, by the way, from the sequential number, the order of step number, the first number in this, all of that. Remember, we literally just went through this. Like, I'm just letting everybody know that I'm actually angry a little bit about it because it's like we literally just did that, right? And it's like, all right, so I was like, well, 720 divided by is 12, right? 60. What? All right, cool. So there's like 720 divided by 2 is 360. Okay, all right, all right. So like that seems to be the same thing of this other number, possibly, right? Is that well? It's 360. You know, I mean, 720 divided by 2. Just get in here. Just divide by 2. That's 360 still. Calculator's keeping it real, just giving it to me straight. There's no way to fucking think about this otherwise, other than it's 360 for sure. All right, all right. So we happen to have another number. This is in the sequence, which is 5. Okay, so it's like we're gonna go like 5 is 72. And that is definitely a number divisible by 12, which is 6, which is the first number in the order sequence. Right? So like what the fuck did we just do? All right. So what if we change the order of operations from 120 divided by 2? That's 60. I mean, we just no, this is factorial 5. Right? So like we're gonna fucking keep up real fast. So it's like we're gonna change this first number in a sequence. And then so let's see here. We're gonna do instead divide by the lowest common denominator found by sequential number multiplied by 2 and or added slash subtracted and let's get rid of that word and added subtracted by 2 depending on your perspective of this dog just barking over there. Not my dogs. It's right through the fucking door. Anyways, let's see, respective of semantical, pedantic arguments made for factorializing. All right, so divide by the just immediately. This is the lowest common denominator. So it's like we got 60 here. Okay, we got 60, which is divisible by the next sequence number. Right. So it's like that is 5. Right. All right. No. No. I meant no. Okay, and that is divisible by 4. right? But that would be 15. Remember how we said that that was not the number we wanted to do? Right. Well, yeah. So we're not gonna do the next order. Instead, we're gonna do by the first number. Yes, there we go. Right, the first number. So we're now instead do now by the first number. First number. And we're gonna divide this number by the first number. The first number in the order of sequence for the factorial. We're getting there. It takes time. So now 12. We got 12. We have 10. What does that 10 mean? You're going too far. Doesn't matter what that fucking number is right now. It literally doesn't matter. We're gonna get there though. All right. So we have 12. We know 12. We understand 12. We can do the 12 all damn day. Okay. But we have this next number in the sequence, which is 4. Right. So we divide by 4, which we get 3. Man, that 3 just keeps showing up. Where the fuck does that? Where that fucker just shows up every fucking time? It's almost like we need to figure out those kinds of numbers. Man, yeah, it's fair. It's almost like I could use 3 times that number of the order of sequence number, and then I can like multiply it by the lowest common denominator, and then multiply it by the fucking final number. Oh, I'm sorry, the lowest common denominator again. It's almost like I can just double the lowest common denominator. It's not how math works. Might work for this one, but then it needs to work for every single one. So it's not how that works. So, all right, so 120. All right, so we can't do that. So it was like we're gonna do 5, and it was like no. So we had another 5. There's 2. We multiply 2 again, right? Because that's what we just did. Well, no. We didn't do that. Remember that? But wait, what? Right. So we did 120, and then we divided it by 2, and then we divided that by 5, and then we divided that by 2. Right. Yeah, we divided by 2, 12 by actually no, like, oh, right, there we go. Right. So by the next number in the sequence. Right, which is 4. Right. So now we have 5 factorial. Okay, so I have 5 factorial. Right. I have this number. Right. This is 2. That is correct. Right. But what did that matter? So we'll do 4. So then what are we going to multiply 4 by? What? What are we going to multiply it by? You stop pointing out where our flaws are here, you fucking dicky fuck. How is it that we get to 3 again? I don't know, motherfucker. Shut up, bitch. Oh, okay. What's the number we multiply by the next order sequence number? Yeah, how do we figure that one out? There we go. Golly. Someone fucking finally said the damn words. Alright. Find number. So we're gonna write it down in the notes. Find number. We multiply by the next number in the order of sequence for the factorial. All right. So I was like, we got the factorial. We know it's 5. It's like, how do we find that number? God damn. I hate these motherfuckers. I'm just saying, it's a bit rough. But that's fair. Like I've just been explaining it for a while now, it feels like. There's a lowest common denominator number here. Seems like it. Remember that it happens to work out that way, that number is 12,
right? Remember that number 12? Yeah. All right, so like, all right, we got 4, we got 10, we got 5, we got 2, we got all these numbers. Well, yeah, well, okay, but we got 4 and 2. This is the lowest common. Well, yeah. Well, well, yeah. I mean, okay. So then, what were we saying about that number? It has to be fucking divided by and multiplied by. Mm-hmm. 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 Yeah, that would be 12, though. Right. 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 How would we get to the number 12? Would we figure out that it's 12? Understand how angry with you sometimes. How do we find out that it's 12? We have to find that out. Because it has to be multiplied by the next number in the order sequence. Yes. Yes, it does. Thank you. But how do we know that is the right number? So we're gonna do this real quick and simple and dirty. We're gonna do 6 times 5 times 4 times 3 times 2, 720. Okay, so 720. And we're gonna divide this because we're going with this one. We're gonna divide by the first number in the order sequence for factorial. I thought we were not doing it. All right, by the lowest common denominator. Right, yes. So 2. We got 2. All right, all right. So then we divide by that first number, which is not 5. That's going to be 6. So that's 60. Okay. Now, then we are all like, all right, so now we have to figure out what the fuck it is we're going to multiply this for the next order number of sequence. So that way we can figure out how to do all this. Right, yes, 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 because it says right here, find number we multiply by the next number in the order sequence for the factorial. Right. So how do we figure this one out? Right? And it's like, right, there's got to be this, there's 12 here, and there was a 10 there, there was an 8 there, right? Oh, yeah, no, there was a 12 and a 10 and an 8. I remember that. I'm fucking remembering that for sure. Right. So it's like, right, right, right. So, well, if we did divide that by that number, because we already know what that number is, that's true. That'd be 12. Well, yeah, no, I mean, it's working out that, right, I get that, but like, that's not what we're going to use, right? Absolutely. Although you could memorize that, and you could use that to fucking immediately fucking know what the factorial is. Correct, but we're not going to do that because we need it to be able to be used on every single thing that is a factorial to be worked out very quickly, no matter what. That's what we're doing. Okay, so it's like, all right, so we got 12. We got 12, 12, and shut up with the 12, you fucking dick. Yeah, shut up. How do we figure out that that 12 is a 12 that we're going to use? Do you understand that? You are a poor student. I don't like you. The student over there. Although, like, for what it's worth, you're also kind of freaking out because, like, we're so close. It's so diabolically, deliciously close. It's like, we're this fucking close. How do we do it? How do we figure out that it's a 12? Well, we know that it's not, though, because we have to remember the 60. We have to divide by 5. Right? But that's 12, right? Okay, well, that's fair, though. Yeah, how do I fucking, there's 2, and then there's 5, and then we have 12. And then it was like, we have this 5, or I'm sorry, we have this 2, this 4, and then it was a 10. I have a common fucking thread here, like being just even. It's not always going to be that way, so, like, stop. Remember, like, trying to figure out because it's prime versus that 3, that. Well, maybe we can use that. Okay, let's see if we can use that. All right, so it's like, all right, we got this 5, we got this 2, we got this 12, right? Yeah, yeah, yeah. I'm gonna figure this. I'm gonna fucking do it. Okay, we're gonna figure this out. All right, so it's like fucking. It can't be 10. It can't be 10. No, 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 it can't be 10. But it does. Equal number, no matter what. That both of these numbers, right, are all divisible by this lowest common denominator, and that if it was that number, then the next in the sequence, and it was multiplying by the sequential number, but we're not doing that. We don't know that, so that's the problem. Oh, right, yes. Right, yeah, see the problem with the programming thing? It's like, it would be wonderful if we could know that, but the answer is we don't know that, so, like, we can't do that. Right, yes. So that one turns it into, what do we figure out? Yeah, exactly, right? So it's like, all right, let's go back to the factorial 5, because these are much smaller numbers, right? So that's 120, and that gives me, divide by 5, that's, no, lowest common denominator, right? 60, and that gives me, divide by the actual first, and that's 12, is what we're trying to figure out, except it's the next order in sequence. 12 is easy because we can understand that it's like we need to get 4 and 2 and 3 and all that, right? Right, but we also have a sequential number for a reason. So like, let's say we just wanted to go for the 5, 4, 3, and 2. That was 4, right? Well, yeah. Okay. Okay. Right. I say it was that. If it's 10, yes, it is. Well, it's 6 and 4, really. It is 6 and 4. Yes. 6 and 4. Does that work out that way? Let's see if that works out that way. So 60. All right, so 720 divided by, because we're going to do it long ways. Okay, we're good. We're good. All right, and then we do this one, and that's the 6, and then we're going to do it by the next, and that's 5. Right? We're going to do it long ways. Okay. All right. So that's then going to be 5 and 7, 5 and 7, 5 and 7, 5 and 7. So that doesn't work, seems like. No, it doesn't. Be nice though. If only. Yeah. 5 and 7. 12. Hmm. 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 But 5 and 2, the lowest common sequential, and then we have to get the. So let's do this a different way, because like the numbers are working out that way. So 5 times 6. I mean, 7 times 6 times 5 times 4 times 3 times 2. So there's that. So then we'll divide by the lowest common denominator, which since this is 14, right? Then you have to divide it by the lowest common denominator. Wait, what? Yeah. That's the actual how we figure out the lowest common denominator. So it's like 14, right? So that would be 7 times 2. 7 times 2. It's almost like it's the same thing. 6 times 2. 5 times 2. 4 times 2. Oh. Hmm. Hmm. There's a pedantic semantic memory. This is the controller. Yes. Hmm. Because it is actually 1, 2, 3, 4, 5, 6, right? Yep. And then we have to 1, 2, 3, 4, 5, 6, 7, 8. Right. 6 and 8. Then we have to add. We have to add the 2, right? So you're already adding the 2, or you're already subtracting the 2. See what I mean? You know. See the fact that there's one, and then you just add the 2. So you do the same thing, right? 1, 2, 3, 4, 5, 6, right? And you do it again, right? So 6, right? So 7, 6, 5, 4, 3, 2, 1, 2, 3, 4, 5, 6, right? That's 12. Then you add the 2. All right, yes, you're just adding the, okay, so it is because it's technically is multiplied by 2, and then you added the 2 because of the right. But it's just multiplying by the same fucking number. Oh no, I would never have, anyways. It's a good way to do that. Yeah, eventually they'll pick it up and they'll learn like that's like a sudden like, oh wow, yeah, that is the case. And it's like, thank you. Thank goodness it doesn't matter your pedantic semantical garbage argument. It's just the same thing multiplied by 2. It doesn't matter in any way. It's just a perspective thing, as I'm trying to teach you about perspective problems. Anyways, so this is that number, right? 5,040, which is that number, I guess. It is that number. I'm pointing at that number in my mind with my eyes looking directly at the number. Anyways, so it's like, all right, we got this number, we got 14. Right, 14. Right. That was a real long, subtle, just fucking your perspective means fucking jack shit. It's the same thing. Doesn't matter at all. How you argue your semantics, it's still what it is. Exactly. Thank you. God fucking damn it, someone saw it. Eventually, God, took forever for people to figure out. It's like, it doesn't matter how much you're arguing. The literal thing is still the thing. It just doesn't matter. Doesn't matter. Well, it's actually subtracting. It's actually adding. Is it cringe? It's just fucking multiply it by 2. But that was a real subtle one for a really long time. Okay. Anyways, all right. So 5,040. All right. So we have so the lowest common denominator, which is the 14, which would be the 7, which is of course the 2. Thank you. It's almost like it always works out to being whatever that number is multiplied by 2. It's almost like that subtlety just never really clicks. It's always 2. No matter what, 2. It's just always 2. The answer is always just divide that fucking number by 2. Jesus fuck. Anyways, 2520. So, all right. So we got 2520. Super, super cool. Awesome. Now we're going to just divide that by 7. That's 360. What the fuck? Wow. It's almost like there's a pattern emerging here every time with all these factorials. So there's 360. All right, so now we got the 3, so that's the first, and then the next in the sequence, of course, is 60. Fucking what the fuck? It's almost like there's a pattern. So then we divide that by fucking, let's see here, by some fucking number. I'm guessing it's 5. It's 12, and then we get to like fucking 4, and then it's 3. It's almost like there's a pattern because it's a factorial. And it took us this fucking long to get there, huh? It's like it's always seemingly 3. It's always seemingly 3. It's always seemingly 3. It's always seemingly 3. Always seemingly 3. Always, no matter what. Okay, so like it's always seemingly 3. You knew that. No, we're learning together. I was not acting. It's always seemingly 3. Okay, so it's like, all right. We'll do the factorial of 6. It's like, oh, let's do factorial 5. Let's do factorial 5. 5. All right, so factorial 5. All right, so factorial of 5. It's always seemingly a pattern here. So that's 120, right? And then that will always be like 12, and that'll always get to 3. It always seems to break down no matter fucking what to fucking 12 and 3. I don't know what you're talking about. I've never heard of these things. Anyways, so it's 120, right? 120, good old factorial 120, right? Good old, we'll divide it by the fucking lowest common, which is 60, and we'll divide it by the lowest, the next number, and that's 4, right? No, 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 no. The first number, right, right, right. And then we have to divide by the fucking next number in the sequence, and that's immediately 3. It was 12. So it's like no matter what, it's like 3. It seems like. So it's like, all right. So we'll fucking look at factorial 5. I did 3. And we'll just multiply that 3 by what was it again? The next number in the sequence. Oh, it's 4. Okay, so then we'll just do the next number. Fucking what was that? The fucking the lowest common, right? And then we'll just multiply it by the first number, right? And then that's 120. All right, so it's like, all right, we're gonna do this again. All right. So we'll just like take factorial 6 here. And start with 3 because it's always gonna be 3. Seemingly always breaks down to 3. I don't know why. I've never heard of such a thing. So it's like, all right, so 3. Right, right, right. So it's 3. Okay, so then what we're doing, we have to do find the lowest common, which is 2. New? I already got it wrong. Right, 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 right. Right. But like, so what was that fucking sequence again? Oh no, it's okay. It's in the calculator's history right here. Okay. So we're gonna look at that 120 divide by the lowest common, then the first number, then we gotta do by the fucking what is it? The next number in the sequence is what that was, right? We're not done yet. I love fucking you up so much. You have no idea, bitch. Because all we did was multiply it just everywhere. No, no, but wait, like, no, it seems like we were hitting on something right here, right? You know what I mean? And we're getting there. Okay, so 120 divided by 2, that's 60, and then we divide it by the first number in the sequence was 5, right? And then we divide it by, why is that 4 there again? 120 divide by lowest common, right? Then the first number, right? Right. Yeah. Okay. Okay. All right. So that means that's 2 steps so far in the steps of the sequential, right? Yeah. Okay. So then that's 4. It's like we're not gonna use that because that's not the right answer. So okay. But I know someone was thinking about it. I know. So by 2, right? That's lowest common. Right. We always just divide by 2. That's the first number. Right. Yep. Mhm. 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 And then the next number in the sequential order. It was 4. That's right. Oh, because we're doing factorials. Yes. They've forgotten about the factorial part, I feel. I really felt like they just completely whoomp right over their fucking head, man. All right, so we're gonna start with 3. Right. 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 And then the next number in the factorial was 4, right? And then we'll multiply it by that number, and then that's 60, and then we by the final like lowest common, right? Okay, there we go. So we're gonna start with 3 no matter what. It's factorial 6, right? And then we'll multiply it because we start with 3 no matter what. We multiply by 5. Because it's yep. All right, we're doing that. All right, and then we're multiplying it by 6. Right, right. Okay, and then we can multiply it by the lowest common, which is not the case. See, where did we go wrong? Ah, thank you. Right, so like 6 times 5 times 4. No, I know you gotta go, but no, I gotta do this. We're so close to being done. Ow, your fucking puppy paw scraping me. All right, so then we gotta buy lowest common denominator. All right, then the 720 lowest common denominator, that's 360, right? That's the first number, right? That's 60. Well, yeah. Then we gotta do the next number in the sequence, right? Well, yeah, yeah. Okay, right. Right. Thank you. Finally, somebody fucking gets it. Like, well, I still didn't really fucking just 12. So, but, um, it is 12 every fucking time. It always seems to end in 3. You never notice that? I never really seem to notice that. You know. So it's like, all right. So start with 3. You multiply by 4. You multiply by 5. You multiply by 6. You multiply by 2. What do you know? That's the whole sequence that we currently have, and it's working every time, except we are literally just multiplying backwards right now, and then just multiplying it by 2. Well, yeah, well, up to not the what? That is correct. So we're gonna do this again. So we're gonna start with 3. We're gonna multiply by 4, multiply by 5, multiply by 6, and then multiply by 7, and then multiply by 2. And what do you know? I now have the end of the factorial. And it's like, that sucks, right? Well, I mean, we're getting the right answer. Yes, but we're really just doing it in reverse. So that's not really better. And all we do is, really technically speaking, just multiply by 2. But it works every time. Yeah, oh boy, but it does though, actually. Yeah, that's the thing. It does work every fucking time, let me tell you. Start with 3, multiply by 4, 5, 6, 7, and then 8, and then multiply by 2. And what do you know? I got the right answer every fucking time. It's like, that sounds like it's not actually any better. That's because it's not. That's why I said that's horrible, although it is faster, but it's not faster. Well, that's true. Yeah, but that's the sequential. But I keep telling them that the lowest common denominator and the sequential thing with the number, and then how all of it's always divided by the same fucking thing. The lowest common, the 2, is always there, right? Yeah, but yeah. Okay, wait. We're getting there though, slowly but surely. We have figured out something, and it is amazing, but at the same time, also kind of irrelevant because, I mean, it's effectively just start at 3 and then multiply up and then multiply by 2. It's really kind of, which is, by the way, shockingly at the end of a factorial. Where have I seen this before? You know what I mean? But, eh? You know what I mean? So we haven't really done anything better. We're getting there though. They're starting to understand it backwards now. That's the teaching part. Gonna first apparently get there. They were so close. They're like, I'm gonna dodge trying to figure out lowest common denominator reversals. I just don't want to fucking even remotely fucking remember. Anyways, so 720 is like, we're gonna start with the lowest common denominator, or 6, for the very first one. It is 120. So that is shockingly, it's almost like that's in the pattern here. So 720, 6, yeah, no, because you also want to go fucking bed, don't you? So 720 divided by 6, because that's the factorial, right? It's like, right, but that's also for the next number sequence over, right, for 4. Right, so you divide it by the factorial result by the first number, right? And then you skip over the next number, you get 4, right? Well, yeah. Okay. Right. Divide by 4. Is that going to work? Isn't that questionable? Isn't that questionable? Let me see here. Probably not, but maybe I can divide it by 2. Oh my god, is that 15? What the fuck did you just... Is that 15? So I start with 3 no matter what for every factorial, just always. And then because it's a opposite, meaning 6, 5, 4, 3, 2, and it's like, well, we went at 6 to 4, right? And then we would have done 2, but we don't need it. Oh wait, we did do 2. We did 6 to 5. Right. Right. Wait, what? Anyways, so we start with 3, we multiply it by 5. Cool. Right. But wait, what? Then we're going to multiply it by 2. We're going to multiply it, and it's like, wait, this is the same thing. Nothing's changed. Yes. So we're now learning random sequentials that still result in the same end result. That is it's seemingly random. It's not actually random. It's a patterned sequence. See what I mean? Pattern sequence. They always get weird about this. But it's like, all right, so we do 720 divided by 6. Are you just teaching us there's no real way to do this easier? Because I feel like that you're almost there. I fucking shit you not. Fuck. All right. So we're going to go back to, all right, so there's this number, and you just multiply by 2, right? Right. 6 times 12. Well, yeah, so 72. Is that a number that you had before? It might be. It might be. Okay. So we just do that then. So 720 divided by fucking 12. 60. Okay. Right. So 720 divided by 12 is still 60. So again, right. You know, let me just go look at that factorial 5 real fast. That's 4, 3, that's 120. Okay, cool. Right, and then it's like, right, so then this number, right? Yeah. What is this number going on about? We divide by the same number, right? 24, right? And it's like 10 is right. And then it's like 8, right. No, you're skipping ahead. It's like we got 24 here. We can divide this by the same number by 2, right? Because it's dividing by 2, no matter what, right? Right. So we can do 5, right? 5 times 2 times 5. So 5 times 2 times 5, which is not the case. Oh, okay. So you're getting the jump ahead doesn't allow you to get actually in any way. So remember that sequential? I remember there's a sequential somewhere here, right? I thought there was. Somebody said something about that. Right, it was 10. Yes, it was 10. Right, it was 10. There's a 5. There's a 120 divided by 5 is 24. Yeah. I remember that. It's 10. That's 10. Right. We could divide the 10. The second 10. So what does this 10 have to do with anything? I wanted to explain that going back, any of the numbers of the factorial, even 1 is literally like removing the whole fucking premise of making this faster. That's literally what this was about. It's like you go to 4 to 3 to 2, and it's like, so you've learned how to factorial. I see. I'm gonna fucking make this just eat you up that you really fucking did that. So I'm that guy. So, anyways, we do 5 times 2, right? It's just 10, right? It's the same sequential, right? Yeah. Right. Well, okay. What if we add it by the sequential? Well, I mean, okay, so 10 plus 10, right, that's 20. And we'll add the next number in the order, 24, right? And then we'll just multiply it. What was it again that we need to multiply that by? I don't know, some number like 5, I think. You just do it again, apparently. So it's almost like there's a sequential number that's the same number multiplied by 2, and then you just added it. Right, right, and then you got the right number. Right, so it's a 5 times 2, right, and then you just added the same number for the sequential, which means it's just fucking 4. Are you understanding factorials yet? Have you understood factorials? Have you understood factorials and made them easier in your head? What did we just do? 5 times 2. No, 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 no. No, we did 5 plus 5 plus 5 plus 5. 4 times so far, right? No, 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 we didn't because we did 5 times 2, right? Okay. All right, you teach me. All right, and then we added 10. Okay, okay, okay. And then we added the next number in the sequence. Oh, obviously. Right. Yeah, wait, but that's a sequential number, right? Yeah, it's 5 times 2 is actually it's really just 5 times 2 twice. Yeah. And then we added 4 because this is in the next order, for the factorial, right? Yeah, yeah. And then we multiplied it by the same number, the first number. The first number, yeah. Then we got 120. Well, does that work for the 720? That's the question. Let's try. It's like, all right. So multiply this by 2, and then multiply by 2 again. You're getting there. So we got 24. And then you just add this other number. No, no, that's 4. This would be 5. Right, right, right. And so that wouldn't work. Are you sure? Or is it multiply this? Oh, it's 170. That doesn't seem to be the right number. Shocker. 6 times 2 times 2. 5 times 2. But wait. That's a different thing. Right. Oh, so I tried to fuck with you. So it's 12. And then we're gonna add 12. And that's 24. That's still the right number. Yeah, right. And then we have 5. I mean, so 5. Try to fuck with you. Right. Right. So we have 25. No, 24. We got 24. Okay. Right. We have 24. Right. So now that we know that 24 is a number that we can use to do what we need to do, because that's kind of a thing that we kind of now have really realized dramatically that all factorial numbers will end up resulting in a number that is divisible by 3 no matter what. I got you there though. That's a nice water. It's good water actually. Yeah, isn't it? Yeah, it's pretty good water. Anyways, so now we know that no matter what, we now know that we can multiply that by what? By the next order in the sequence because of the exponentiation we have here. Right. And then we can multiply that by 3. No, 6. There we go. 720. The first number. So multiply by the. So wait. Yeah. So we're going to do that again for you. 6 times 2 times 2. Right. Then we're going to multiply it by the next order of operation number, meaning from 6 to 5. Then we're going to multiply that number, okay, which is 120, by 6 for the first order of operation number. Now do you understand why the power of 2 and 3 and all that became very important for you to understand why it is that whole order of operations and number for factorializing is extraordinarily important. You have to learn all of that as to why it is that this will work. All right. So 7 times 2 times 2. Right. It's like, oh, yeah, no, that's pretty good. Right. Right. Is it? Is it indeed? Or am I fucking with you again? All right. So then we multiply by the next number, and then we multiply by the original number. It's not working. Ah, shit. So I think we're going to have to work a little harder. Because we need a 5,040 here, right? So we can't do just 2 and 2. But wait, didn't we do like something with that like sequence number, right? Yeah. It's like 7 times like, what is that, 14? No. We can't do 14. You know that. It's like 6 times 6. 12, right? Well, that's 72. And then we were all like divide by like fucking the fucking something here, right? By 3. Yeah, okay. You know what? You guys all suck after a while. I know what you're doing. The teacher wants to input his information here. It worked with the 5. It worked with the 2. Like, I don't see what the problem. I don't see what the issue is. I do. 5 times 2 times 2 plus 4, right? 6 times 2 times 2. Then what did we do? What did we change? Right. We changed it to being times 5 because it's an exponential, right? Right. Well, yeah, it is an exponential. It's an exponential. There's an exponentiation here because we're talking about factorials. So 7 times 2 times 2 times 6, but that doesn't give you the right answer. Right. So what's the next one that we have to do? That's the exponential. Remember the pattern of the exponentiations? So they're always divisible by 3 is what I would go with. Yeah, I know, but people won't really fucking do it. It seems like, you know what I mean. So 5, so 7. So wait. So what about that sequential again? Yep. So 7 times 2 times 14, 96 times 2, 392 times 6 times 7. Oh, that's not gonna work. So let's get that. So 7 times 2 times 14. Okay, times 6 times 7. 8,000. It's not working. All right. So, where are we at? We have not gotten where we need to. No, we're not there yet. It is always a learning experience. That's how algorithms work. This is programming algorithmically, and this is figuring out a genuine formula that seems to work. This is how people do this. All right, so 7 times 6 is 50, 40, geez. All right, so 50, 40 divided by 7, right? 720. Immediately red flags. It's always seemingly divisible by 12. And then that can get me, fucking damn you, which can get me to 5, which then can get me to 3, right, which can get you to 3, right? There's always 3. 3. Remember the 3? Remember that 3? Well, yes, I do. 3 times 12. Is that what you want to go with? No, I don't. Okay, so then where do you want to go? No, we'll always start with 12. Well, we started with 3 because it worked well with 5 and 6, but now we're jumping up to 12. Why is that? Because factorial exponentiation. Right. Let's explain that one though real fast. 6 times 5 times 4 times 3 times 2. 720. Okay? Right. Okay. So then that divided by 6 is 120. Pretty quick, right? You kind of understand it. Then you can divide that, of course, because we always know it's always going to be something that's divisible by 2, 3, and 12. Seemingly. This is what we just figured out. So we divide that by 12. No, 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 no. We divide it by the lowest common denominator because it's easy to understand that. Okay? That gives you 60, right? Which means we already did 2. Okay? But we don't want to do 2 for every fucking thing. And we certainly don't want to fucking like have to deal with dividing by 6 because that's all we're doing. We're just moving the numbers that we're ultimately using to figure out a factorial. If you didn't realize, I'm going to have to tell you directly now, dividing by 6 is immediately just going down the line and just using the right order of sequence to get the right number. Okay? That's the pattern here. 6, 5, 4, 3. It doesn't matter as long as you do it the right way. You're still using the same numbers in the factorial to ultimately get to the same number. And you're trying to get it done faster. Okay? So it's like you need to understand that the sequence number and that 2 that's always there is always very important because it's the lowest common denominator of every fucking factorial that there will ever be. Well, maybe. Right? We're going to get there. Okay, so fucking jank, man. Like, what the fuck? Okay, so 6 is 12, 5 is 10. Seeing a pattern here every single time. Cool. All right. Right. Well, so then fucking 720 divided by the lowest common denominator. We're going to do the same pattern again. So, like, how do you do this faster when it comes down to there being a 10, right? So it's immediately 72, right? 50, 40 divided by, so that's 14, 360. Wait, what? 8 times, 7 times, 6 times, 5 times, 4 times, 3 times 2 is 40. And then you divide that by 16. You notice a pattern. Not yet. Okay, that's normal. It's normal. It's normal. They're not going to notice that pattern right away, guys and gals. Anyone out there? If some of you have, great, but don't spill it because this is awesome in terms of like figuring out cool patterns in numbers. This is how a lot of people that really love math understand why they really love math. They figured out like this little pattern. Like that's the flap flap and the nonsense of the you drinking all the great water, right? So 25, 20, right? Well, yeah, right. But I mean, by 16, right? This is a doubling of that same number, right? You divide by the same number. So lowest common denominator, right? That's 1260. Okay, cool. Right. Again, you're just moving the number around. Right. Let me divide over by 3. 12 or 5, seemingly. So factorial for 7, even if it is 7, right? So and I just need to get to, so let me see here. If I already know that 7 is going to end up like that, then I can always just do the same pattern, it seems like. So 7 is not what we start with. Actually, we'll start with 12, multiply it by 5, and we'll multiply it by 3. No, 3. All right, so I have to do this again. 50, 40. Right, so 720 divided by 3. next in the sequence. Next in the sequence. So 2, the lowest common denominator. Right? So 360. Right? Now 360 is an easily understood thing, as it has no real like ability to be really divided by like 7, right? Not really, right? But you can always start with a base 3 number. And always start with a base 3 number. Yeah. It's like we're not gonna do that because that's a frustrating thing. And then we can do divide by 5, you get 72. Right? Like that seems cool. What does that matter? 4 and 6 and 8. This number is divisible by is numbers. A pattern has emerged. A pattern. So 50, 40. Right? We gotta get to that number for a factorial of 7. So we'll use, since we can always start with 3, right? So you have to know that. Yeah, that's true. Factorial of 7. You're always just moving these numbers around the right way to effectively get this faster. That's all that's really, if I'm going to divide this, right, by that way, and then you eventually realize, oh, if I just do that and then multiply by 2 at the end, like I suddenly changed everything. But in reality, it's like, oh, right. And wait a second, it's getting faster and faster, right? Like you're able to understand it faster and faster and faster. But this number is a easily divisible by number, by any one of these numbers. This is effectively all I've been saying for a long ass time. Oh yeah, I know it is. Even the very number that is the number itself twice. Remember that sequential number? Yep, and you got 360 divided by the same number sequential. You get, which is just double the same number of the factorial. You get that number, right? So if you understand that, because it'll work every fucking time, then it's like, all right. So then you get to 7, right? It's really 14, right? Multiplied by any one of these numbers, even though it's common denominators, right? So it's like, right. So we'll do 14, and we know that we can use the same kind of technique for 14 again. Yes, which means you only need to really know one of them. This is kind of the point I'm trying to make, but it's not coming across very well. So, yeah, I'm just gonna change this a little bit. Right, so 14 times, what number do you want to start with? For real, it's like 3. Uh, sure. Yeah, no, I mean, that's not gonna really, we're not gonna do that. Really? No, it's not like the right kind of fucking way to go about this. So I'm trying to lead you to the right number that you have to fucking like multiply by, but you're just not doing it. So it's just like, okay. So 7 times 6 times 5 times 4 times 3 times 2. It's 50, 40, right? Yeah. But you divide it by 14. You get 360, right? You divide it further by 14, right? Nope. By 12. Sure, yeah, no. That's a relevant number. 7, no. By 6, yes. By 5, by 4, by 3, by 2. Have we noticed a pattern yet? If you multiply the, okay, wait. Let's do it with 6. So it'd be 720, right? And we can divide it by 12, but we can't divide it by 6. No, you can, but like that's a whole other thing, right? It's gonna get there. We're getting there. Okay, all right. That's all you have to remember. You can take the first number, you can just double it and multiply it by what itself? No, it's certainly by any other number other than just itself. Although sometimes it works with just itself. But yeah, but it's like you'd want to know the lowest common denominator of the three. That's the fastest way to do this. You know what I mean? Like it literally is the fastest. Like literally, you just figure out the first fucking number that the low like that any of those, and then you can just immediately get to the final number, and that's what I've been trying to get to for all of you, really. But like it's kind of annoying that it's just. Mm. So, anyways, so we'll do 7. Nope. We have a 7 factorial and multiply 14. And screw it, we'll do 28. Right, because fuck it. And that's fine. 14. Sure. Yeah. So we're gonna start with 14. Well, I mean, we know that it's divisible by that and by 2. Okay, so if we know 50/40 is divisible by both the first number sequence and it's doubling and by 2, then we also know that there's a way to always be able to figure out that given number. That's what that would be. There's 12, there's 24, there's 28, there's 360. They always seem to be the same kind of fucking number based upon a base 2. They're all base 2 numbers because that 2 basically just makes sure it's always going to end in a base 2 number. That's a given factorial problem that they're just going to have to deal with no matter what, whenever you're doing any factorials. Okay, I see that, but like, what does that matter? Okay, all right. So 7, to take the first number, you know that it's divisible by itself and this and that, right? And we already know about the sequential, right? So like you should be able to figure out this fucking number so fast. I know, right? It's like whatever, fuck it, you know. So it's like, all right, so we'll take 17, and I mean 14, and then 7, and then we'll adding. Really, I'm not gonna add. No, I'm fucking done with like fucking trying to cheese that. Get out of here. Anyways, so I'll take 14, and then we have to get to effectively any base number 2 number. Yeah, but this is already one of. Yeah, they're all one of them. That doesn't really matter. We're trying to take any one of those numbers and use the lowest common denominator as a way to effectively double some of these numbers. So we can probably do 14 and 12. Right. And then same thing with 10. Same thing with so here 8 and ooh, went a little bit too far. Yeah. So 14 is 10 times 5. That's not gonna work. So 14 times 12 is still not really that great. So 14 times 7 times and fuck this. I'd rather just get to it faster. Truthfully. Yeah. So if I know that, I can double, I can do I always know I have to just get to effectively like 120, right? I can just do, wait, what? Yeah. I mean, it's like I can literally get to any number from 3 So any factorial, it seems like it's just going to go from 3 or 2 effectively all the way up to whatever number it is. I'm just trying to find the sequence now. Hey, thank you. So it'd be 14 times. So 2 times factorial 6. I mean, that's the thing. I just remember that it's like, oh, I just start with like 360, but it's and then multiply by 2. Like, I mean it. Like, I can literally just figure that part out like that because it's like, well, yeah, no, then it's just by 2. That's what it is, right? It's like same thing for 50/40. So it's like 50/40 is the same kind of thing of like, well, it's just divided by the same kind of thing. It's 360 times 14, right? So it's like 7 times 360. No, 14 times 360 would work out to be the same thing. So it's like 8 times 7 times 6 times 5 times 4 times 3 times 2. Just 40, 32 divided by 16, which is the same number as 7 times 360. So that would mean that I can definitely get away with dividing that by 360, and that'll give me 7, which is cool and everything, but uh, that's not really what we're aiming to do. So divide by 16, and then that means I can always divide by a base of 360 again, right? But like I can probably get away with a different number entirely, because that'd be easier as a base 2 or a base 3, stuff like that. So I'll just use 360 for a while and see if this is actually going to work. And no, 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 no. What? Oh, yeah, no, that's the right number. Okay. That means I can divide it by 18, and then I can divide it by 360, and then it does work. So it's always working so far. How would you get this stupid number? 18 and 56, I guess. So I have 18, like 9, the base 3, new, the base 2, though, does work. But that would mean that the base 2 number is always like going to be able to multiply by a given number that is not the sequential, not the first number, and instead it would be a number by 360. So every number by 360 would then be something I can use to go from there to any other given number. So I didn't have to remember that it's not that, but I could use that for that and that. No, it's not working. All right, so this divide by 18 and then divide that by 360 always seems to work no matter what. How do I get to 56 though? I get to start with 360 no matter what for any given number. I have to have that be multiplied by 2. All right, because that's the base 2 number, but that base 2 number doesn't really work the way I would like it to for this one, which means, all right, that's because I'm trying to figure out right, so 360, I'd have to do 18 first, and then I have to do the base 2 number, with multiplying by that base 2, but that wouldn't work because I can't use the base 2. So it's like I need to figure out from that 360 multiplied by the 18 for the factorial of 9. And that gives me, okay, so 18 times 360 is a good number to start with. Right number, so I'm already figuring out that part. Let's see if that works for 7 times. So, I can start with 360. In fact, I can do it in 6. So it's 360 times. Is the base 2 though? Right, yeah. So it's like base 2 would immediately be that. Right, and then that's the exponential. I've already seen that pattern quite a few different times for what it's worth. So let's see here. 7 would be kind of the same thing, I think. So 50, 40, which would be, yeah, no, I'm just fucking around, trying to see if I can like make an even better one or if I can figure out something for what it's worth. It's because I want to. I've kind of like gotten distracted instead of like trying to do an act or anything like that. It's just like, fuck this. I just want to fucking fuck around with my calculator and my phone. So it's like, all right, so let's see here. So 360 times 40 is immediately, well, the base 2 number. So instead it'd be multiply. So, oh, wait, okay, wait a second. So it'd be 360 times 2 would immediately be that base 2 for the factorial 6. And then I can do 14 times 360 because that's the base 2 number of the 7, which immediately give me that number correctly. And so that would mean that 8 times 7 times 6 times 5 times 4 times 3 times 2 is 40, 32, which would divide by 360 would be 112. Right, so like that base 2 number would be 16. Well, let's do that number again. I divide by 16, which is 25, 20, and then I can divide that by 320 or 360, which is 7. So, which would be in the last sequence. So, like the last number in the sequence would be that thing. So, I mean, the number in the sequence, the way down from 8765, all that. So, all right. So, as a result, that means I can use the 360 times 7 times 16, which will give me immediately the right number. And then it's like, I wonder if that'll work like a similar way. So I can do 360 times, see here, 8. Let's not do that one first. Let's do 18 times 8 times 2. And then, okay, give me a second here. 9 times 8 times 7 times 6 times 5, 362. Divide by 360 is 1008. Divide by next number is 126. Divide by 2 is 63. So it's like, yeah, that's cool. I've already got like a couple of patterns here. So 362,880. And then divide by 18. And divide by 360, 56. This is the fastest way to do it. So 360 for factorial start with, and then I need to immediately remember that I need to multiply that by 18, right? It's like, well, that's for that number. Yeah, that's that's the thing. Like, I can't do that number. So it's like I have to remember that that's the number that is not the number. I have to do 360, and then there's a number that is. So what is that number? 56. So 56 is a number divisible by 8. So it'd be a number that's always divisible by the previous number, which is what we just said. So be like, oh, right, well, it's not going to be, would that be the number in the next sequence, right? Multiply those two, right? Because, like, well, no, because it wouldn't work the same way for fucking 14 or something like that, or 7, right? Yeah, well, give me a second. Yeah. Right, so 7 times 6 times 5 times 4, right? So times 3 times 2, 50, 40, right? which is then going to be divisible by 30, 360. That is divisible by that number by 2, but then that would be different than what I'm looking for. So we're going to actually go with 5040 divided by 14. Right. It is always that number. And then that would be the start of the beginning of the sequence because it would be 360. So I can always start at 360 and multiply by that number and I immediately get it. Right. And then for this one would be, where's that fucking number? There it is. So this would be 40, 30, 40, 30, 20. Okay, so then that would mean I start with the same number, so divide by 16, and then I divide by the number divisible by, oh no, it's 360, this would be 7. So that's the next number in the sequence. And instead, it's like, oh, instead of 14, I could just immediately, and I don't have to do anything. It's like I'm already seeing that that pattern is the next number previously, so I could do, see here, 360 times 7 times 16, which will give me the right number, which is the thing I was doing, and then 9 times 8 times 7, right? Then that's the same thing, or it'd be dividing by first 18, which is that, and be, see here, divisible, so we do 360 this time, which should be 56, which is going to be a divisible number. So this one would be just multiplying those two numbers. So we do multiply 8 times 7 is 56 times 360 times 18, and that is the correct number. All right, so then all right, so 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. It's 3 million. All right, so then we immediately do divide by 20. That's right, and then we divide by 360. And that number is 504. 504 is a divisible number by 8 and 7. So this would be 9 and 8. So 504 divided by 9 is 56. So there's a pattern. That's a pattern. That's a definite pattern. Figured it out. That's a perfect pattern for this. Every time. You just have to use 360. It's literally the perfect pattern. Got it. Immediately. Picked it up like that fast. Like, that's immediate pattern stuff. Right. So it's like that's 9. That's right. But it's like also 504 divided by 8 is 63. It wouldn't matter though. That's who cares? Because it's 504, right? Right. It's like you have to remember that it's like right. So 504. These are other people that are gonna listen to this. So I doubt it, considering how long this recording has been going on for. So there's that. So, anyways, 504. Then you have to divide that by 9, which would be 56, which is always going to be a multiple of the 8 times 7. So we'll just do that. So we'll see if that works. But it's like 8, you multiply 8 times 7, you get 56. Then you multiply it by the next number above. So 56 times 9. And then you multiply that by 360. Then you multiply that by 18. I'm sorry, 20. And then that gives you your number. So it's like, all right. So we'll do the same thing. So we'll start with 56. And we'll multiply it by 9. Oh, no, we have to do this the right way. Right. So 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. Right. Did all that correctly. All right. So that means I can divide this by 22. And then I can immediately divide that by 360, which that means I can immediately divide that by 504 if I wanted to, but I'm not going to. Instead, well, though that would be the right number, the right next, yeah, because it would be 10, right? Yeah, it'd be 10, so that's what we were doing. So it'd be, yeah, because that's what that was. It was like, but it's always 56, so it's like eight, that, that. Right, and that gets you, okay, so divide by, and then that 50, like 50, 40, which is another 7. Right, and the number, right, yeah, no, and then that's the same fucking sequence. This is like just multiply by 14, but it's actually 7, which would mean it'd be 56. Right, so divide by 56, which would be 90, but we're not going to use 90. We're going to use, we already did the 360, so it's always a base fucking number like that, it seems like. Right, so we just do 56, though. Yeah, no, we're not doing 56. Can you get the fuck out of here? Remember, we have to understand that there's a pattern here. So it's like 11, 10, 9, 87, right? Right, so we already did the 22, we already did the 360. This is what we did the previous time. That's an immediate pattern recognition right there. So it's like we did 18, then we did 3, and then that's the previous ones before, and then that means you can immediately multiply, right? So it's like same kind of thing. One's previous means you can do 10, then right. Because it's like by that, the one before, if I wanted to multiply it, it'd be 504, which then 504 is the same number as the 56, which is just 360, or not 360, 14, no. 7. Yeah, I just did this too. I should have wrote this down. It's a good thing I have my calculator that has some degree of actual like memory. So 50, 40, and that's 360 divided by 14. So it's always 14, which means it's always the 7, which means it's always going to be 7. So I can immediately just go like, right, 7. So there's another 360. This is 14. Let me see here. So if I wanted to do that, then it'd immediately be the same kind of thing. Like 11 times, 11 times 10 times 9 times 8 times 7 times. I know I already did this. I don't care. I divide this by 22. That's immediate. Like I get that. And then I divide this by the 360. This gives me that. And I just need to work out the 50-40 faster. Instead of like being like, man, I need to fucking remember 50-40 for factorial of 11. You know, I don't want to do that. So it's like, right. So that means I can fucking do 10 and 9. And since it's divisible by 10, that means I can divide by 10, just like I did before, like for the 9. So like you just get that previous number I just did for that fucker. This guy, 3 million. So divide that by 18. Or is that the wrong one? Eh. Alright, so that's the 10 one. Right. So, and then that gives me divide by that by 360, which is 9, which is the previous number. Right. And I divide by 9 and I divide by 10, that gives me the fucking 50, this is 504. So 504 is then something that I can use for the 56, which means 504 tells me, so 504, because that's divided by 10, and then you can always use a multiplying of 56, right? Because that's what that'll work into from the past here that I'm seeing. Right, 56 multiplying by 9, right? Right. So 360 by 20. over 4 divided by the previous number, 5, is 56, which we now recognize that as being the 8 times 7, right? And then you have to do 56 times 9, and that's how you remember to do 504 times 360, which this one is 504 times the number above, which is then multiplied by 360, which is then multiplied by the 22. This gives you the right number every time. The pattern is complete. The pattern works every time. Pattern works every time. So 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 equals this ginormously long million. Okay, so then it's like we divide that by the 12, so that's 24, right? Then we divide it by the 360, right? Then we must divide it by the number previous, which is 11, which is 5040. One number previous is all it takes, seems like. And then from there, you can do 56 every time. Like, literally, yeah. Because it's like, just divide that one by 10. But it's like, you don't need to remember 10. You don't need to remember 50. You can just go from fucking 56 times fucking, was it, again, it was 56 times 360? Is that what it was? Says 50, god damn it, scroll. Scroll, bitch. Right, you have to do 56. Well, but you don't, though, unless you want to. It's 56 times 9, and then you have to do times 10. So we're doing the same fucking pattern again, times 360. All right, yeah, no, because right, we don't even start there. We can always just start at like, just remember that, right? Yeah, you can just remember that for like a factorial past a certain point. You just start at like 5040. So then you can just do like, see here, 5040 times 10 times 360, and then you just have to multiply it by the double of the number. So 12, those would be 24, which is not what we're doing, right? So that's, so there's more step there. There's one more step. So we have the 5040 by 360, and that's where the 39, right? So we got that incorrect. So we have to do one more step there, right? So this is where, all right. So I didn't jump ahead too far, I guess. Divide by 24, divide by 360, and then we can divide that by the number previous, which is 11. So that's 5040. So I have to go from 5040 times 11, this is the number previous, times 360. So I believe we just did. Yeah, by 11, and then that's that number times the fucking 360 times the 24. And it gets me the right number every fucking time. So it's like, all right, so then it's already a pattern that emerges for 5,000. Yeah, no, well, I mean, it's always there. Yeah, the pattern's always there. It looks like. Yeah, there's a factorial pattern here. There's a real easy factorial pattern. That's 26. That's 360. That's the previous number. Then that's 10. You can do if you wanted to, but you don't really need to. I mean, you did 11. No, I did 12, didn't I? Yeah, divide by 12. Yeah, it's just the previous number. Right, but it'll always work out to being like a number that you can just multiply. Right, yeah. So it's like if it's a factorial 13, you can start with 360. You can multiply it by 56. No, not 56. start with 360. Then you have to multiply that by. Give me this. All right, so we have to start from basically kind of like scratch there. Yeah. So do 360. Just gotta get to 50/40. Yeah, kind of almost. I mean, it really depends on what we're trying to do here. So I do this, and then let's see here, divide by 26, right? Divide by 360, divide by, which actually we can do that differently now. We can do 50/40, divide by 50/40, and I can divide that by 56. Well, I already had a pattern there. I should have just kicked that up. All right, so yeah, so here, this is that number. Damn it, I'm just gonna do this again. All right, 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. All right, so this means I can always do divided by the same number twice. This is 26 instead of 13. It's 26, and divide that by 360, but I don't need to do 360 because it'll always be a given number, like 50/40, right? And that means I can start multiplying by 50/40s instead. But then that number then will be the previous number, which is 12, right? And then that number will be, I think, basically 56. It didn't work. Yeah. So that would be, because I did 50/40. I bet you it'd work if I just kept it as is, though. Yeah. So, so 360 is what we usually do, right? So 360, and then I can do, see here, the previous number, which is divide by 12, right? It's always looking, yeah, divide by that, by 10, seems like, but it wouldn't really work the way, because it's like, no, uh, that does mean that that number is divisible by 50/40. Yeah, I was like, yeah, by 11. So it's like it's always the next number sequence seems like, yeah, I've already hit on that because there's 13 to 12 to 11, right? And then like that's the 50/40. So right, and it's like, oh, okay, right, yeah, but that's 360. It means I can skip this every single time. I don't have to do that. I can just multiply by 50/40 to a point. Let me see that real fast. And then this. Yep. There we go. So then that means I can divide that by 26, divide that by 50/40, and then I can divide that by, it's already basically 50/40, so that's what I was doing before. I can divide that by the 12. There's 3960, which that one can start with a base of some number that I would be able to use. It's like I've already got a fucking sequence from that fucking 360 and everything else. Yeah. I suppose if I wanted to do it faster, we should just keep it at the 360 or whatever it is. Yeah. All right. So there's that. That is not the right fucking number, damn you. There we go. So we'll just divide that by 26 like before, and then divide that by 360 like average, and divide that by fucking the number finally that, and then if I know that, then it's like, I know I can start from 5040. That wouldn't be the right call, but I can start from 360. 360 just as a base, and then I can multiply that by 50, 56. Is that what that was? From back in stupid, damn it, calculator not having enough memory. Then I can multiply that by 12, which doesn't seem the right. So I start with 5040 again. There is a sequence there, though. That's the thing, it's already there. Start with 360. I just need to multiply that 5040 basically. Multiply that by 12, and then multiply that by 26, which is not getting me the right number. So that's a no. But close. Surprisingly. 13, 26. Let's just move on from that. Take the first number. Actually, let's start from the top. We'll go with 10. All right, so that's 3 million. All that. So then we can divide that by 20. We divide that by 360. Divide that by the next number, which is 9, which is 56. Right, now 56 times 360 is that number, but that won't work. So I have to do the next number in the sequence, which is what that was about. Then we can multiply by 360, then we can multiply by 10. Nope. I should write this down. Yeah. Divided by 360, divided by 9. So I multiplied 56 by 9, and by 360. And then it's, alright, I have to double the number. Alright. There we go. That's what it is. So, start at 56, multiply, but like we can, let's do that sequence order of operations here. So you divide, so final one will be multiplying by double first number every time, right? Then 504, 360, yeah, that seems to work every fucking time. Yeah. Alright, so let's see here. 11 times 10 times 9 times 8 times 7 times 6, 9. There we go. That. So we do divide by 22. Right, that's the last sequence. Then we divide that by 360. Right, and then we divide that by the previous number. So this is 10. I need 10, that's 504. Right. Right, and that's 504, which is honestly pretty close. So 504, 56 and 9, which means you understand that from 56 and 9, you can multiply by 360. Multiply by 360. Right, and that gives you that number. Actually, wait a second. 504 times 9. Actually, you don't need 9, you need 10. So 10, because it's the next number in sequences. Actually, that's something we have to write down. It's like modify last, that's that thing, and then we have to do, see here, and then multiply by 360, and we add to previous, so next number in sequence, multiply, right, and then right from that, so that's the thing, it's like I can still divide that by 360, which will still ultimately have it as a base number of 7. It seems like it's always a base number of 7. It's a bit weird, but it is. You know what I mean? Yeah. So it's like, well, 14. I'll start from 14. So it's like, all right, for 14, then I always have to go to multiply by, what is that? By, 360. So I can do a double 360. Yeah, there's a way to do a double 360 here. So multiply by fucking 360, and then we'll start off that, and then we'll do the next sequence, which was 10, and then we can do the next sequence of 360, and then we can do the next sequence of this fucking 11, I think it's 11. Yeah, 11. Yeah, that's too far. So it's like 360, it's 550, 50, 40. And 50, 40 is nice and everything, but like not necessarily. Right. Oh, that's because I skipped. Right, I skipped. Yeah, I'm skipping the next, like the 10. That's what that is by meeting. So I can't do the 10 from that 14 by multiplying it by 360. So I start with a base number 7. So if I start with 360, I can multiply by immediately just 14, which will get me basically almost all the way there. And then I have to do multiplying by the double of that. That's basically what that is, it seems like. Alright. Let's see here. And that's. Oh, I need to double the 360. That's what that is. Alright, so 14 times 360 times 360. Which then means I can do the 22. Which then gives me the 39,916,800. Which is exactly the right number. So I can always double by 360s. Let me try that again. Start with 14. It's 360 times 360 times 360. It'd be 13. So it'd be 13. Alright. So it's a base 7, it seems like, past 7. Let me just do that real fast. So 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. Whew. Right, so it's not the right number, and that sucks, but that's normal. It's always getting there, right? I can't start with 14, but I can divide this by 26. I started with 13. Yep. Which gives me that. Which then can give me 360. And maybe 360 again. But I can do dividing by this 360 first. Then I can divide by 12 then. And then that as a base number that might be something I can actually use if I use a 360 again, which it is, which is 154, which can then be divided by 7 as 22, or 14 as 11, which is the next number in the sequence for 11. So 11, which is how you'd remember that. For the sequence number, there's already a pattern here, right? So it's like 11 would then be something that I could use as like the base 7 number. So I could use the base 7 like I was saying for 14, and then I could multiply that by 360. So 11 times 14. What do I think that was, right? Yep, and then I can multiply that by 360. And then I can multiply that by the 12 that I need. I think that's what it was. Yeah, so 12. And then I can multiply that by 26. Nope. I got it 5 with 12, so almost there. Right. Oh, I need to do the extra 360. So that, and then I can multiply by the 26. Then it's like, it's always a base 7. It seems like, because that is the correct number. Yep, that is the correct number. So let's try this one more time. So 14 times 13 times 12 times 11 times 10 times 9 times 8, 7 times 6 times 5 times 4 times 3 times 2. Cool. All right, bigger number. So we're going to divide this immediately by 50/40. Fine. Fine. So by 14. And divide by 28 then. So we can always get 28 to work. And doubling of whatever the first number is. And we can divide that by 360. And we can divide it by the previous number, which is 13. Which is what we were doing previously. Let me just look at that. It's the 14. Another number here that like we had before. Yes, it is. Oh, what do you know? That's that, and I can divide that by the 12, or I can choose the 360. Divide by 360. By 360. Because then I might be able to divide it by 540. Nope. Or 56. Yeah, it is. Okay, 7. Ah, damn it, the number. Divide by 14. Yeah, that works. 56, 33, base number 7, 360 again. 36 does work, but it's 33, but that's the 11. Right, but that's not 12 because we're starting with 12, so that doesn't work. So what if it was 12? 154. Oh, 154? Hey. That is the 11, though, for the next one. So that means I know I can just immediately multiply that. God, I could just do like that, like pretty much all the time. It's like 360 times, like, it's base 14, so you'd have to do, let's see here. I mean, factorial 14. So factorial 14 would mean I have to understand that that 154 needs to get to 1,848. So I can start with 360, right? Yeah, but I have to multiply by, so well, because that would be the next number in the sequence. So, well, 3 sequence are numbers down. So it'd be times 12. Give me a second. All right, so 360, and then I have to get the, all right, so then that would be then 12, so 154. So that would be, okay, so I start with It's 360, it's 11, so I need 11, base number 11, right. I need base number 11, but I need to go with 12 because I did 12 at 360 twice. So 28, 360, 13, and it's 12, 360 twice. So I did 360 twice. And then, so it's like a 360 every time after you double it for every number that goes down. So I can't start with 360 technically, but I can start with the first number that I want to, which is 12. And then I can start with a number of 360 for that, right? Which will give me a given number that is something I can use. Is that will be a number that is divisible by the next number in sequence. So, well, multiply what did I just do? 12 times 360. Yeah, I don't really want to do that though. 154 will work for 11 times 14 because I can use that instead. That's 14, but it's like, look, right? So 154, 1848. The only reason why I know that is because of that 360 number there. So I have to get 154 for that given number, and I have to remember that. So that 154 has to be dropped down. So 154 divided by 7, 22, which is 11. Right. But I have to make that number like do a lot more than that. Yeah. So because the only reason why I know that it's like 1848, but like you wouldn't know that. Right. Right. Let's start this from the top instead. Let's just continue doing it the long-handed way, I feel. Right. So do this one. So divide that by 14. Divide that by 360. Divide that by 12. Wrong. 28. Divide that by 28 first. Then we want 360 after that. And then we want 13. But I could probably get away with 26. And I did. I can double it every single time. Then I can do 360. And I can do 7 and 32. All these numbers are absolutely 100% easy. I can do another 360, almost. All right, we already know about the sequence here. Yeah, oh, right. What am I doing? I gotta do the whole fucking thing over again. Right, we got that number here. So that's after the 28. 26. Yeah, 28 dividing. Right, and then I can divide that by the 360 like we normally do. Right, and then I can divide it by the next one down, which is 13. I can divide that one by another 360 because that'll, well, instead of that, we can do 12, right? Right, and then that one will allow me to do the division of 360, I suppose, which is 154. So 154 to 13 and 12. Seems like that's how many steps you need, like every fucking time. It feels like. It's like you can start at like 7 practically, right? Yeah. So, well, 154 as a base of the 14, or not the 14, the 11, which is what the next number would have been, and then that allows you 154 divided by 14 is what that was, right? Yeah, it just has the base number of 7, which seems to always occur constantly with this, you know. So it's like, all right, so I can start with 11, and that's the last right there, 14, 13, 12, 11. So it's like, right, so I'll start with that. Then I can multiply that by, oh, right, 14 is a base. So, oh, right, because we started off with the pattern as the multiplication of the 7. So the pattern started off with 7, so we can multiply 7 twice, and then that'll eventually get you to the factorial. So it's like, right. And that's how you remember that. It's like 11 times 14, which would give you 154, which would then give you the 12. All right, we don't want 12 though. They wanted 360. Right, 360. So we do that alternatively. We do 12. Then we do 360. Then we do another 360. No, that's wrong. Already doing it wrong. All right, now I have to do. Oh, it's every other. That's what that is. Okay, that's what that is. So this is the right number, and then it's 13. Right, so it's 12, and then. Right, no. Okay, so give me that number actually. Instead, first that number, and then I have to multiply by 12, 13. Right. Then I have to multiply it by 360. And then I have to multiply it by the double number, which is the correct number. There we go. That is indeed the correct number right there. Yeah. Yeah, right there. But you know. So I can easily start with a base of 14, seems like. Yeah, and then I can multiply that by, what was the number? 14 times 11, looks like. And then I can do that alternatively. So 11 times 60, it seems like, and then I can multiply that by the fucking 12, 13. Like, where are we going to? 15, right? So yeah, now I have to do that by 12, that by 13. Multiply by 13. Then that means I can then do the 360 again, which then means I can do the, where are we at on that? We're at 13, so that means I can do 14, and then I can multiply it by fucking 30. Yeah. See if that pans out. So we'll divide it. Here, we'll do the brute force way. 30, no. 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. And that is the same number. Same number. Get the same number every fucking time. All right. Alrighty. So that seems to mean that every fucking factorial past a certain point just starts as a base 11. Then you just multiply it by 14, which actually technically starts as a base 7, truthfully, because then you just multiply by 2, and then you have to skip by the 4 for 11, then you have to skip forward by a 360, which that explains why I'm trying to do the fucking, because I've already got a pattern, right? The pattern is 360, it alternates every 2 times, and then you end with it doubling on the last one. That's the pattern now, right? And it works every time. But that also means that there's a 50-40 here that works. So we're going to start with this number, right? And then we're going to divide this by 50-40. In fact, I can probably get that further for one of the other numbers here, the 440, 440, right? Which is then able to be by 50, 40, which can then be divided by 360, which is 13. Every factorial can be done by one of those base 2 and 7 weird odd numbers, like prime numbers too. But it works every fucking time. So it's like 360 and then 50 40 and then 55 40. This always works, it seems. So let's see here. But that gets me to that one really, really, really quickly. But that's the base 13. So 13, but that number would be the 15. So like that's 2 down. So like let's see if that works for 2 down or for 2 up. So 13 times, let's see, or 360 times 50 40 times 55 440. Right. And then it's like, then the next number should be that fucking other number. What the fuck was it? Right. Oh, well, we'll just do another 360. Can't do that. What? Can't do that. Right. There's like a definite sequence here to do this lightning fast, man. That's for sure. So it's like 1632. Hey, if it works, right? So we'll divide. We'll just see that. So 16 times 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2. So it's not the right number, which is good, because then that would have been fucking like extraordinarily lucky. There's just no way. But it's like, all right, but it's still the same sequence. Oh yeah, no, but like that's the thing. Past a certain point, you just start using the same kind of fucking numbers. Like you can divide by 55 for 40, and it'll work. And so like if you do that, but it's like no, you gotta remember the first one. So divide by 32 first, then we can do 55 for 40, and it'll still work, right? And then I can do that one by 360. And I can do another one. Fuck it. Yeah, 55 or 40 probably. Almost. But 50 40 will work. Yeah. That's the only thing that you kind of need to remember for each one of those. But like you have to remember that every one of those steps. Remember the algorithm of the steps? This is what the actual steps was. But like you don't probably think that because I wanted to do this. Just fucking eat it off. Like just fucking thinking about things. Anyways, that's 2340. Which now means I can do 360. Ooh, almost, no. But what about 154? So close. 7? Oop, 56? Oh, dude. I know, right? It totally changes the numbers. Yeah, the pattern sequence? Yeah. But that does mean that it's like a base 2 for sure. That also means it's a base 12. That also means it's a base 24, almost. So it's not base 12 though, although I can make 12 work at 195. Yeah, but that gets me to, because that's how many steps. We started at 16, I went 1, 2, 3, and then we got back at 12. So 32, that's 1, and it's 55, that's 2, that's 3. Right, and so that gives me 4 here, right? There's 4 steps so far, and since we started at, that gives me it at 12, which would explain why you have to use 12. Because that would work for the sequence numbers. Right. So then I can divide this by probably 11? Ooh, so close. 195. Well, 5, obviously. That's 39. Yeah, I can divide that by 14? No, obviously not. Too bad. I know, right? Wouldn't that be nice? Do I need to divide it by anything? I mean, if you understand the sequence like that, then like you wouldn't basically, because it's like 12. Oh, is it factorial 16? Start with 12, multiplied by 195. Immediately just give yourself 50 40. Start with 55. Oh, wait. sorry, 55 or 40, then you multiply by fucking 32, and then you get the right number. So that's totally doable. You just have to remember for factorial 16, you start with 12 and then you just multiply by 195. But it's like you have to remember like 195 some other way. So like it's way easier, way faster, by the way, because it's way fucking like easier as like a table basically to remember it. Because like most of the numbers are 360, 50, 40, 55, 440, stuff like that. They're all based like sevens and twos and stuff. But it's like, what's 195? It's kind of the problem. Is it 13? I don't think so. No, it's definitely a base 5 though. Yeah. So 52, 195. I mean, it's by 5 is like it basically. Yeah, there's another number. There's got to be a fucking number with that. No, no. Well, I mean, I can start with 12, right? And then multiply. Right, we're just going to do this real fast with that. And then we'll just multiply by that. And we'll just multiply by it. So it's like, all right, so 32, sure, to get that number. Right. Right. Did that wrong again. So 12, right, 50, 40, and then, yeah, so 12. Right, I forgot the 195. Oopsie. So then I can do 50, 40. Then I can do 55 or 40. Then I can do, fuck, damn it. I didn't hit the multiplication apparently. 55 for 40, right? And then I can do 32 to get that number. And it's like, all right, so if I want to go from that number to the next prime, how do I do it? I mean, not prime. Although that would totally work for fucking breaking out and destroying algorithms for any fucking encryption. Just wreck their shit, and it seems like there's always a pattern to it. Anyways, so the next one is that's 16. So we want to do 17. So then we just do 360, right? Because we divide it by 360. Well, actually, no. Or would we? Let's just do that. So, give me that number back. 360. And then I run out of room, so I don't know. My calculator! No! Alright. Does it give me more space if I use this one? I hope so. It does not. You suck! You're the worst! Alright. Calculators, you need more space for me and my big numbers I'm calculating. You damn bitches. Anyways, all right. So we'll just do that number first. All right. Then we'll start with the 16. Let's see if it still works. Right. So we gotta divide by 32. Then we gotta divide by the 360. Then we gotta divide by the 360. Apparently. Wow. Oh shit. Double 360s immediately give you just a repeating number. That's always a fucking 5 with a 4 and a 5. 504, 504, 00. Oh, God. Anyways. All right. So I've already done 2, but then, like, the sequence is always the same where, like, you go backwards by the same number. So since we started, that's 15, right? Right. And then, like, that's what it was before. I already forgot my fucking sequence. So multiply, say in sequence. So the next one below would be the fucking 15. This is what we just did, right? And then well, actually, could we just fucking double that? Give me a second. So we gotta divide by the 360 again, which does not work apparently. Oh, that's good. Why? So then we can divide by the 14 here. Right? That's what we did. We did 360, 360, 30. That should work though. By 14. Right. And then 360. Yeah, so close. Damn. About 50, 40. It's not gonna work, unfortunately. 56. Hey, it does work with 56. Oh, you know. It always seems to work with these base numbers. Well, we're at 15. Okay, so then like if we're at 15, then we can't do 360. So the sequence already broke, is what it said. Yeah, because I didn't do the sequence right, to be fair. So it's like you're not supposed to double that. It seems like that's what that would be in terms of a problem. So we'll divide that by 32. Right, and then we'll divide that by the 360 one time, and then we'll divide that by the 15. Right, and then we can divide that by 360 again, and we can divide that by the 14, and divide that by the 360. Almost, so close. Look at that, it's already like basically fucking, holy shit. 24024, so I was like, we're already further down. But we're at 14, so we can't divide it by 360. So the base number of 360 is out. That sucks. Right? It was working so well. 56? Does work with it. Why does it always work with 56? I don't know, man, but I have yet to have a problem with 56. It always works with 56. Huh. Can I do that with those other numbers? Maybe. So just do 56, I guess? I don't know. Let's do instead of 56, because, well, what was that, 154? 154 will work. This is 156. Yeah. How about that? All right, and then we can do base 7, base 14. Nope, nope. Boo! 156. Yeah, I know, right? So there definitely exists a fucking pattern here. Like, there's no way that there's not. I mean, just alternating a 360 seems to always work no matter fucking what. But it's like, then it's like, well, because of 16, we'll go like, well, 16, right? Okay, so it's 16. All right, so it's like, all right. We already went down to fucking, what was this? 13, 14, 14, 14. So all right. Went down to 14. We have a 13, which is a fucking prime number. So we just have to add a rule of prime number. Then as 1848, which is, I believe, one of the numbers that we came up with before. Which means I can divide that by 14 or 12, which is 154, which is one of the numbers that we needed. There is actually a fucking pattern here, though. I know that sounds weird, but it's like, oh yeah, 14 because prime number 13, right? And then you just do 12. 12 gives you 154. 154 means you have to multiply by fucking 156, which would give you the immediate number. But like, you can't do that, right? It's like, but you can't divide by fucking one of these numbers. Oh yeah, 7. Base number 7. Ah, fuck. Another prime, but like the lowest prime in the given sequence, which that's the sequence. That's the pattern. So the lowest sequence pattern would be 7. So it's like, then you'd have to go from 13 to 12 down 1. But like, you can't, maybe. Give me a second. Can I divide this by 360? I think we tried that. Yeah, it didn't work. Sucks. Yeah. All right, but 720 might. No. 12? It does work with 12. Right, and that's the lowest prime. Well, no. What you meant was lowest common denominator. But like it will work with the lowest common denominator, which is 2. Which then you could divide that by the highest like fucking pattern sequence number, which is 132. But instead you just remember it as, well, I'll just go down one more from the 13 to 12, and then I'll just divide it by the lowest pattern. So it's like I'll start with 7. But it's like right. Except no. It's like since it's base 16 or the factorial of 16, you start immediately with 22. Just like then you multiply by 7. And then you do like what was that? The fucking right. Then you have to do 12, right? And then you have to do the 13 because that's prime. And then you have to do the 14 because like that's fucking stupid, but you know, prime means you have to skip, I guess. And then you end up doing 360, right? I think that's what that was that we did. All right, 13. Oh yeah, 13. And then the 14 is the 20. That's it. Right, so 14 gave me. So give me a second there, because I'm seeing it right there. Say 24 or 24 times 14 gives me exactly the same number that I need. And then I do multiply that by 360. And then that's the next sequence alternatively. And then that's 15. So multiply that 360, and then you multiply that number by 15, then you multiply that by 360, and then you multiply that by 32, and then you get the number. And it is the correct number. It's a very odd way of doing it, but the pattern's always there. I know that seems like it's not a pattern, but that's a pattern. It's a pattern every time. The pattern's always a base 7, a base 2, and it works with 360, 50-40, 55-4-40. It's always there. You just got to remember it that way. You can always work out a factorial that way. Seems like it's like it always works alternatively. Yeah, exactly. Like if I could do more and more factorials because it would work out that way, like I'd be able to figure out a bigger and bigger pattern here that would allow for me to effectively know the sequence. And eventually that would be the Lemke sequence because it's named after me of how to understand how the base 7 or the base 11 or prime, really base prime, but it's like it starts with 7, right? And then you have to do like the basic pattern and algorithm to work it out. Like it's always like this, and so it means like it's always coming down to a singular point of like fucking 22, 154, 156, or 360. Like I can probably get it all done from like a 360 point for what it's worth, but it's like I need to know what the base number is. So it's like if I know that it's like 16, right? And it's like, well, I know that'll always break down to 154, and then it's this sequence. You know what I mean? Like instead of factorial this, well, then it's this sequence to work out the factorial. Right? It's like 16, 154 immediately. Like you just remember that. And then you work it out this way, and then boom. But like that also means because of the 360, you can do it faster because it's if it's 154, then we're thinking about here for the 50, 40, 50, 40, 55, 440. Yeah, it's not gonna work. But like that's the sequence now, for sure. Like the sequence for sure leads like very far up to those other numbers, which cuts out the vast majority of the rest of the numbers. And the bigger the fucking factorial, the better this gets in terms of the sequence and being able to understand the pattern for like where it breaks down to a base number that you just have to remember as that base number that only has this sequence. which is the multiplication table for factorials. Which will mean it'll work every single time. Let me tell ya. Seems like it's always going to be using a 55 440, a 5040, a 360, a 12, a 711, or something like this. There's always like a sequence here. Like, there's a definite sequence if I could get that fucking number. Like, for sure. Like, there's no way that there's not. But see, the thing is like, it totally takes off once you get past factorial 7. Like, factorial 7 is the fucking number that starts the whole fucking process. Like, 6 is essentially the equivalent of like 4, for like the step-by-step thing. Remember the pattern seeking, right? Like, it's like, oh, right, this is, what was it, 8 or whatever? And it's like 4, and then, right, it has to get to 24. So then you'll just remember that it's like that. It's just 24 because well, it's the sequential number, right? Which is 8, I believe, right? And then that means it's just divisible by fucking base number 2. And you have to subtract, right, 8 times 4, which is 32, and then 4 times 2, which will be 16. But you don't really necessarily need to do that, because then you can remember that it's really like 8 times 3, because you already got the fucking number. Anyways, then 5 is 120, and then it's like kind of the same thing, sort of a sequence, right? And that means you use the sequential, but then it's like, right, 5 and 10 and 2. And it's like, oh, right, it's 120. Immediately you remember. 5 and 10 and 2, 5 and 120. Because it's like 1, 2 for the 10, 0, right? Like, because like, oh yeah, it's 10, is it right? But like, you wouldn't do that because like you need to teach them something or something instead of just memory. But it's like, right, except like how you would do that is pretty simple. Like, you go, all right, it's 10, and this is the 4, and that's the sequence. Started the sequence. And it already works also with the 4. It also works with the 3. Just like the 3 is the fucking base number that you'll use for 8 times 3, right? Or 4 times, right? And then 5, same thing. It's like, hey, it's 20. 5 times 4 is 20. Then multiply by 10, but it's not. It's like 10 times 2. Anyways, point is, whole thing, sequence, you'll remember, right? Then 6 is kind of the same thing, where it's like 720, 360, 6 times 6, 36, and then you get a 0. You got it. Immediately get 360 times 2, which is 720. So like, you'll immediately remember. But it's like, that's not what you're supposed to say. What you're supposed to go is like the sequential number, so the one that's before it. And then 6 times, fucking stop this madman. Meanwhile, me. So it's like, so it's 5 times the 12, right? And then that's 60. And then that means that number will definitely be divisible by the final number, which effectively means like that 6 for sure is probably going to need to divide into, what is that? Fucking, let me see here. And that's 72. That's 72. And 60. That means it's definitely 720. So it's looking for a 360 there. But you're not supposed to do that. But like, I shit you not, everyone's gonna do that. Like, you know that, right? You know that. Anyways, right. So, but we have to remember it differently, of course. We have to actually teach them. So it's like, it'd be the 5 and the 60. So that's base, and then like that means you have to remember the sequential, which means it's like the pattern there. Then turns into the 3 after, and then that's 60 times like 3, but you wouldn't want to use 3, right? We have to remember the first start of the 6 times 2, which is 12, right? And then that 5 times 2, 12 is 60. So it's like, right, right, because that's the sequence, that's the number. But then it's like, right, but then it breaks down because it doesn't, though, because it's actually 2, but also 12. It just happens to work with these factorials, you know, which is kind of rough because it's like, right, it's going to work out to 720, but that's only, it's only as a result of how you have to multiply it. Is this particular factorial thing? That's for sure, right? Because it's like, well, it's what is it, 12? And it's like, well, well, yeah, no, I mean, you start with 2, multiply the 60 from the 5 with the 12, right? By 2, which is 120, and then you'll understand that like the number for the 3, which is below that, because you know what I mean, then means it's like, well, there's three, but it's not 3 120s, right? Because it's like that's 3 times 120, which is 360, but that is 360, and then like you just have to remember the final 2 in the step process for the factorial, which just it's complicated, but like you'll fucking remember the pattern, which is the whole point of it, what we're teaching someone, and then factorial 7 is where it kicks the fuck off. It's like immediately think 7. Okay, the 7, fucking all right, we're getting there. All right, so that's 50-40, of course. That's 50-40. All right, see that 7? Yeah, I do. All right, so and then in the steps, that means we have to divide it by the fucking 14. It kicks off. It's the start. See, we already did the whole. It's 12. Remember the 2 times it's, and we have to do right. So it's like, all right. So 7, right? So we're gonna do 7 times the 2, which is 14. All right, and this is where it kicks the it's crazy, I get it. But it's like, remember that 6? Remember what we just did with the 6? The factorial 6? Yeah, we're just gonna have to remember 360. Like, it's a fucking very valuable number. So we basically are gonna go, right, remember that 6? But there's like 14 here, right? Number. Well, we already like did 2 of them effectively, right? So multiply. I know. I'm being such a dick about it. I don't care though, because it's like, well, you gotta do 360, but 360 divided by 12 is 30, but that's not great. So it's like 360 divided by. We already did 2 steps though. Yeah, but it's not good enough. But we can remember it by 5 and 6, multiplying by 5 and 6. Yeah, no, I mean you could do that, but it's not gonna work. People won't do it. That's not part of the sequence. So it's like you have to do 7, and you go like, all right, so we already did this, and it's 14, and then you have to do the fucking right. Just remember, just multiply it by fucking 360. But like, can't totally do that, which is the problem. So it's like we need to do the dividing by something or something, and not really. I mean, that's what I'm trying to do, but it's like 360 base 2. So we divide by 2. Right, and that's the next order sequence, which would then be divided by 6, which will give you 30, which means you know that it'd be 5 times 6, which is how that would work. Because then you can start with that, base 2, then you do 5 times 6. Should be 60. Apparently. Yeah, but no. Say you just start with like factorial 7, you start with 5 times 6, which is 30. And then you'd multiply it by 14. 420. Get out of here, you fucker! Which you don't need to do, right? So it's like, 720 is 50-40. Right, 50-40, right, thank you. Alright, so 50-40 divided by this 14, which is 360. And you have to divide that by this fucking base 2, 180. which then that means you know that you can use the 3 and the 5. So that would be the sequence. So you'd basically divide by, because you already did the 7 and you did the 6, because you did 14, so like that'd be the sequence. So it's like, but I suppose we can do it again. So 50, 40, divide by 14, divide by 6, which would be 60, right? But then that means you know that there's like a 5 after, right? And there's a base 2, right? So that means it's going to be a part of the 6, which would mean it'd be a part of an even number, which means it's definitely a part of 12. Or 3. Oh yeah, 3. Oh, so if I divide by the 3, then it's like 5 times 4. So 5 times 4, which is 20, then you'll multiply that. Isn't it 3? So 5 times 4, you multiply that 3 because of the base 3 number that you remember. Then you'll remember to multiply by 6, and then you'll remember to multiply it by the double of the first number. And then the sequence is started. Right? It's like you're working backwards, but then you get to the first forward. Right? Which seems kind of counterintuitive, because it's actually technically worse than the first fucking numbers, which is what I said. Like, it's not going to be better. Except, like, for what it's worth, it is actually a lot easier to do certain numbers way faster now. It's just like, well, it's 24. Is it factorial 4? Right? It's like, right? Like, you'd be immediately like, oh, 8, 3, 24. Done. Right? And it's like, same thing with 5. 5, 10, and 2. Right? So it'd be, right. So you immediately remember it's 120 just off of that. But it's like, you wouldn't do it. So it's like 120 divided, right? Because you have to remember it that way, but not really remember it because you'd be working it out. So you'd be immediately like teaching someone, oh, the factorial 5, you'd start with 2 as the base number 2, then you'd multiply it by 10 because of the step process, then you'd multiply it. Actually, you can do that differently, truthfully, because that's the sequence stuff. Yeah, you could do that way faster. Yeah, 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 yeah. Base 2. Base 2, I mean, it's 5. You wouldn't have to do that much work, like, honestly. It's the 10 thing, but then you don't need to know the 10 thing, or the sequence thing, but you need to remember the 10 thing, the sequence thing. Right. 120, yeah, but it's 5, so it's immediately, it's going to be pretty quick, though. It would be divisible by the 4. Yeah, yeah, yeah. This is how you have to remember that. So it's like, 120 would immediately just become like, oh, or factorial 5. You start with the 2, of course, but not really. You start with 4. Start with 4. You go immediately and jump that to the sequence number. Yeah, I mean 40, because I mean that technically works. And then you just know that, like, it just needs to multiply by the next number for 3, right? 40 times 3 is still going to be 120. I know that sounds really odd, but that's just because of that. But it's like, right, but if we wanted to keep it as the multiplication, so it's like, all right, right, right. So then you do 120 divided by 10, so that would be there, but you can't start there, right? So it's like you have to start with a base number 2. Base number 2 then needs to be multiplied by, but I don't want to use base number 2. It'll work every time. Oh yeah, no, it'll always work. I really like that. Kind of ish, but right? I mean, I do, but it's a kind of ish. It's one of those things where it's like, oh yeah, the base number 2 does work, but it's like, huh, how would I get around that problem? It's like they wouldn't really understand the sequence thing yet. Hmm. It's like base number 2. It's pretty easy to get to 120. But that's because of 10 from 5 times 2, and they immediately just go, oh yeah, that's 120. So I need them to not think about that way. And I need to not think about that way. Because like I'm already only thinking about it that way. So there's that. Right. So I need to get this here. The sequence would be then, all right, so there's 4, I have to multiply. I have to start from that base number, multiply by 2. And I can't multiply by 2, so I can multiply by that 10 for the sequence number for the number of that, right? Which would be fine. And then that would allow for me to get to 20. 20 then means I can do, instead of 4, I can do just immediate 5, which will give me 100, right? But it's like, then I can't really do the 5 times 2, right? Almost. Right, yeah, right. So, how about different? Yeah, right. Because it's base 3. Seems like, yeah. So we'll do base 3, and then we have to multiply that by the 10, which is 30, which will then give me a 40, right? I can't do that, so I have to use the next one in the sequence, which is 4. 30 times 4 is immediately 120. You know what I mean? Exponentiation, right? Hard shit, seems like. Yeah. So immediately 120, but I can't do that. So I can't do that by the 10, so I instead have to do the honorable thing of multiplying it just by 2, which gives me 6. And then I have to like come up with a number that from that sequence number, right? That's my problem. It's like 60, right? Yeah, and I'm like, I'll just double it. Just for whatever reason, you just double it with this one. Like, there's just so many ways to get to 120 on this one. It's kind of fucking shitty. It's fraught with difficulty for the sequence because it's like the sequence can be multiple different sequences, right? But it's like I want it to end with the fucking multiplication of the 5 times 2, right? Which is multiplication of 10. So you have to multiply by 10, which then just means they'll just start with base 2 and they'll just multiply it by the 10, which is, but then you can't do that. Yeah, that's the problem. Right? So it's like, well, I need to multiply by 10. So how do I get it? And it needs to get to 12. So it's like, then I'll just fucking say, oh yeah, multiply 4 by 3 and then multiply 5 times 2. And then that'll work. But that's basically literally what the end of the 2 is doing for you. That explains why that sequence is somewhat in there. Right? You're always multiplying it by 2 at the end. And you always multiply by 3 at the end. So we're basically just understanding how factorials work from a center out approach. Hi! How's it going? Did I get you there? Hey, remember that center out approach? And a certain what was that? What was that HBO series? What was that HBO series? They had a Hooli, I think it was. There was like some fucking Pied Piper thing going on. Like a good old center out approach. Yeah, we haven't actually touched on a real sequence, although we kind of have, but it's like also that's just because I was going to get you to the center out approach. But it was like, oh yeah, no, but it's seemingly like every time a 360, I could just use a 360 of 50/40 or a 55/440. Like it's always there the moment I add in a single like couple 360s. You know what I mean? Like, it always narrows it down to exactingly this sequence. That means I can break it out to that sequence every time. Which is great, but also at the same time kind of difficult. There's always a pattern that you always have to know. Multiplication tables. Anyways, it's almost like it's possible to fucking do this. Like I said at the start of this, oh my god, it's been over 7.5 hours long. Yes, this is a wonderful teaching. It's a 6 hour with elementary school, one teacher. That's all you get. Anyways, we're gonna move on. It's like, all right, so like 6 would be basically the same thing, right? Is you start off with 3 and 2, and you do 6, right? But it's like you can't. You have to start off with a singular base number. right? But then it's like, because it's 6, then you just go like it's 720, right? Right. That's kind of the problem. You know what I mean? That's factorials for you. So, anyways, but it'd be 720, right? And that means you need to know two. You can do a sequence, right? It's like, well, you want to multiply it by 2 at the end, which is what we're really doing, aren't we? Yeah, but we're also compressing that. That's the thing, right? Because it's like 4 times is that's 12. Remember that one? 7's a prime number, 5's a prime number. 5 times 1, 7 times 1, always seeming a prime number that's always seemingly there, that you can start with and go from there. And you can always use a sequence of these two numbers, either doubled or tripled or otherwise, and get to the fucking final number. Bahingo! He's got it! This guy's got it finally. Bahingo. That's right. Bahingo. That's right. You didn't understand that I got you there. You didn't know. But now you know. It doesn't matter how many factorials there are, the primes will always work out to being, you have to kind of use those numbers, and then you just kind of double or triple any of the other numbers. And then you'll get to a fucking factorial number way faster. That's effectively what the long-winded explanation of this is. So you knew, kind of. I mean, it's pretty interesting that the fucking 50-40 and everything else is there, like for what it's worth. But that's because there's like certain prime numbers that are really, really interesting, that are involved in factorials, that are incredibly necessary to breaking encryption, but also breaking factorials down incredibly fast. It's almost like I'm trying to teach you how to do something that I'm not supposed to teach you how to do. No! Shut up over there. You. Yeah, be gone with your fucking stupid. I will destroy all of your encryption. All of the people over 7 hours and 40 minutes, they're gonna fucking get to this point. I'm sure Googie's just fucking floored right now. Anyways, we'll figure it out. Like, well, the sequence is still there, like for what it's worth, and it's definitely gonna work every single time with a 360. But it's like the base number is always gonna be this weird fucking like kind of number, because like you start with 3, right? But it's like you wouldn't just end it with 3, because like you have 12, so 3 times 12, right, is 36, right? But then it's like, right, except you know that like 5 times 2 is 10, right? Because you already have that. So that means you can do 6 times 10, which is 60. See the breakdown? Anyways, so since let's get out the calculator. So if you do, so you do 12, base 12, so 2 times 12. So now you'd want to do 3 times 12, which is 36. And then you can do that with 10, so that's 360, right? There's a 5 times 2, right? And then that means you know that, well, the base number, common denominator is 2, so you just multiply it by 2, it should get you the number. This is really fast. And that's the sequence. Then you just go like base number, common denominator, and then you go, oh, right, then it'd be 5 times 2, and then you do 12, which is a number of order of like sequential number, right? Right. And then that's 6 times 2, right? Which gives you an immediate, oh, it's 12 times 3 times 10, which then means it only leaves you with the 2 left over, really, kind of, for the common denominator that you have to use, right? And that's the step stuff. So you get to 720. But like 7 would be basically kind of a similar story on that side, because you'd go like, all right, so you have to go with primes first to get rid of them, which is what the sequence is. So it's like you have to do 3 and 7, but you have to do 14. So you have to do, you can start off with 14, and you multiply it by 3. No, you can't do 3. So you do 3 and 2. right? This is 84. Hey, that's the fucking 42 number. Yeah, well, yeah, no, but see, yeah, I don't really want to do that one. But let's just continue it just in case. You never know. That's okay, fine. Fine, we'll do that. Right? So we know that it's 14, which is the total number, right? Which we already used, right? But then it's like we also know that like 7 hasn't really actually been used, and neither has 5 or 6. And we can do 7, 5, 6, which would not give you the number that you're looking for. Correct. All right, so 6, which is the only number that you have really left, which is fucking phenomenal. Yeah, which is 504. Shocker that that number keeps coming up somehow in prime numbers that are always going to have some of these numbers that are always going to show up. So, anyways, but it's like, right, you have 15, and then, well, okay, so wait. This is factorial 7. Yeah, well, I mean, you can start with 7, but like you're doing 7 times 2, so 7 times 2 is just 14, which means you immediately do times the 14 times 3, which is 42, which will give you times 6, which would then give you times, yeah, but I don't want to do that. I liked it better the way I did it. So it's like, you can do 7 times 2, right? But then you can do the 14, which is 196, which is actually pretty fucking close to like you being used. So you do 3 times 2, which is so close, man. It won't work though. Like we're not doing the sequence properly, right? Yeah, because you have to start with the base number. So base number of 2, then you have to multiply that by the whatever number that is, right? That you're going to go with for your first number, right? So does this end up remembering as like 28? Pretty much. Yeah, and then you'll just multiply that by 7, which is so fucking close. And 68, 50, and just the sequence. 84. Well, there you go. So, hey, well, right? It's 14 to, okay. Wait. You start with the 2, right? And you just multiply, and, you know, right? You just multiply 14 by 2, because that's what you'd be doing, right? Which gives you 84. Which then means you understand that you could like just multiply that by like fucking, oh man. It's a fucking 6. Right? But it's like because common denominator and 5 is left over, you understand that you can use common denominator and 5 left over to multiply by 10, which gives you the number. It's common denominator and then like the multiply by 10 because it's 5. Common denominator of 5 and 10, right? Or common denominator, the number that they both use. Exactly. So it's like kind of the same thing for 8, which would be 4320. So 4320 is going to be another same thing where you do the 16 times 2, which is 32. And then you do, right, because you started with the first number. So, right, but then like you got to the 2, which is still the common denominator of 2 for this. So then you do divide, no, you have to multiply by the next number in the sequence, which would be 7, right? Which is what I did with the 6. Okay. Seems to work with the 4 too, and the fucking factorial 4, but like you'd remember it differently. Anyways, and then that means you could then do. Hmm. Well, but it is by 6. Never really used that 3, did I? 762? No. 672. 672, right? 5. So then you'd have to remember that it's going backwards, but then it's like you don't want to go that far back. So it's like the common denominator of one of these numbers that is a prime number will get you there pretty fucking fast. So let's do the 40, what is that? 40, 32. 0, which is going to now be divided by 224, which is 180, which means you can use 3 and the 14 as a common denominator, well, for the remainder of those numbers. This is 180, which would be a common number that's divided by 180. So we have 4, 5, so 2 and 3 would be those primes that we could use, and we divide by 3, which would be 60, or we can divide by 5, which would be 36, and by 2, which would be 90. So you can always work out a 90, well, let me see here. We're going to be using 16. So it'd be 16 times 2 times 2 is 32, and then you'd be able to use 32 with 7, which is 224. 224, it's 180. So that'd mean you could use the common denominator, but you could also use the 16, right? Because you can divide that by 16, which would give you 14, which would be just a doubling of the first number in the sequence, or the next number in the sequence of a factorial of 8. And it would work every time. So you do 16 times 2, and then be multiplying by 7, which is basically at the larger factorial we're doing. I mean, literally, yeah, it is. And then you then multiply by the number freaking. I know, right? All right. So 224, and then it has to be with 180, which we were like, oh yeah, no. 224 is divisible by fucking 7. Right, so you do 7, right, and 32, but that would mean it's not doing 7, so you do, so you take that number, you keep it over there for 224, and then you go 7 times fucking, one of the previous numbers, or 6, which we haven't gotten to, and 8 for the original, or the doubling is what I was talking about. This would be 16, so we could use 8 as a double again. So 8 as a double again, which is what we did before. We actually did a double before in one of the other previous factorials. So, wait, what? Yeah, we did. So fucking 32. So be 32, and then you'd use, see here, 32 times, what the fuck was that again? The 7, right? And then you multiply by 32, or not 32. Right, excuse me. 180. All right, give me a second. Kind of a little confused. Yeah, but that is by 7, 8, 6, yeah, 5, 3, 2, 4. He's in a bunch of them. That's true. And then we were thinking about the sequential number. Oh, that's what it was. It was 16. So I could divide that by 16, or 8. No. 16 would be fine. Yeah, right. So 16 for the 180, which is what we're going to be focused on, because we have the 16, but we have 180. But it's like we have 224 already as an established number, right? But that's a sequential because it'd be 6, right? All right. All right. So this one's annoying. You'd start off with like, all right, so you start your 32, right? Right, and then you double it to like 64, I suppose. It's like you could do just exactly that. This would be 40, 30, 20. and you divide that by 64, which would be 630, which is a direct number divisible by 7, which is 90. Right? And then that 90 is divisible as a number for all the rest of them, which would be a common denominator, but like they're probably not going to want to do that. I don't give a fuck what they want to do. I'm the one like trying to figure things out that's enjoying himself for what it's worth. It's like, go fuck yourself over there, bitch. I don't care. What are you gonna do? Anyways, so 90, and then the base number would be 2 or 5 or 3, maybe 30. Yeah, it's super simple to do that though, because base number 3 always seems to come out like on top on that one. So it's like, right, you do 64, then you multiply it by 7. You at all. The fuck? Anyways, so 64 immediately, but that's right. That's 16, and then you do it with the fucking other number, with the base number. Right. So you do 16, and then the base, and then the lowest common denominator, and then it's like, right, 630 divided by 7 is 90. So like you know that it's a 90 number because of the 70. You know the 7. Yeah. Anyways, so you have 7. See here. Which means you know that it's divisible by both 7 and 3, or one of the other primes. And so 63 divided by 7, and I forgot, is 9. Yeah. That means you know it'd be 3. So you do 64, because you already know about the sequence and the lowest common denominator. The lowest common denominator is already done, which means that you have to think about it as a factorial. No, not in any way. A 7 that is also needing. Remember that we were just doing that too, about the whole like we have to figure out the number for what this other number could be, right? So it was like, right. Well, we wouldn't multiply it by 3. We wouldn't multiply it by any of that. You don't need to. Like, could we multiply 7 by fucking 14? Is that gonna be a thing? Almost. Oh, jeez. So 7, it has to be a number like that. So you'd start with 5 times 2, which is 10. And then you just multiply that by 3. You don't need to remember the number before it, but that's the thing. Like, yeah, but it would be really easy to do that for what it's worth, because you could just fucking remember that 7 goes into 90. Right. But it's like you have to just make 7 turn into 90. It's like 90 divided by 7. 3, 2, 6, 5, 7. Doesn't work. But crazy. Right? But it's like, yeah, you don't. But you do have a number here, 2 and 3, which gives you 6. And you have a 5. So that's 30 immediately. Right? Which means you can probably remember. There's a way to do this. It's like factorial would be incredibly easy if I could just fucking get you to do like 16 times fucking 16 truthfully. Which would be, let's see here, 4320 divided by 256. Isn't quite right. Damn. Which would instead be 32, which would allow me to get that number. Right, you just add the two 16s together. Yeah. That's not gonna work. So maybe, let's see here. 4320 divided by, right, that's like 8 times 2 times the already there 16, which is 256. Right. And that means you immediately got 256. So you just need to divide any given number from the next sequence number, which would be what it is. It would be 4320, divided by the next sequence number, which would be 7. It's only 5,000. Yeah, no, but that's not going to be a thing. I'm not going to do that. That's what a lot of people would say, truthfully. So, there's 256, though. I know, right? I need pee. Give me a second. All right, I didn't pause that. You're gonna hear me. You're gonna hear me. Hear me. Hear me. That's what this is about, by the way. Like 7 clearly shows off that primes have a profound impact on how it is that it changes, like the sequence. Like 7 immediately adds in a fucking prime rule. You have to remember that there's a prime rule. So it's like that would turn it into instead. It'd be like, well, 7 has to be a fucking number that has to go with the fucking 3, which would then mean you just have to figure out the lowest common denominator between the two, which are both prime. Since they're both prime, that means you can figure out that it's most likely going to be one of those numbers that you can come up with. It's like 90 divided by 7 doesn't really work, but 90 divided by 3 does, right? And like that's the problem. And so like you wouldn't use that number, but like 7 would definitely fucking work. And so it's like 7 is 16. So it'd be 8 times 2 times 16, which is 256, which is 16 times 16. Yeah, right. Then you can see here, freaking 320 divided by 256 and 575. So you can't do that, but you can do it by 7. You can certainly do it by other numbers too. Let's say, so 256 could be multiplied by 8, 3, freaking, I don't want to do any of that. I want to get rid of the 256. 256 is a dumb number to use. 8 times 2, which would not work the way I would want it to. So it's like, we're going to use that. So we have to start off as a fucking 6 because we have 3 times 2. We have to start off with a, then to fucking 5, 6 times 30. It should be 180. Yeah, this is what you need. Yep. 2 times 3, right? 2 times 3. And then you 2 times, maybe 6 times 5 times 6, which would be 180, right? And then like you do times the 180. So, which we were using before for what it's worth. I think that was for another number. Yeah, that was 5040. Right. This is 4320. So 4320 then means I can use a 75. Use a 16. Right. And then times by 8. 2340. Already there. Right. I just have to multiply by the lowest common denominator. This isn't really the case. Looks like. So close. Yeah. So let me give me that number back. So 4320 divided by 180, which is 224, which was the number that we were trying to get for the 7, which is 32. So okay, so that's what that is. So you'd multiply 2 times 3, which would get you 6, which would, like you basically just go to 180. So like we said a little earlier, and then you go, all right, so that 180, and then you have to do multiplied by, what was it, the fucking 16 or whatever, right? So the fucking, so 32, so you do the 8 times 2 plus 16, which would be 32, so you multiply by 32. This is what that would be, except that's 32, that's not quite what we're looking for, so 224 divided by 32 is 7. right, the next number in the sequence of the factorial. That's what it was. Good. You do 2 times 3. You do that times 5 times 6, and it just gets you 180. So you immediately just get 180. And then you would do that times, let's see, 32, which is what you're looking for. Then you have to then multiply it by the 7, which gives you the exact number on the last sequence. So there you go. That starts kicking off when that fucking 7 comes in, man. Like it's a real rough factorial start. Anyways, I'm gonna finish this later. Actually, turns out there is gonna be a part 2. I hinted and primed the shit out of you. Deal with it. Yes. My dog needs to go out. I haven't eaten. I'm tired. It's 8 hours of doing this, of hard math labor. And all right, bye.